Hello, today we're gonna do something crazy and push our limits and study lead code for a long time. For a very long time. I will try my best and we're gonna continue with this problem. Yesterday, um, we solved this problem, like I said, matrix zeros and happy number, and that's all basically in the previous stream. So today now our plan is to solve a question 44, maybe up until to question 30. So let's hope the best. All right, we have like a 1dp problem, like dynamic programming. We have tree problem, again tree, graph, one greedy, another dynamic programming question, which is awesome, right? Another dp problem. Like, I have solved this question tons of times previously, but I'll try my best. And balance bind, like another three question. Linked list pro, like this question is quite special for me. All right. Let me check the stream here as well. So like this question is quite special for me. All right, because after understanding this question, I realized that I learned um, recursion basically. All right, sound seems good. We are live. We have our light. Everything seems just fine. So, and let's see what other questions we have. A backtracking problem. All right. I think it is not a question but a note. And midpoint of linked list. That's understandable. Another graph problem we have. Lemonade chain, like this is a greedy problem that I've seen during interviews actually. You may ask, have you solved it fast and correctly? My answer would be no, actually. Actually yes, I have solved it actually. But after the interview, I look at this and I studied it again and I realized, like this is a greedy problem. Because for brute force algorithm, like brute force technique and greedy techniques, i like I thought they were something like unnecessary or quite basic, but they are not. And question 30 is a knapsack. Like, I studied this question a lot, multiple times, and I will try solving it without looking at the without getting any help basically. Let me open from here as well. I guess we can go like beyond, even beyond 30. Question 29 is another tree prop. Like, actually during interviews I haven't seen trees a lot, but it is a topic where you can practice your understanding of recursion. And for example, even in heap sort or heap data structure, we use trees, all right? So like I see three topic as a playground for uh, practicing recursion basically. All right, everything seems good. So binary tree diameter. All right, maybe we can go beyond question 30 and try solving. K sum subarray. So actually we, like, in one of our stream we practice prefix sum. So maybe we can try solving this question. And heap sort. All right, so we have studied this. Loop detection. Actually, we, like in previous stream, we applied this flow cycle to another question, not without using linked list and cadence auto. So all right, so like beyond this, I have studied very much. All right, all right. So let's go to question 40. Not 40. Yes, 44. So um, I think everything is set up correctly. Let me set the task. task is question 44. Yes, let's set it. Yes, as I expected, the daemon is not working. No. Yes, it doesn't work. So let me fix it real quick. While I'm doing that, maybe I can open you guys an animation for heap sort. Let me open this one here. Like maybe I can open it in Reveal in Finder. Like I wanna create a loop. Right? Yes, this is here. Like is there a loop version, like a loop option here? I haven't tried it. View playback speed here. I guess loop. Yes, wonderful, amazing. So you can guys watch the build phase of heap sort. Like first phase is like first step is building, and then the second is extracting. All right, and the core atomic part is sift down. Let's click on it and let me fix the actually I think I should open the project file here, and then I can open this. All right, just give me a sec. Hello again, guys. I am back. I restarted it, so let's stop this video and actually let's close these sessions too because they require some RAM. All right, so let's start another class session and let's tell AI what is our goal today. Our goal for today is to study this problem, activate tutor mode to skill And let's start with the core part of this question. All right. And also, it would be a good idea to open leetcode. Let me open it as well. So maybe actually it is right there. So leetcode, there is some, I think. So this is the question we're gonna solve. I see a list of lists, so like I'm not quite familiar with this syntax, but I will try to learn deeply, let me say. So first, let's paste the question here, and maybe I can clear a couple of tabs, like a Chrome tabs, to make my PC faster. All right. So this is the question we have today. And we have our notebook. So let's start with understanding list of list, all right? Like first, let's create a list. Like this is a list, all right, list of integers. And the parameter there was something like this, right? 1, 2, 3, and then another list, and then another list, and we close the so the syntax for creating this is like this list is like list of integer and close it again, and a name and then equal sign, and then we are gonna use like a new keyword. But what should we write on this part? The same thing or just the array list? Like we should look at it. And one important thing about this array list is like if you have, let's say 1, 2, 3, and like let's say you add 0 there, so this part basically moves, right? All right. So basically the index of 1 was 0, and after you add, let's say, another element to the beginning, and now its index becomes 1. So that's a good thing about this array list. I have learned it recently. Let's see what AI says. Though you have did it, all right. Which parts of some do you already feel confident about? So basically, actually, let me read the question. So the first step to solve this should be reading the question, all right? So we have given an integer array nouns to turn all right, I know this. Like another version of this question is twosome, I think. And by the way, let me set the task over here. Task is solving threesome problem. Yes, now it is working. And also, like, without diving into the leetcode, let me ask a question to my another class session where I handled the OBS. Thank you, it is amazing. Now, like, I started streaming, and like CPU usage is looking good, but my fan of my computer is again started running. Like without breaking anything, can you check our OBS setup to see what might be causing this? because I don't want to hear the fan of my computer, and I don't want it to get hot, you know. All right. So we have this question. Sorry. Oh my god. I turned the wrong thing off. Sorry guys. Sorry for your ears. Um so let me draw the like triplets. Like let's understand the question better. So we have array of integers, list of integers. What we need to do is find three elements that sums to certain points. So let's start with two sum. All right. So in two sum, our goal was like picking, like finding two pointers, like two numbers that their sum is equal to certain number. So for this purpose, like we need to sort this array, right? Because if you have random, like if your array is random, like in random order, you cannot build on top of like imagine you have a like a you need to build a building, all right? So you need a solid, you know, foundation that you can add other bricks on top of each other, all right? So the foundation here is like having a sorted input, because when you have something sorted, as you go right, you can expect that the numbers will increase, and as you go left from, you know, right to left, the the numbers you'll see is gonna be decreasing. So based on this assumption, you can create a logic. This is quite important. And also yesterday there was another thing that I thought like first is like a sorting, and then there was another operation that you can use. Maybe I can remember later, but first let me check it actually. Was it like heap sort or happy number? I don't know, maybe picking correct data structure. Like I should have written that, man. Let's open our notes actually. Do we have something here? Generics need a reference type. All right. Yesterday we studied reference type. I guess I won't be able to remember it, so next time I will write it. So basically, for the questions, all right, most of the time like a greedy problems, or it can be anything. But if you don't have any option, if you don't have anything in mind, let's start with sorting, because sorting helps you build a logic, all right? So if we have like you sort this array, and I would start one pointer from here, and then the next one like at the end, maybe, I don't know, but in here, like in three some question, you have three pointers. All right. So like I solved this problem before, so like maybe another thing is like a sorting or changing or framing, or even better, reframing the question. Maybe it was this. So like these two approaches, two processes, two styles are quite important. One is sorting, one is reframing, because for example, you know how to solve two sum question, all right? And you can transform this question into the two sum and solve it that way, because in two sum like we have like a we have sorted the array. We put our one pointer left and the another on the right, and you basically sum these two, all right, after sorting obviously. If the number you find is, let's say, greater than your expected result, like that certain number, all right, if it is bigger, you should make it smaller, so that you should move that this pointer to the left. If you find a smaller number than your expected, like a certain number, you move this pointer to the middle, like an inward. All right. So now, like, the another thing we're gonna do is like a transforming this like a 3-sum question into 2-sum so question, basically, and this will help us. But you may say, how? Let's say we have two, like a three pointers, and our goal is to find k. Let's say k, all right, or let's say 10. Seeing a number feels me like makes me feel better, like 10. And our goal now is like to find, let's say, like if you want to transform this into 2-sum, we can try finding this, like this is our certain number or expected number or our goal, let's say goal, all right. We can try to find this number, and then again our goal would be like a sorting the array and then positioning one pointer over here and one pointer over there. And like, is this it? Like, will it solve our problem completely? Oh, I should update not 5 but I think 12, right? Let's copy. Let's update the title. All right. So we sorted the array, we positioned our pointers, then I guess we are done, right? Let's open the app I have here. That would be great if I have a save button or something like that. I think I can just take a screenshot of this code, and like, this was, which question it was? I think this. Let's paste it over here and then open our question again, and then we can delete the code we have from yesterday without worrying. And now our goal is like, type this code, let's say function func a, let me say, all right. And our goal is like a sorting there. But what was our input? Let me open. All right, so the input is like a areas of integers, so nothing more than that. So we have integer array of, like an integer array. So we need 2 pointers, like a pointer a start from 0 and another pointer starting from 0, All right. Like we need to sort the array, so for sorting we can use arrays dot sort, I think, uh, and give the array right away, I think. So there was some method for sorting the array, like in the increasing order or like ascending order or the descending order. We can look this up too. All right. So let's say we sort the array in ascending order. And now, like most probably, I will need a for loop over here. And like let's say we have ascending order array. I guess I need to position the second pointer at the end. Let's position it. Let's r dot length. I think this is correct. Uh, so we will like we need to sum these up, and also like our where is our goal, like where is our k value? Oh, we don't have k value, but the k value is basically 0. All right, so if it is 0, then we move this part to the right of the right side of the equation. So our goal will be like I said, our k value was 10 here, but it is not 10, but it's at 0. So our goal becomes minus z. So we're gonna try finding that value. So where is our z value? We don't know it. That's the idea, like that's the good part of this question. I think we don't know it. Like what we need to find is finding three numbers that they add up to 0. If you move that number to right of the equation, our goal becomes like this is interesting. This is interesting. Like we don't know this basically. Actually, it can be any number, or I don't know. Like we don't know what our goal is. So how on earth we are supposed to find it? Because the only thing I remember was like remove like a moving z over the right side. Um, so I moved it, but now we don't we don't know this. Let's create an array, all right? Let's say we have this, and let's say this is x and this is y, but I should pick z as well. I should pick z as well. Like would it like is it gonna be like a single or static value, or I will first pick, let's say, this, and then run our algorithm, and then in the next iteration I will pick z value as 4, and then run our algorithm, and then maybe 5, and then maybe 2, and then maybe 1. Maybe I should do it. So maybe in one for loop, like a starting from 0, let's say z equals r, let's say ri. All right, we picked it, and in the next for loop we should like using 2 pointers, like we should sort the array, obviously. All right, like let's assume our array is already sorted. All right, Like, and we picked z as the first element, all right. And in another for loop, like we should pick like a x and y and move them inwards, since our like a this is this is the logic we can build. Basically, this is the logic we can build. And also, maybe let me update the title. Lead coding for Ralph R. But like the next like the question now, the next question now is like where we are gonna position that x and y. Like, since we picked the first this element, maybe we should start x from I plus 1. Let's say we have an array, we set z to that, and the remaining part that we should solve is this, all right. And then in the next iteration, we're gonna, let's say, not this one, I mean, like we're gonna set z this, and we're gonna set x over here, I think, right? Like, but in this case, are we saying that we are not gonna think about this part at all? Because we have this is the question, this is the proof we need to answer. For example, yesterday, in I think in happy number question, I think the proof we had was the proof we had was, let me think, because here in this question we had a proof too. Like, the proof was something like this, alright? Because let's say you have number 1000 and up to 9999, so the digit sum of these numbers are between 0 and 324, all right? So that it is guaranteed that there will be reoccurrences. All right? Because I asked that, how do we know that we're gonna, maybe there will be a number that when we try to calculate its digit, like a digit square sum, maybe it will be so unique, and we can go, what sort of welcome in Americano base. um like, I don't know, bro. Like, I am also trying to understand like a lead code problems, but this is intercourse, like a intercourse of like a math and coding, all right. And coding is hard, and math is hard, and the lead code is over here, all right. And this is lead code, and what we are doing right now is, imagine you have an array of numbers, let's say 1 2 3 4, and let's say 5. The question asks, find three indices, three indices, I mean xyz, all right, xyz. And if you sum the value at those indices, all right, their value should add up to 0. And it asks that find those indices. For example, first indices, let's say it is 0 and this number, like here in this example, there is no combination of numbers that can add up to 0. But let's say this is minus 3. So if you sum this one and this one and this one, they will add up to 0. And what should you return is like a in this 0, 1 and 2. So this is the answer. So there are some like the previous version of this question was 2 sum, and this question we are solving now is 3 sum. All right, so basically we transform our problem into this one. And even beyond this, like there is one more foundational step for solving this question, which is if you have like numbers in random order, all right, to like you should start with first sorting these numbers, all right, because without sorting you have no chance, like you have zero chance to build any logic. Because if you sort these random array, all right, let's say you sorted at -1, 3 and 5 and 9, like this is quite crucial, all right. If you have a sorted array and let's say you start from here, and if you go to right, you can expect that the next number you're gonna see will be bigger than the previous one. And if you start, let's say from here and go to here, like inward, what you can expect is, you guessed it right, the number you'll see will be, you know, smaller than the number you had. So like if you have a sorted array, you can build a logic. So like the problem we are solving is just like an implementation of this, all right, Americana beans. So and what I have tried is like I turned this problem into 2 sums, and now I have x and y. Now I was thinking about the subset, because I set z0, like z to this one, and then our subset will be here, and we're gonna apply 2 sum here. And then I was thinking what would happen after this, like after solving this subset. So you have to make a program that lists all x, y, and z's that can make 0. Yes, their summation. Or find a way to make the x, y, z you are given to. Actually, our goal is finding a combination of those indices that their values will add up to 0. So what I mean is like the value at index x plus the value at index y plus a value at index z will be 0. All right. And the question asks, what is these numbers? Like these are indices in the array. So let's say you have an array, let's say 5 minus 2, 3 minus 10, and maybe 6. I don't know, minus 6. Yes. So the indices here is let's say -3, all right, it will be better. So if you pick this as x and this as y and this as z, because their value like this are even, let me write even better, r0 plus r1 plus r0, 1, 2, 3, 4, r4 is 0, right? Like this number, and this number. If you sum these up, you're gonna see like you'll end up with 0. So the answer is x equals 0, y equals 1, y, and z equals 4. So the question asks, finding these numbers. Pardon me for my ignorance. I just started my that is just fine. If you just started your first year and if you solve these lead code problems, you're gonna be like a CEO, all right, in a company when you just graduate. Because I started solving these lead code problems at my third year at uni, and I failed at understanding these questions for almost 1.5 or maybe even 2 years. All right, for 2 years I didn't understand. It's like I of course understand some part, but I didn't understand recursion. All right, I didn't understand backtracking. All right, to backtracking, I didn't understand trees, I didn't understand DP problems and graph problem, because all of these are for like these are the hard topics. All right, and you should know. And if you don't like internalize, if you didn't internalize the recursion, you have no chance understanding these topics. All right, you have zero chance. And I struggle with understanding, these problems for 2 years. All right, and then I read a book, and there it said that your approach is wrong, and for understanding recursion you should this approach. And then I started understanding. But if you are at in first year, so you are so lucky. Oh, so you are given a set of numbers, yes. Then the program has to identify which numbers to replace xyz as, so that the result is 0. So xyz values are just the array ID. Yes, array indices. Yes. So let me show you this. Actually, let me copy this one. All right. You know that array has indices, right? Indexes. So let me even remove that part. Like this is index 0, this is 1, this is 2, this is 3, and this is 4. Like these are indices. And the question asks which indices. So the question is basically this, all right? The question is this. You can open this problem on leetcode as well. It is another version of twosome. So what I was doing is like I transformed this question into twosome. I started my z value at, like, in a for loop. I started my z value from 0 to the end of, maybe not end of, but maybe 2 before that. We're gonna think about it. I set my z to the first element. All right, and then now what I do is like setting my x and y pointers and moving them inward in this subset, like in this area. Like I set my 0, this is the first element, and I apply twosome in this subset. And what I was thinking is like, what will happen after this after completion of this iteration? I mean, after the first iteration of this for loop, what should I do? Maybe I just need to start coding and then see what we need. All right, so we have a sorted array. All right, like this starts from 0, obviously, and then we're gonna have like another for loop, and let's call it j. All right, now our goal is like moving x and y inward. But first, of course, I need to set y to the, like, I need to start y from the end. Maybe for each iteration I should, like, maybe actually, like, we have b here, or maybe I should call this x and this y, and maybe even better, in each iteration we should set y to the end. So we're gonna move y from rightmost side to inwards, all right? But the position where we start x is not is not gonna be 0, but instead um I plus 1, all right? So what we do is, like, let me draw it. What we do is, like, we have an array, we are setting z to this number, and we set y to like the rightmost, and x to like a +1, all right? Like, now we are solving this basically. um and now what are we gonna do? Like, we should apply to sum over here basically. And what does to sum? I think we should try, like, we can have an if statement over here, and if the value at index I, like, I can make it even z, all right, to understand it better. Let's make this variable z, all right, and let's make it z2. So if the value at index z, so like our formula is basically like, if the value at index z is equal to, no, actually minus version of this will, if it is equal to the value at x plus the value at index y. So we should check this. Let me take this one, and if it is equal to summation of actually instead, maybe even better, I can make this x2, all right, and maybe I can even remove that x. So the value at x plus the value at index y. So if their summation is equal to, like, equal to the, negation of the value at index z, then we can return, I guess, true or something. And to be able to return true, our array, like our function, should return boolean. And yes, so we sort our array so that we can build our logic, all right, because going inward will help us to find what we are looking for. So as we go inward, we can expect if we are getting closer to what we are looking for. What we are looking for is this value. Wonderful. If so, like, this is like, this is z, so we set z, and we start, like, we start x from the point 1 forward, 1 index later of z, and we start y here. So actually, instead of checking if we, like, if we get it, it is wonderful. But if we don't get it, now we maybe we should, actually, maybe I need else if. Like, this part is crucial. We have else if, like, we need to check, like, we need to understand if we should go, like, if we, like, whether we should move x or y. We should understand this, all right? Because moving x will increase this summation, and moving y will decrease the summation. So maybe I should calculate the summation over here, all right, because I will use it a couple of times, and put some here. Wonderful. So if it is equal to some, like, actually we shouldn't return the true, but the indices. Maybe I can, maybe I can create an integer, like a result, right? And maybe I like new integer 3, all right? And maybe we can add, you know, result 0 to our, you know, x value. Like we should store these indices. Result 1 to y, and result 2 to value z. And also, by the way, let me update the title. Current problem is 3 sum. All right. This seems good. So if our summation is equal to z, then we should store these indices. But if the summation we find, let me check this again. Today we continue from, actually I can remove it too, right? Let me update the title again. Set ticker. I guess it will be better. All right. So if the summation is bigger than the value, I mean, like, should we use the negative, or like, if it is smaller than the value at z, or even maybe we should use minus sign too. Like, if it is smaller than what we are looking for, like, we should increase. To increase, like, move x inward, right? We should move. But if the summation is bigger than what we are looking for, if the summation is bigger than what we are looking for, I mean, sorry for dictation. If the summation is bigger than what we are looking for, basically, we should decrease it. So we should move y inward. Move y inward. But we are using a for loop. I guess we should, you know, use a while loop for that. Let me check if the title is all right. Maybe we should switch to while loop. Let's make it while loop. Like in this for loop, maybe we can set x as z plus 1, all right? Like z plus 1, this is x. And we can set y. Yeah, so we already setting y here. We are starting y from the end. Wonderful. I think while x smaller than y, we can continue, like, we can continue iterating. If the summation is equal, everything is good. We stored, like, we are storing those indices. If the summation is smaller, we should increase x, hoping that we are gonna find like a bigger one, because we sorted the array, and as we go inward, like as we move x to the right, we're gonna see bigger numbers, so our summation will increase. So we basically move x, I mean by 1, and if the summation is bigger, so we should move y inward, all right, so that we find smaller numbers. And like I think this solution is just fine, but what I am afraid of is, like, after the first iteration, z will be 1, all right, so we handle that spot, all right, and then z is over here now, and x should start from here, and again y should start over here, and they should go inward basically. Wonderful. But like, can we forget about this part and like a process only this? Most probably yes, but I want a proof of that. But for the sake of time, let's continue. All right. Like, this seems legit, so maybe I can give this to AI and let it judge it. We sorted the array, we start from 0, we set x, z plus 1. Like, we should have some guard too, like we should add some guards. What is the hidden box before z mean? Oh, like, you asked a wonderful question. Like, this is like we have this for loop, right? And after the first iteration, we completed, like, we moved z to here, right? And now the problem we are solving is like here, so we moved by 1 actually, so we processed this part. The meaning is this, meaning that z is now 1, because it was 0 here, all right, z was 0 here, we process, we find, or we didn't find to some, or like a x and y values. If we have find it, we store those numbers. If we don't find, we go iterate, we move z 1 right, all right, and then we are going to continue. So because in the even next iteration, what we are going to do is like in the second, like when the z is equal to 0, like is to 1 to 2, all right, like let me type it. So we completed that slot, we completed that slot 2, like, and z is now here, so z is equal to 2, and x like will be here, and y will be here. So these are slots, all right, that we have completed. And this is this part. Is it clear, Americano? I think I can copy the code and give it to AI and let it judge. Like, this code suffers some guarding because it can be out of bounds, all right, or maybe I should limit how far z goes. It is not length, but length minus 2, I guess, because we have 2 pointers, I mean x and y. Okay, got it. Wonderful, wonderful, mate. All right. Like maybe before asking AI, if you have any questions, I can answer. Like like this won't work, but almost complete. Like the main structure is completed now. Like we have a for loop, and we are setting z, and we are setting x based on like one more of z value. All right, like here, and we set y from at the end, and we get their summation and check if it is equal to value at z or not, and a minus version of it. If it is equal, then we have found our answer. Like our indices are these. If we don't find, and then there is two options. Summation can be smaller than what we are looking for. Like this is what we are looking for, all right? Like this is what we are looking for. If the summation we get is less than what we are looking for, like smaller, if it is smaller, we should increase the summation. And to increase the summation, we should move x to the right, all right? We should move x to the right. Because since it is sorted, when you move x to here, it will be more than the previous number, all right? We move x by 1 inward, and if the summation is bigger, we move y to inward, like to left. Like if the summation is big, all right, we move y here, like to the left, inward, all right. I think code seems legit, except the guards and some edge cases. Like one edge case, like we add this part so that we don't like the extreme case, like the farthest way that z can go is like here, like z, and here there can be x and y, like, all right. So this is how far that z can go, all right. And we can describe this location as like a length -2, and if we make it even smaller than that, z can go up until here, and we can set x again by adding 1, and we can set y to the end. Then we can run this while loop once, and then based on these conditions we can either increase x or decrease y, and in both cases they will be same, all right. So this while loop will terminate and stop. Like this seems legit. So let's give it a try, or maybe we can copy the code, all right. Yes, and open leetcode. Actually this returns list of lists, so instead of saving like that, instead of creating an array, I can create maybe I don't know, maybe like this, the answer, all right. I don't know what to type here, but let's type it this one. Or it was array list, I if I remember correctly. Yes, because in Java, like you don't have to type the type, like you don't have to write the type again on the initialization part again. This is the type, this is the implementation, and this is generic thing. We don't see it, but we have this part here inside of it. Anyway, we have answers, so we should add these to list of integers. Oh, and also another part is there is not only one answer, like there is no one triplet. So another keyword is triplet, all right. Like we are looking for triplets, so there can be multiple triplets, or I don't know. So what should we do is, like, I should create a list and add that list into answer. So first I should create a list. So how can I uh like list of integers? So maybe like this, let's say temp and new array list. I think like this, all right. And I should add like a index of x, right, and index or y, and index of z, and after that add this list to answer. So to answer list, so add this list, and we shouldn't return true or break the loop because there can be multiple lists. So we create array list, we add our indices there, and we add that list to our answer when we find our triplet. Wonderful. And we do this. Like, this seems legit, all right. And maybe our method should, like, our method is returning not boolean anymore, but that one. And after the for loop, we should return what? That list, right? Like, I mean, return that answer list. Um, Wonderful. Like, now it is better. Like, it looks better, right? Let's copy the code. Let's open leetcode and paste it over here. And are you ready, guys? We're gonna see some red red result, all right? Because at first try it doesn't work, all right? Um, like 3 sum. So maybe I should change the function name to this, and yes, public. Yeah, let's give it a try, guys. Are you ready? I'm ready. Like, yes, compile error. Yes, so I should fix it. That, like, this doesn't count, guys. Like, I don't want to type everything like this tedious parts. Yes, so we need like, this doesn't count too, guys. All right, forget about the compile errors. But the why we are getting error here, guys? Let me zoom in a little bit more. So I guess we didn't initialize x, so this doesn't count too, guys. This doesn't count. So, like, we initialize x. Let's see. uh, uh Another. So we didn't add the semicolon. Hold on, guys, hold on. We're gonna handle this. Oh my gosh. So yeah, we don't use result array anymore. Hang in there, guys. Like, forget about these compile errors. Like, now we are getting runtime errors. So this is a real error. All right, this is a real error. We need to fix this. It says array of bounds exception. So wonderful. So it seems that we need to be more careful about our x and y indexes. Uh, why? like like I hate these edge cases, but the another foundation, like another important point of these, like this type of questions, is like handling edge cases. All right, it's a skill. Because at first this seems quite legit, because we start our x from 0 and like z from 0, but maybe the size of array can be 1. All right, so maybe I can add add edge cases if the size of the array Like, because we imagine array as something like elements of, like, number of elements of our array is like, let's say 5, 10 of elements. But we didn't think that if the array is empty, or if it includes only one element. So if the length of the array is 1, uh, maybe return empty list, right? I don't know, new array list. Like, is it okay, guys? If the length is 1, or or where is or, guys? Yes, or length is 0. I don't know, like, is this good? Another runtime, like index 6 out of bounds for length 6. Oh, like our array is this, and our code is failing even with this, like a normal looking array. It shouldn't be like, like, if I remove that part, what were we getting? Like, let's cut that part. Again, let's execute the input. Open test case. Like, it doesn't try with an empty or length of 1 array. So, all right. So, like, we have a real issue here. We have a real issue. What do you say, Americano? What should we do here? Wait, what's case 2? Case 2 is like a 0, 1, 1, and like, this shouldn't be a problem. I mean, case 2 is like a 0, 1, 1. Case 1 is this. Like, are we failing at this case? What if it's an what if it's an error because, oh, yeah, no, negated 0 is 0, and 1 plus 1 not equal to 0. No, don't call yourself dumb, or like, you call yourself smart. Right? All right, so maybe, as you say, we should think about like z being 0. Maybe the 0 is edge case. Like, we have 0 here too. Like, our goal is finding this triplet that sums to 0, and we moved that part to right side of the equation, and we negated that index, and now our goal, like, I mean, like, we had x, y, z, and we moved z to, like, this, what we need to do, like, what we need to find is now like a negate version of z, and like, the real version is summation of values at indices x and y equals to negated version of z. So, like, this is correct. This is correct, but you are saying that, like, this beautiful number. Oh my god. How are we supposed to find this error? Like, this is important. Like, here it gives out of bounds exception, so we are going out of bound. Maybe, like, this is like, if we are going out of bounds exception, it means that we go like one further than we can go. Like, maybe we increase x by 1 again where we shouldn't. All right, or we should go like we went to left side, you know. There is two, like there are two possible ways. Like, is this wrong? Like, I take negation, but like this is what we are looking for. And if the summation, like if you are saying that if the value is 0, like negating it again 0, so this shouldn't be a problem, Americano. Like negate version of 0 is 0. So we are like, if the summation is smaller than 0, we should move x inward to the right. I think I see it, guys. Americano, I think I see it. Here, only condition we check is if x is smaller than y, right? Like we have an array, we have z something here and x and y, and so we move x here and y here, and when say like when they are on top of each other, we terminate our while loop. Wonderful. So if we are terminating our for loop when they are on top of each other, all right, like then it should mean x doesn't go, like cannot go beyond y, and y cannot go beyond x. So in that case, there should be no out of bounds exception. But again, so let's add another condition, all right? So let's make it even more robust. So while x smaller than y, and let's make it more robust, all right? And x is smaller than than this one, and y is bigger than 0. What do you say, Americano? Does it look better now? Without like before clicking at run button, I'm just wondering your ideas. Does it look better? What do you say? Because the only condition we had was x being smaller than y. Like this seems correct for me, for my eyes, to my eyes. But it says that you are like, we are getting out of bounds exception. All right. So we are strictly saying that x should be smaller than the last index. Even better. Not the last index, but even maybe 2. Because after that, there will be y. And y should be like larger than 0. I'm clicking on run button, Americano. Let's see. Let's see if we got it right. So I don't think so, but let's try. Another runtime error. Like index 6 out of bounds for length 6. Like the code has run that input, and I think we should ask this to AI, guys. Like even we explicitly say that x should be smaller than that one and y should be. So how on earth like we are getting out of bounds exception on this one? I think we should trace it. All right, so like another option is tracing, like putting this, all right, into our node and iterate. All right, so like this is a tedious job, guys. This is tedious job, but this is what we should do. So we have this, and we have our code over here, our beautiful, amazing, not working code, not working code over here, and like let's put it over there. So what we are doing is setting this, like setting our z value here, right? Like this is our z equals to 0. Yeah, and we are setting x over here, like we are setting x over here. Oh guys, the problem is here, come on. But yes, all right. So the problem is easier than I expected. So we cannot set y to array length but -1. Americano, come on, you should have set this. Yes. Now I think at least we're gonna see another error. And yes, memory limit exceeded. So I think instead of creating the temporary list again and again, understand less than 35. Like, come on, man, we can do this. Like, by the way, do you know Java? Or like, if you know Python, I can try typing this code using Python. Because if you are not familiar with the language, then the problem becomes even harder than it is supposed to be. So, are you familiar with Java or Python? We are wonderful. So you should understand this, mate. You should understand this. Come on. So instead of creating, like initializing a list here, let's create it over here and use it. Still on generics though. Like generics topic is, I suppose, in the last phase. So you are familiar with loops, right? For loops. You are familiar with while loops. You are familiar with arrays, array indices, I suppose, right? Actually, I'm not familiar with the generics that much. Like only thing I know about generics is let's say, I don't know, man. I'm not familiar with generics at all. Like there is something like this, and let's call it car. Like there is a car class, like let's make it capital. Car class, like we use generics in array lists basically. Like when we are creating, like we use, like when we use that sign, we are in generics. But I haven't created a class using generics once in my life. And also maybe you can teach me generics. But I suppose like you are familiar with for loops, while loops, and arrays. Yes, for real. Like I haven't. Like I am using array lists and hash maps, but I haven't used it. You can teach me though. Absolutely. Like the idea behind these generics is making sure that there won't be a runtime problem. All right, because before generics, like you could do something like that, list dot add, let's say 5, and then you could add also a string, let's say kinesin. All right, and this will, like this would compile but failed at runtime. So to solve this issue, there is generics, like if you say your array, if you say your list is like a list of strings, then even in compile time, you could see, like you can get this error. Hello, welcome. It is just works. It just works. Okay. Welcome in. We are solving threesome problem. And also, Americano will teach me about generics. What the heck is Jerry data type? What Jerry? Well, what Jerry? What do you mean? like generics. Where were we? So like we are getting runtime error. So the cause, like the problem, like we can solve it by moving initialization step here and using the temp array over here instead of creating multiple times. And after adding, we should clear. I don't know, clear the list. Like I don't know if it's even real method. This Jerry in list, maybe it is just handwriting. Um, yes, it is just is most probably it is just handwriting. But let me look at it. Like string, list of string over here, and we have array list and these arrow functions. So like, do you know guys how can I clear the list? Let me run it first. After adding these indices, we should clear so that in the next iteration it will, you know, it will hold the correct thing. Jerry, no, yeah, Americano. As Americano says, it is string. Maybe we can look it up. How can I clear a list in Java? Oh yes, this is a real method, guys. I wouldn't say it is a even real method. But again, we hit memory limit exceeded, and this is bad. Like, we are sorting our array. We are initializing x from 0. We are initializing our list of integer. Type and pray always. Please, God, I'm begging you. Like, please make our code work. Like we are initializing our temp array once. Actually, we don't need them, right, guys? We don't need those robust conditions because it is valid. We are calculating our summation. Yes. And if we find what we are looking for, we just add these indices in our temp array and add the temp array into answer. And the answer is like an array list here over here. After saving one triplet, so this is one triplet, all right? Triplet, one triplet. We clear, so like this should, oh my god, come on guys. Like, maybe I can copy the code here, guys, all right? And open my code, all right? And paste it over here because I don't trust leetcode, all right? And here we can run our own threesome, like a give this, and maybe we can give a list of new integer like this, right? Integer, let's say 1 2 3, and then maybe -3, and then maybe -5, all right? And let oh my god, oh, I think we should import like, how can I import list in Java? I guess we need these two magical stuff and put it here. Arrays, for array source method, we should import something from the package, Java package as well. How can I import this one? Java util arrays, all right, let's copy that. I feel it like we are getting closer, guys. Come on, trust your gut. um, non-static method, so let's make it static. Public. So Americano, do you know why we are getting this error? Like we should make R3 some method static to call inside our method, like main method. But as you know, if you define your method inside the class, and if you are calling that method inside the same class, you like you don't need to. Now you can call it right away. Like this question asks during midterms, finals, quizzes, everywhere. Uh, Non-static variable answer cannot be referenced from static context. So we make this context. So, oh, uh, where am I supposed to type static? Here. Like if you want to get 100% from your exams, you should know this. Teachers and professors love asking this. Oh my god. Out of memory. Guys, we are getting complex. Americano, help me, man. We are getting some strange errors, guys. So our code doesn't work efficiently at all. Out of memory error, like Java heap space. Like erase copy of erase row. Like we are in main, we call our method, and then our add method, and then another one, and then grow. Uh, we are failing, so like I don't want to lose any time more, and I will copy this one and open my AI session and paste. So together with Americano, it is my friend, we created this solution, but it fails, like, and it gives uh, out of memory error. Like this is the stack of errors. So why do you think this happens? Because we are almost 100% sure that our code is looking amazing, but why are we getting this error? I mean, without giving the answer explicitly and dumping the answer explicitly, guide us, all right? So Americano, like I'm using a skill that makes AI to behave as a tutor. Instead of giving answers right away, it tries teaching. Good. The structure is genuinely solid. Good for us. Sort, fix, two-pointer invert, yes. Compare against, yes. That's the real shape of the problem. So guys, we handled the problem like a, I don't know, almost maybe 90 percentage. But looks amazing. What is that? OM means something runs forever. Oh, something runs forever, guys. The stack trace is just ArrayList grow answer is exploiting to infinite size. So one of your branches never lets the loop end. So we are failing at, like, guys, like I'm afraid maybe this one the issue. So maybe add x is smaller than array dot length -2, like a -2, and y is larger than 0. So how about that one? How about this one? Like this for loop will end when it hits like a this case, and this while loop will like like we are still getting same error. One question, trace it by hand. Inside while loop, walk through the branch where is true. You add the triplet, then what happens? Oh my god. Americano, come on man. Like we are increasing, like we are moving our pointers inward, but here we don't do anything at all. So like it finds it finds what we are looking for, and then like, and then in the next iteration of while loop, all right, like x and y values are same. So Java needs to update and add Java close everything for real, for real. Like Americana, you should have told me this. Like, but you now, like, do you understand now? Like, we are in while loop, all right? And like for this else if, we move x inward, and here we move y inward. All that's awesome. But here we don't move them. Like we don't move our pointers. So like in one iteration of while loop, it goes into this if, and in the next iteration, it goes into this again and again and again. All right. So what we need to do is like moving. Oh, what should we do now? Like moving x inward and y inward, or only one of them, but most probably moving, like we should move two of them inward, right? Now I'm praying. Yes, so now I think we have empty array, but we should we should have like a legit result, like a, because if you sum 1 and 2 and minus 3, no, if you sum 1 and 2 and then if you move 3 that way, cheat a bit, check case 1, count the number of numbers, then hardcode hardcode element. Like we are too close, Americano, we are too close. Like let me copy the code and paste it over here, like I mean in leetcode. Like we are too close, man. We are almost done. Come on, we've gone so far, that ain't the option for us. Like let's run it. Oh yeah. We are too close, Americano. Case 1 is wrong. Case 2 is wrong. Case 3, yes, like we should return this one, but we are returning 3 empty arrays. That's amazing, bro. Like we, like when we find what we are looking for, we add these elements. Like what is the issue with it? Oh, Americano, now a real issue. Like Americano, come on, you know object-oriented programming, right? You know object-oriented programming, right? No, like object-oriented programming, sorry. Like the issue with this is we create a list and we add its reference, all right, its reference. So and then we clear the original array. So like this answer holds the reference of that array, and if you clear its contents, what you'll end up like in answer array it will be like it is clearing that too. So um one way that I can think of is maybe creating maybe creating lots of temporary arrays and adding their references, so we can have multiple reference of multiple temporary arrays, so that we don't need to even clear. Like, let me try this. All right, so because here we are using same array and we are clearing its contents, so that's the issue. But if we initialize a new temporary list again and again, and filling its content and save its reference, then it won't be issue. But it is not space optimized option. I strongly believe there will be optimized version, but oh my god, we are getting so what we have found is quite like is not looking similar the expected result at all. That's bad. Like it says 2, 5 and 1. So I guess I already. How did it even get, like, this is the exact question I asked. It is like, let me tell you why. Because we are adding indices instead of the value at that index. So instead of x, we should get the value at that index. All right, y and z. So like, I thought that the question asks the indices, but instead it asks the values at those indices. So like our index is 251. So um so like 251, like uh 2. Oh, let me run it, so we are gonna see it. All right. Oh my, I guess we are getting closer. The order is wrong. So like we might like -1, 2 and -1, but um what should we change here? Like, order is like x, y and z, right? Like, order is x, y and z. Like, let me read the question again, American. um like, the distinct triplets are, so like we are gonna handle this distinct case. All right, notice that the order of output and the order of triplets does not matter. uh I j Oh my god. Uh, it says that order does not matter. Come on, man. Why is this an issue? What a lie. It does matter. Yes, it does matter, bro. Like, if it doesn't, why we are getting this, like, why our result, like our case is wrong? Like, of course we will handle these reoccurrences, like this another issue, but like, look at it, like look at these two. They are same. um like -1, like, I guess we should change the position of these two, right? But no, I guess the order is um smaller to larger, like in ascending order, I guess. I don't know, but why? like look at it, like if you sum minus minus 1 with 2, you get 1. Like, this is exactly right. Like, this is, oh my gosh, come on, man. What do you say, Americano? Should we ask AI to, tell the answer right away? Yeah, really does seem like it's in ascending. Yes, like, yes, but it is not logical, there is no like a why it is in ascending order. Like, we are doing what is asking to us. What do you say, Americano? What do you say, guys? I am quite triggered to ask to AI. First, let us copy the code, the updated code over here, and paste it there. Remove the duplication first, then make it ascending for some reason. All right, all right, all right. I just gave the code. We fixed it. Yes, 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 yes. This now runs on produce correct triplets. But look at what it says. Produces correct triplets. Now, step 3. Reread the actual problem statement. The solution set must not contain duplicate triplets. Yes. Like, run your code in your head. What does your answer come out? Alright. So we need to handle this duplicate. Oh my god. How can we handle this duplicate? Like, these are literally same. The distinct triplets are this one and this one. Notice that the order of output and the order of triplets does not matter. So how are we supposed to handle duplication? Like, we are add another if to check if it's already in the list. But if we do that, let's say if we add, like, are you saying individually or as a triplet? Like, if the answer only the triplets, yes, only the triplets. If the answer, like, maybe here we need some sort of if, all right? If the answer, like, let me write it first in English. If answer has the triplet already, don't add the current triplet. So now we need a detection system for understanding if the answer list has that triplet. How can we how can we like, I don't know, man, come on, like a triplet that, like, there is a triplet. Let's say I'm just, randomly saying, like, 1 1 2, all right? And another triplet is, let's assume 2 1 1. So what we need is detect that, like, if we let's say if we edit this, our system should detect that when we are processing this one, it should say you already have this, so I'm not adding this one. Our system should say that. Like a permutation or combination, no. Maybe we can, like, maybe we can do this, like, something like this. If oh, but which triplet? Like, in answer there are multiple triplets, all right? We should first, like, what I have in my mind is looping through answer. Like this is the first thing comes to my mind, all right? Looping through triplet, all right? And let's say for each, all right? For each, like a list, yes, list of in integer, all right? And triplet columns answer. We should iterate through all the triplets, and when we pick a triplet, we should iterate through all the elements of the triplet, right? Right. And we should check if each of the elements of that triplet has this. What if ascending first, so it is easier to check if the triplets all the same? Yes, yes, that could be a way too. Yes. If you sort the array, like if you sort the triplet, then what you need to do is check if the current, like if the first character is the same and the second character is the same. Yes, let me try that way. So we have a triplet, so we need to sort the triplet like, can we do how can we sort the triplet? Americano. Arrays that sort like like we should sort the triplet and like integer I starting from 0 smaller than 3 for 3 times. What we need to do now is we also should sort the temporary array too, like most probably it is not the correct way, but just type it, all right? Sort the temp array too. Now what should we do is check, right? Check each element. Yes. If what was our goal? I forgot our goal. We are checking if the template is like, if it already exists, we don't add that new temporary into our answer. So so if they are not equal, just break the loop, right? But which loop? If answer has triplet already, don't add. Yes, we shouldn't add this, and like we should go or continue or break. Anyway, so we sort the triplet, we sort the temporary triplet. We are checking if the temp how do I reach its index? Like let's say I is, if it is not equal to triplet, or it should equal, but if answer has a triplet already, if the three of them, like three of them should be same. If not same, let's break. If they are all same, if we can reach this point, meaning that all three elements are same, so we don't edit. So we don't edit. So we just continue. We are in while loop. We are in while loop here. If any character like different, if any character is different, we should like there is a logic error here, like all the numbers in this triplet, if they are same, like if we have a triplet that is already exist in our answer, we like all like only thing we should do is not adding that triplet, right? So we just break the loop. I could make use of your help, guys. What we are doing is, guys, all right? What we are doing is, or maybe move my like this one and make it even bigger. Yes. Wonderful. What we are doing is yeah, so we will do it, all right? Because in the next questions, like we have dynamic programming questions, Americano. Hang in there, all right? Like a edit distance, and like we have 3 questions, graph, greedy, like word break. So we have like a cooler questions, all right? We cannot give up at this let's say basic question, like a like we cannot give up at this 2 pointers question, all right? Let's start from over, like, all right, so like let's start from over. So we have a for loop, like everything is right. Only thing we are like we should handle, like we have to handle is recognizing that if we have the triplet already, if we have it already, so even make it bigger, all right? This seems nice. Let me make it even bigger. That's wonderful. Our goal is, like, let me draw it. Let's say this is a triplet, like this is triplet, and it is our in answer list, all right? We have this already. So next time we find a triplet like this one, all right, like this one, we should just skip. This is what we are trying to do right now. This is what we are trying to do now. And it is easy, right, Americano? It is easy. It is easy. We should iterate through each triplet, get each triplet, sort them, as you say, sort them, and check each, like each characters are same. And if any of them is not same, we should, like we are breaking this loop. Like there is another important point here. Like if we break here, are we breaking from only this for loop or this loop for loop 2, or even better, even like this for loop? So I guess from the closest for loop, right? What do you say, Americano? When we find the different character, we should add this triplet into our answer. So we break, and are we going here? Like this is important. So maybe I should ask, like I should ask this to AI, because I could learn this from. So now please only answer this, all right? What I need to, like what we are trying to do with Americano beans right now is trying to recognize, find, or locate when we have a triplet that already exists in answer list. So for that, we are using for each loop, and we sorted the current triplet, and we sorted our uh, temporary list, and we are checking each character, like each element of it. And when we find, like, if there is a mismatch, it means that we should add that triplet into our answer. But we don't know how does this break work. Like, does it only exist from the closest for loop, or the, uh, like even out of this for loop, or even while loop? I don't know. And also we need, like, the first explain this. All right, we should learn about this break. And also, can you teach us the continue? I mean, continue will just continue to the next triplet, so we know this. But how about break keyword? We're gonna solve this, come on. This is easy. This is easy. We are checking each triplet, we are sorting them, we are checking each character. If we find a mismatch, that this means we should add it. Like, we need to do something here. What if, hear me out, we check before adding into the list, like sort first then put on list, but check values. If value 1, 1 2 3 already exists, ignore it. If value 1 2 3 already exists, ignore it. uh, Contains, like, contains that one, contains that one. like again, we should know how break keyword work, Americano. Even, I guess, even if we use like the last approach you just mentioned, we need to know how break works. So let us learn this before, like, first, and then we can try everything. Direct answer. So let me close, like, all right. So direct answer, no tutoring. You ask syntax. So break exists, like, exits only the single innermost loop that encloses it, nothing more than that. So if we use break here, it exists, like, exits this for loop, that, like, the innermost, the execution line. All right. So if we find a mismatch character in this triplet, if we break, we end up here, meaning that we should add it. We should add it. We should add it. So if we should add it, uh, we are adding it. I mean, we are adding it. If we add, we also should increase this. Or no. We don't need to edit, because we are already adding it here. All right. Like, the point of this code snippet is just recognizing if it is same. Like, if we already have it. If we find different one, then we should edit. So we break. So, and we go outside of this for loop. Now we end up being here. All right. What should we do here? Like, we are checking each triplet with our temporary array. Like, I mean, we can delete this, and if we find a mismatch, then, like, let me type it down. All right, we have found a different triplet. So we should exit and go over here. But break puts us here. So we are trying another one, another triplet, another triplet, another triplet, and actually, if we found the same one, oh, got it. So that new part was just for the checker and the break. Oh, okay, okay, got it. Yes, yes, this is for checker. Like, this is for checker. This code snippet will help us recognizing, understanding if we already have that triplet into our answer. If it is, we should go next. I mean, we should continue. Like, this part is quite good, man. Like, because we are in a while loop, all right? And if we find the same triplet, we shouldn't run this. We shouldn't run this. Maybe we can use a flag, all right? Maybe we can use a flag. So, and we set that flag to, true or false. And then based on that flag, we can add or not, basically. That's wonderful. All right. If, let's say, if flag says the current triplet should be added in else statement, if flag says don't add the current triplet. That's all, man. Like, this is easy. So we should set a break. Like, this is the only thing we should do. We found a different triplet. Actually, there are tons of triplets here, and if the current triplet is same with any of them, right? Any of them, we like, let me create a flag over here, like a Boolean flag, or let's say should add. All right, false by default, and you check every triplets here. You check every triplets here, and should, if should add is true, then we add. If it is false, then we don't add. So we continue. We continue, but before that, of course, we should move. All right, this seems good, right? If we should add it, we add it into our answer. If we shouldn't, we just, our while loop goes forward. So now only thing we should do is setting this boolean correctly. So, like, what we need here, like yes, so what we need is, if the current template, like a current triplet, is already exists, exists in answer list. How can we do that? We can do that by checking each character for each triplet, and by the end of it, come on. Oh my gosh. Please help us. Maybe we need another flag over here. Like, because what we are doing is checking each triplet and checking each character in each triplet, basically. Um, so if each characters are same, if each characters are same, if each characters are is same, I don't know, is same. So here, like a, let's add break here, and if you know, if the temp 0, like temp I not equal to triplet, if it is not equal, then we it is good, we can add it, we can add it. So should add is true, we can add it, we can add it, and we break the loop, and it goes like, but we should decide this and the end at the end of this for loop, for each loop, not here. So it should, all right, like we are setting this as true. Maybe somewhere we should set it false, like a, no, we shouldn't, like we break and we go to another, like next triplet, and we check its characters, and if like they will be same for it. So we need another flag, man, another flag. Boolean should add inner false, all right. So if by the end of it, like if here should inner, like if, or then maybe we can make use of tenor, if here should add equal to should add inner true. If should add inner is true, then we assign true. If it is false, we assign false, and based on that flag, I don't know, maybe we can solve it only one variable. But what we need is, like, we should check each triplets. Come on, man. I don't know. I'm gonna ask AI, guys. I give up. So what we do is, like, we have these triplets, all right? And we have our temp triplet, all right? Let me even type like using red. So we have our temp array. So what we do is like a looping through, like a using for each, all right? Using for each, we check each values of this, all right? Like for each of the elements, each of the triplets, we check each characters, we compare. Our goal is to make it to make sure that the current triplet does not exist in the answer. if it doesn't exist. So maybe we can create like a single boolean. Boolean uh, does exist. All right. But they behave for like we are in for each loop. We are checking each character. I don't know. I should take a break, guys. My brain doesn't work right now. Maybe 5 minutes break. What do you say, Americano? 10 minutes, 5 minutes break. Like 10 minutes break would be awesome. I should take a break, guys. I'm taking break, guys. For let's make it. Let's first stop like pause the Pomodoro, and then 10 minutes break. After that, I'll be back because I cannot solve this. 10 minutes break. Be right back. All right. Let's start the break. Yes. I am back. I am back. Let me get my microphone. Hold on a sec. Oh, now I feel better. Oh dang, what the heck? This is easy, right? Then just have it check the previous one. So wait, I think we are still missing. Welcome back. Thank you. Thank you, mate. We're gonna handle this. Just be relaxed. Just be relaxed, all right? Only thing we need to see, like a thing, is how good life is. Nothing more than nothing more than that. Let me start my Pomodoro as well. So how are you? Did you take a break too? Like we have list of lists, right? And with for each we take individual, like we take each of them and compare them with our temp, like temporary array, right? And for that, let's say like this is for each array, this is temp array. What we do is like checking each character, all right? Checking each character, and if we find is the song good, or let me, yes. So like what we need to do now is like checking each character, and when we find like a different one, or I don't know, like 3 of them should be same at the same time, all right? We were using like a not operator, but this is not the correct way. I think the correct way is if every one of them is matched, then we can say that what if all of them. So instead of a for loop here, all right? Oh my god, why are we using for loop here? I mean, like we don't need a for loop for that. We just compare them at like if I mean let's say triplet, all right? Let's say triplet 0, let's say equals to temp 0, and let me copy, like we don't need a for loop here, man. If the first, like if the second characters are matched, and if the third characters they are matched too, like they are both same, then we say that we have this triplet in our answer. So like so let's put like inside if all of them are matched, then we can say that what, Americano? What? We can say that, like we can set a flag. We can set a flag for that. So remove them, all right? Remove them. We don't need them at all. All right? If 3 of them are same at the same time, should we add it? No, we shouldn't, because among these triplets inside our answer array, we found the triplet that are matched completely, but actually we shouldn't check them like this, but instead first character should be there and second character and third character. So instead of checking like comparing them exactly, we should check contains. So but we can update it, all right? So let's say let's say we have the triplet in our answer, and we set our should it to false, right? And by default we can make it true. If we have the triplet, we set it false. All right, so now this for each loop does its job, guys. It does its job. So if we should add it, we are adding it, and if we shouldn't, we don't add, but we continue. That's the way. Now it is time for updating this part, Americano. Guys, instead of like what we are doing is like a checking each character if they are same, but instead what should we do is what we should do is wait a second, wait a minute. If they contain like a let's say we have XYZ, and we should check like a using some sort of contains method or not. If contains X, and if it contains Y, and if it contains Z. Oh, Tar. Welcome Tar. How are you doing, mate? Maybe just dump everything inside the temporary array and only checking them once. Just throw them all in and sort them and just have them check their immediate neighbor, like 1 2 3 1 2 1 2 4 1 5 2, like 1 3 2 means like it can be 1 2 3 1, check I didn't get it. I don't get it, but the correct way should be like this, like we can sort it. Actually we have sorted, right? So that's why we are checking if they are same. All right, I forgot. All right, I forgot that we have sorted. Hey there, don't mind me. Welcome in, the gambler. Welcome in. How are you? How are you feeling today? As Americano said, like we already sort them. Like we sorted the these triplets, so we can check we can check them like a one by one exactly. All right, if they are matched. If they are matched, we shouldn't add it. So if they are matched, like a first element is matched, the second, the third, then we shouldn't add it. Haha, maybe I started tripping after the break. No. You said it correctly, because I forgot we sorted these triplets. I'm good. Good luck with the triplet. Thank you. Make them happy. Thank you. Yes. Like actually we expect them to make us happy. All right? Because like we should solve this problem, all right? Thank you, by the way. Thank you for stopping by. So we sorted them and we check if each characters are same. If they are same, our flag says don't add that triplet too. All right, and we check them like here inside the while loop. All right, inside the while loop. Yes. So all right. So this is a case, like we are inside the case of where we find what we are looking for, but we don't want duplicates. So this part is for duplication. Yeah, okay. So only remaining part is Americano. Are we using this sort correctly? Because I haven't seen it like actually it is correct, right? Like this should work. Let me run it, guys. Let me run it. Let me run it. And let us get some errors. Yes, compile error. All right. Arrays sort is not applicable. Yes, this was what I was like. This is what I was afraid of. Argument mismatch. The list integer cannot be converted to int. Like we should find a way to sort them. We should find a way to sort them. How can we, guys? Like we have a list of integer, and all we want is just to sort them. So maybe like I don't know it. So maybe how to sort, right? List dot sort. Like we need all right. Collections sort. All right. So the method is collections dot sort. So instead of this, collections dot sort. What is our triplet? That this is our triplet. All right. And now collections dot sort, and our temp, like this is sorting in place, and we don't have any problem with that. We have sorted. So I think we should also import it somewhere. How to import it? I think using this one, but I think we don't need to import anything because the leetcode website handles this, right? So are you ready, Americano? I am clicking run. Another error. Like this is a good error. Like there are two types of errors, guys. One is you don't know anything at all and you feel bad, and there are some errors that you feel better because these are different errors that you keep getting. All right. Eric, but line 26. Line 26. Yes. So like this is the like. All right. I was gonna ask it, but I forgot. So like how we reach in the indices in the indexes of list. I don't know it. Do you know? Like, do you know, guys? In a list, how do you maybe get, right? Maybe get dot get 0. Like in arrays, we use these like a bracket dot get 0, and then let me copy this part and paste it over here and change the indices, right? Change the indices, and let's make it 1. Thank you, Americano, by the way. I forgot we already sorted. So now this line makes like tells us that they are same. Wrong answer. Wow. Yes. So finally, I'm happy. Case 1 is correct at this, guys. So we have like I guess it seems that we have solved the duplication error, like a duplication case. But now for this input, oh my gosh, for this input our output is that one. How on how on earth our code can find this out of that? Yes, progress. Yes, this is definitely progress. But I think for let's say single triplet, like I mean for inputs that has only 3 elements, our code fails. So we need to handle this because it hallucinates, you know, like our input this and our output like this can't be true. So maybe we should add an edge case or something so that when the input size is 3, so let's add it. If the input size is 3, then what should we do? We should find, like, we should, where did the code even get to? Yes. Yes, so like look at it. Yes, there is no -1 either. So like our code fails at when the length of our input is 3. So if our input length is 3, then we still, like, I don't know, man. Like, actually, like, we shouldn't check if it's 3, but instead, if it is less than 3, then we can, return some empty array or something, because there is no possible way. But starting from 3 and more, it shouldn't be a problem, because like, let's say we have 1, 2, and then 3, all right? So our like our z value starts here, x starts from like a here, and y here. Our code, like our code checks like a some these x and y values, all right, and compare if it is minus z, and if it is not, oh my god, if it is not, it will move that x. Like, this is a big issue, Americano. Now I wonder how we passed the even case 1. I mean, like, our z starts from here, like what I mean is, we don't set our z to 3 or 2 or 1. We can only set it to 1, and then while loop iterates only once. But the answer is like a setting z to 3 and settings x and y to 1 and 2. So our code doesn't process this case. Because I, like, you asked this question at the very beginning of our like a solution, all right? Like, you asked that, what is the meaning of that block, like and I said that when we process z here, we move z over here, and we process the rest of them. So this means the first iteration 0, all right? In after each iteration, we move that z to right. But I think we should be able to set z, like, we should able to set z's value to every element. And then if length is 3, just add it, and if result 0, return empty. If the result is 0, add it. If return is not equal 0, I get it, but like, we have 3 elements, so like we are setting z to minus, like a negative. Like, let's say you have 1, 2, 3, so you should set z to 3, all right, because negative version of 3, and you should get 1 and 2 x as x and y. Your solution does not tell us to, and mine neither, all right? Tell us to set 3 as z. This is the issue. Because you can sum them up, but which one are you gonna choose as z? All right, this is the issue. Because it doesn't say only sum these up. It says find a z value, take negative of them, and make sure that the remaining two elements, summation of these two elements, will be same. So the question now is which one you are gonna choose. In our quiz, like in our solution, we pick the we pick the first element as z and solve the remaining problem like this. All right, starting from x, like we sort the array and we move our pointers inward, and then we pick and the next element as z, and then the next, and then the next. So z is never set to, let's say, last element. Like z is like doesn't get the value of the last element, for example, but the solution might be here. I think I should, I'm gonna ask this to AI. Like, at least we learned that break only jumps out the innermost for loop today, and I will, like, this is the issue that I have no idea, guys. If I don't have any idea, um the time we will spend will be pointless, because I learned that in a hard way. All right, so we have this code, um but it has some problem. Like, let's say we have input of 3 and we realize that we don't set the z, like we don't set z's value, let's say, to the last element, because we start z from the beginning, from 0 index, and then we make x and y, like we pick the values of x and y from the right side of the z. So, and we shrunk our input like a problem from left side, but the solution might be from, let's say, setting the z as the value of this last element. I think our structure contains something deep wrong, like something deeply wrong. What do you say? Oh, apologies. No, no worries. Didn't know that I forgot. That's all right. If x, y, and actually, no. Yeah, like you said, like you asked a good question. Like the question asks x plus y plus z equals to 0. Like this is the question. Like this is the original question. This is what we need to do. Like this is what we need to find, and we transform this format into x plus y equals minus z, and we try finding pairs of x and y that equals to minus, like a negative z. All right, because using this way we can do just like a two sum. Like, at least this is what I thought. Now I'm asking that if it's a correct approach or not, because as far as I remember, this should be the correct approach, but the original question is this. All right, original. Let me, oh, my bad. Yes, hello. So it was a classic system pro. Actually, like, isn't that classic threesome problem? We are solving it. Like, this is the original threesome problem. I mean, look at it. Yeah. Like, I'm while, like, when when I'm saying that word, like I'm thinking like do I use it, like do I say it wrongly? Like, but threesome, yeah. Let's look at it, man. Good instinct to question coverage. Um, good instinct to question coverage. That's exactly senior move, but let's test the worry instead of trusting. Predict before asking. Um, take any child, like any valid triplet in the answer. Hmm. What does it say, bro? Think about for. All right. Z always sits at. So here's the real question: does every valid triplet have a unique smallest element? And if Z sweeps across every index to smallest, does any triplet ever get missed by never having Z at the end? What do you conclude? Hmm. Like in your loop, which pointer lands on a? I don't know. Like Americano, maybe we should look at the solution, all right? Because I just like there are too many questions, and like I want to solve like this DP problem, all right? But I guess applying to some approach is not an issue, and our issue is something else. You said array dot sort, but we are using collection dot sort, right? In the new approach. Almost an hour on this question alone. Yes, yes. So like we should skip like at least like this is enough, all right? This is how far we could go. That's all right. Next time, let's say 2 weeks later or 1 month later, when we try to solve this again, we can continue from where we left off. Um, all right. All right, we sort the array. All right, so we have already like, all right, all right. Inside the duplication. Hmm. Rule of thumb. Yes. When I said after you sort the array, I meant your top. Yes. Back to coverage question though. Coverage question. So this is a term, like this is a good term, man. Like this is about edge cases, all right? Edge cases. Is there any valid triplet your Z from the left structure connections? No, Z covers every smallest element, nothing missed. Mm. Can you ask me once more? Like after understanding this, we're gonna continue with the next dynamic programming question, all right? You sorted the array. Now Z only ever moves left to right, yes. And X, Y always sit on the right of Z, yes. So Z is always the smallest of the three values in any triplet it forms, yes. Your worry was, yes. What if the answer needs Z at the last element? Yes, for example, Z is bigger. So think about any valid triplet that's A smaller than B, B smaller than C. A smallest gets found when Z points at, B and C gets found by X and Y to the right. Does every valid triplet have a smallest element? And does Z eventually visit every index that could be smallest element? If yes to both, can your structure ever miss a triplet? I don't understand. I don't understand at all. Like, I know that we have sorted our inputs and we are looking for triplets. But what if Z should be, let's say, the last item? because we. All right, all right, all right. Now I see it. Yeah, yeah. No, it can. Yes, you are right. I mean, I get, I get. So because we already processed the. I don't know. I don't know. Let's continue. All right. Let's continue. Let's continue. Let's leave it that way because we need to continue. We need to go. Oh my God, this is not good. Let me copy this part. Open our node. Open our code snippet part. Select Java. Place like a paste and save. All right. So we're gonna continue. Let's continue with the DP. Oh my God. So like basically two-sum approach is correct, but we failed at if the length is 3. All right. So after solving that case, it will be great. So let's continue with this dynamic programming question. Let's see how it goes, man. Like we cannot spend time like a more than 1 hour for any question. So now we have this dynamic programming question. Let's see. Let's first take a screenshot and paste it over here. How can you do this for 12 hours? I would die at a... Because, Americana, because, let me be honest with you, I've spent so much time on these problems so that I can't go back. And these 48 questions are the most asked questions. Like I had some interviews and I've seen these questions a lot. So my goal is understanding all these 48 questions in my mind, fresh, solvable, let's say in 10 minutes or 20 minutes. All right. After that, I will feel confident about leetcode because, like, of course, these are not enough. I should solve, let's say, 300 questions, especially, for example, in greedy problem, like a greedy topic, there are, like, greedy itself contains, let's say, 15 different subcategories. So to capture the idea of greedy problem, you should solve at least 50 questions there. I have solved, let's say, 10 or 15. But overall, my goal is cover all the topics, all right, in leetcode, and be ready for incoming interviews. And also AI is in our side. And also another thing is, I have you, man. Like we are studying together. Maybe I should also start coding. Like, yeah. So just hang out here, all right? Like I got lots of interviews and I know what they ask. So you can also follow leetcode. Like a leetcode has like you most probably know him, like a wonderful person. Like let me even open its his map actually, roadmap. Like this is the map. Um, like I solved tons of questions, but for this part, like a tree, you should know recursion very much. So forget about tries. They don't like it is not asked that much. You should know recursion very much. You should know recursion again, one dimension, two dimensions. So these are all about recursion. If you capture the idea of recursion, then nice. And for example, I live in Turkey, so the grid, like them, most of the time they ask greedy problems, and they are hard actually because it's like a math problem in college entrance exam. So we should like you should be familiar with greedy problems, like 50 questions, 15 categories, 50 questions you should solve, and these are the other concepts. So uh, like there is no way, all right, I should do it. I should do it. So that's why I started streaming too. Like it makes me study more. Thank you. Like with the help of people like you. Thanks for the advice. Yes. So like uh in almost like any of video that you can find on YouTube, they explain recursion wrong. All right. Wrong. WR O G. Wrong. Like I've read a book on recursion written by a professor. Uh, we can find it his book later. He says that don't think recursion as a like iterative method, and don't try to create like a type or draw its stack frames, all right? And most of the people on YouTube draw stack frame to understand, to explain the recursion. There is like, this is not the way, because we are not CPU, all right? We are human beings. Like for example, do you know reverse linked list problem, Americano? Do you know the reverse linked list problem, where you should, you know, like you are gonna make this like this. Like I strongly suggest you that capture the idea of recursion on this question. And fun fact, during uni, one of like in my data structure lecture, like a lecture in, I guess, midterm or final, I don't know, I don't remember. They asked reverse linked list, and they both asked, let's say, iterative way, like, and recursive way. Like this was a question in one of the exams. Like, even if you really capture the idea of recursion on this problem, you can understand it. You can solve it. You can solve trees, backtracking, time problem, anything. But this is quite crucial. Like this seems easy, but it is not easy at all if you approach with the wrong angle. This is leetcode. So by the way, follow this map. All right. This is quite helpful. Let's go back to our problem. We have two words, and let me update the current topic over here. Our current topic is edit distance. Current problem is dynamic, let's say DP. Set the ticker. All right, let's continue. So given two strings, we have two words, return minimum number of, oh my gosh. Like actually this is hard unless you know search space and making decision, all right? So decisions we can make are this one. So what we have is basically a string one, let's say kinesin, and string two, let's say kino, and our goal is convert word one to word two, convert kinesin to kino. Our options are like, I really enjoy drawing the decision tree, all right? This is the correct way. Our options like insert a character. I mean, like insert and delete. Insert, delete. What else? Replace a character. Oh my gosh. So the question asks, find the minimum number of operations needed for converting kinesis, like a string one to string two. All right. Like this seems quite hard, but actually what we are going to do is basically try every option possible and take the minimum of them. So like it is not too hard. So we basically like at each like a recursive state, we're gonna try inserting, deleting, and replacing. But the replace part is like seems hard, because what should be the source? What should be, like, I mean, which character? Like we are gonna replace which character with which character? So this is my question. But I know that we should use this search space. Like I mean decision tree. Like this is decision tree. Decision tree. So and each of these represents options or choices. I mean these are options, choices, or I don't know. These this is enough. Options or choices, all right? Mm. But we have the same problem with insert as well. Like, where do we, like, where are we gonna insert? We have mm, two strings. So S1 and S2, let's say Kine and Kino. Kine, Kino. So let's start with the first index, all right? Let's have a recursive function called, let's say our function is func. We should check if the characters are matched, all right? Because if they are matched, what should we do, Americano? If the characters are matched, what should we do? Here in this case, don't change it. Exactly. So there is no option. There is no decision we need to make. So we don't call our recursive function. All right. We're not going to call our recursive function because we already know what to do. We should delegate like this word. I enjoy this like delegate. I guess delegate. I like this word. We should delegate our problem to sub problems. So um, let's say if we call our recursive function like, at the root level, if we call this function as like using kine and kino, this our function our style should call ine and ino, all right, and do nothing because we don't spend any time. So our new sub problem is this. So we should solve this one. All right. This is one case. This is one case. So, and also again, I and I is same. So our function should delegate its responsibility or its problems to the sub problem of this one. So again same. All right. Let's see. So it should delegate to E and O. All right. So now what should we do? Now we have here we have three options, like three operations that we can do: insert, delete, replace. Now these representing function calls, recursive function calls. All right. Uh, like another thing is now like how we are doing that. Like I mean, let me read the example. Like replace H with R. All right. All right. Uh oh, remove R. Which R? This R. Oh. Like by looking at the example, I don't understand how I should apply these operations. Like this is a point. Like this is the phase of solving this problem. Like first phase, understanding or your options. You're gonna make them in each phase. So does it one by one from left? No, 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 no. Actually, like let me look at it again. Like this is the solution, but what we are creating is all the options. Like this is the solution, but while creating the recursive DP problem, um you apply these three, all right? Three options, three choices. So like looking at this doesn't help at all. This is what I mean. So maybe guys, we can make use of some from help uh from AI. This is the question we wanna solve. This is a DP problem, and what we know is in each step there are two options: insert, delete, and replace. And I really enjoy drawing decision tree. So basically, I draw a tree with root that has three children. And I also know that from another DP problem, I guess it was substring or something. We can have some pointers like a S1, S2, and these pointers like point to some word. And if they are same, for example, we don't do like we are not calling our recursive function, but instead we delegate our sub problem to the next sub problem. All right. Like this is what we know, and what we are trying to do is like, for example, like without dumping any code, can you explain how should we like represent, how should we transform insert operation on, how can we, oh my, how can we transform insert operation into code, all right? Like because this is a translation, like uh and also like the delayed. So um like this is not about recursion or DP, but instead it is about translating human language to code. So and of course replace. So for example, insert, like I don't understand uh where should I insert, like because I have two strings, all right? I have two strings. We are trying to convert the first one to the second one, and I guess we are like we apply these options onto the first string, right? First string. Um First string, yes. But at what position I should insert and which character I should insert. And it is same for delete. Which character should I delete? And replace method is even um, actually replace is the same too. It needs two pointers, but in the first string. So we are applying our operations onto the first word, right? But even inside it, we need no, actually for replace we don't need two pointers, but instead one pointer for location and another information for which character. So can you guide me a little bit so that I can handle these operations and then focus on some recursive part. But go with small steps, all right? Don't give me hints, not uh, full code or full answer. And also, by the way, activate tutor mode too, all right? Oh my gosh. Let's see. Come on. It is still transcribing. Yes. So, like, I solved this question before, to be honest. And the thing I remember is, like, insert, delete, and replace method are like simpler than I thought. And but I don't remember how I was doing. Um, let's say you have two strings, kine and let's say kilo, and you obviously need pointers, but you have two, three operations that you can apply onto this string. But which position, man? Which position? Or as you say, Americano, from left to right. Maybe from K, should I insert? No, like we should delegate our sub problem too. So first we should check these two strings, string one and string two. And when you find something that is not matched, there are two options there. I guess at that location. At that, yes, all right. So we start, let's say we start from there, and let's say fun kine and kilo, and then it delegates to ine ilo, and then ne and lo. So now they are different. So there are two operations we can. But where are we inserting it exactly? Like insert view, like exec, like execution. Hmm, execution. So like uh we can replace this character, all right? Like for example, this is replace operation, all right? We can replace n with l. This is one of the, like, if you have an e here and you are processing n now, all right? You can replace. You can delete. If you delete, you have e. If you uh if you replace n with l, you get le, and you insert, like, what are you gonna insert? What are you gonna insert here? Like, what are you gonna insert? Does each operation cost the same? Like, does replace and remove cost one? And I think they are same. Yes, I think they are same, as far as I remember. That's a good question. That's a good question. That's an amazing engineer question, and I think they are same because, like, I mean, let me read it again, but it should be same because yes. So minimum number of operations, and these are the operations. So yes. Let's see how how AI answered. Good. I've got your notes loaded. Your past work is all sorting heaps. This is your, yes. You already gave me your confidence map. I'll skip the formal audit. Confident decision tree. Two pointers. Yes. If characters are matched, delegate to subproblem. Fuzzy. How to encode insert. Yes. Like this is the term. How to encode, insert, delete, replace specifically which position and which character. Let me anchor the goal first because it dissolves half of your worry. Wonderful. Like this is what I need. Goal. Turn word 1 into word 2. Yes, this is our goal. What mean, like that means word 2 is your target. Yes. The thing you are trying to match. Yes. So for example, let's say we coded our function, all right, our answer, and in our recursive function, after the base cases, what we will have here is checking if string 1 equals to string 2. If it is, we will return true. All right. So this is what we are checking. And below that, we are gonna do our recursive part and logic part, operation, everything below here. Like this is the recursive structure. This is the oh my gosh. This is the recursive structure. Now the leading question. Yes, please. For insert only. You are at pointer I on word 1. Yes. Yes. Let's say A, B, C, D, E, F. String 1, string 2, and it says pointer I. Can you make I and J as S1 and S2, please? And tell me again. Like, I know, guys, I'm being lazy here, but seeing, like, because I use this in other DP problems too. All right, this helps me. So we are at here. All right, let me delete that. Like S1, like we are here on A, and let's say S2, or even below it, S2, we are here. Yes, don't match. You decide to insert. So yes, so they don't match, and we need to insert. Like, and also, like, now I'm thinking that if our function should has both of the strings or only one, but maybe most probably, oh sorry guys, like I use S1 and S2, but I think we should use I and J, because this is the strings, not the indexes. So string 1 and set string 2, and I think we don't need to have our pointers in our parameter, because all the thing we do is comparing their leftmost part. As Americano said, we are gonna see it. Yeah, like, don't call them S1 and S0, but I and J. I'm sorry, guys. I'm sorry. This is I. This is pointer. Or P1, yes, P1 and P2 is better. Can you make P1 and P2? All right. What is the one character? Oh, yes. So, no, all right. Become word 2. So, what is the one character it could ever make sense to insert? And why that one? So, here, the most logical character that we can insert here at this position where pointer 1 points is D, of course. Like, from the string 2, we should insert, but isn't it the replacing? Aren't we replacing? Actually, like this is replaced. Like what I'm doing is replacing, but it is like, it is inserting that I should do. So inserting means like a, let's say, another character to here, right? What is the one character it could ever make sense to insert? So yes, what I'm describing is like what I'm doing was replacing, but it asks inserting. And why that? Ignore the position for now, just the character. I don't know, man. Like, I don't think we should insert anything, because like we have, let's say, our let's say our first string is ABC, and the second character is DEF, and let's say pointer 1 points to A and pointer 2 points to D, and like I don't know, like I don't see anywhere to insert basically. Because let's say if I insert, let's say D, all right, our string 1 will become D, E, B, D, A, B, C, sorry. Wait, sorry, my brain, my brain. Yeah, bro, we are trying hard today. Yeah, inserting costs 2 since we'll have to remove. Actually, it won't. It won't because I think all operations cost same. Like inserting a character costs 1, deleting a character costs 1, and replacing a character costs 1. All right. It says good. You inserted D where like to the position where pointed 2 points. That's the right character, and your instinct, I don't see where to insert here, is correct. For A, B, C, D, E, F, replace is the better move there. Insert is the wrong tool for that case. Yes, this is what we are talking about. A, B, C, D, E, F, replacing one costs 1, but inserting 1 will make it 4 and 3, which will lead for you to remove 1 to keep it. I guess I understand you. So if we insert a character, in this case, we make our input even worse, so that at the end, we're gonna have more operations to turn it into the word 2, I guess. This is what you mean, I guess, right? But what I mean is, like, each single of them costs 1. Wait, no, I thought the AI wanted you to use insert. Let's see. Like actually, what we are doing, I mean, as far as I know, we are gonna apply insert, delete, and replace nevertheless, all right? In any case, we're gonna use them, but we're gonna, like, they will return some values, all right? And we are gonna take the minimum of these 3, all right? So we are gonna apply insert here too. Let's see. So let me give you the case where you insert is the only tool. AB and ABC. P1 and P2 walk together. AA, BB. Now P1 has fallen off the end of word. Oh, end of word 1. And word 1 is exhausted. But P2 still points. Yes. Yes. What do you have to do now? And how many times? Of course, obviously, I should insert what P2 points to word 1. Wait, ama shush for a bit. No, don't shush. Tell, because making mistakes is the best way for learning. Just type it all, man. Type it all. Of course, obviously, I should insert, yes, so press enter. Because as far as I know, we're gonna apply all of these options, all right? All of these options, and we are gonna take the minimum of them. So in any case, we are gonna try, at least, try doing those operations, applying those operations, running those operations. Exactly. Now the mechanical part. This is the whole point of the exit. All right. You insert word 2. You insert that character right in front of P1. Yes. That newly inserted character now matches. Yes. So after the insert, which pointer advances and which one stays put. Stay put. So let me save it because I like this word, this idiom. Which pointer advances and which one stays put and why? Like pointer, that's a good question. So ABC, what was the example? The AB and ABC. So imagine we have AB and ABC. So these matched, like pointer one was here, and then oh my god, where is it? I don't see my, let me, yes, pointer one was here and pointer two was here, all right, and we compare A to A and we move pointer one here, and B to B, B's are same, and then we point pointer one to here. But all right, like 0 1 2, now pointer one is 2, and also we also move pointer 2 1, like I mean compare this, A it is same, compare B it is same, and then we move it once more, and now P2 is here and P1 is here. 0 1 and 2, so both pointers are index 2, but we don't have anything left in string 1. So obviously, if we don't have anything here and we have C here, we should insert here. We AI says that we insert C over here. Yes. After you insert C right in front of P1, the newly inserted character now, yes. So after the insert, which right in front of P1. So I guess what it tries to say is like pointer one was here, we checked AA, they are same, we move it, yes. P1 advances after the insert to match the index. After the insert, I think yes, yes, like this is the correct answer, and this is where I am where I am trying to get. All right, yes, most probably you are correct. I mean, you are correct, but I am trying to understand. So P1 was here, we checked character, they are matched, we move it, they are matched, yes. Now what? Now we at the end, we are at the end. Now it says that, I mean, like P1 is here, P2 is here, they are matched, and then we move P2 here, but we cannot move P1, I guess. All right, it is there, and it says that now P1 has fallen off the end. Yes, like what does falling off mean? So what is the index of P1? P2 points, yes, all right. So I guess as you say, we insert C, all right, we insert C, and then we should move pointer 1. So this is the answer. So after the insert, which pointer advances and which one stays put? Like, of course, so P1 stays put, and P1 advances after the insert. You are definitely right, Americano. So P2 stays put, and after the insert, like after inserting C into S1 string, we advance P1 by 1. So we advance P1, but we make P2 stays put. We are doing it, man. We are doing it. Press enter. We are doing it. Let's test. Oh my god. Did we do wrong? Let's test that against the example we just did. A, B, A, B, C. P1 is already off the end. Like, what is the meaning of me being off the end of the word one? All right. You insert C. Now both strings and in A, B, C, you are done. By your rule, advance P1, keep P2. P1 is already past the end. There is nothing for it to advance over. And P2 is still sitting on C, never satisfied. So trace it. After inserting the character that matches C, which pointer has its job? Oh my gosh. What is it saying, Americano? What does it tell us? Let's test it again. So like we should understand the position of P1. Let's test that against. If P1 is smaller than P2, increase P1 by 1, and if like I mean P1 smaller than character length, insert I, correct even if I am wrong. I stand correct even if I am wrong. Like if pointer 1 is smaller, we increase, and we make sure that P1 is smaller than the character, I mean the string length, you mean, I guess. Insert I. Like, I understood you half. Oh my gosh. I guess I need to drop my eye drops. I guess I had one, but car length, brain, not braining. What does car length mean? Like, we have two strings, like string 1 and string 2. What do you mean by that? Brain, not braining. I meant string. All right, time. Of course. String dot length, you mean? Oh my gosh, Americano. Like, the DP problems are the hardest one. You are reading too much into. Yeah. Let me. Oh my gosh, brother, the weather is hot. The question is hotter, and oh my gosh, come on, man, come on. We're gonna do it. Like like this is easy, man. We just need to know like how to translate inserting, like insert operation into code. As far as I see, I yeah, you are the hottest. You are the hottest, man. Come on. The weather is hot. The question is hotter, and you are the... So like we're gonna handle this, all right? We're gonna definitely handle this. So let's recap what we have. All right. I mean, why I don't see the, I guess, yes, wonderful. So what we have is string 1 and string 2, and we have two pointers, P1 and P2, and the example that AI gave us that AB and ABC. So now we are trying to understand that like they match, A matched, B matched. So like P1 was at 0 and they match, we increase, so P1 is here, and again match, but we are at the end of the thing. So like, but what I'm trying to understand is after the match of B's, what is the value of P1? Is it 2 or still 1, since it stands on the edge of string 1? Like, come on, man. Anyway, let's test it again. You just did word 1 AB, word 2 ABC. All right, P1 is already off. But like, what does this mean? Is already off the end of word. So like, is P1 2? Is P1 2? I mean like a 0 1 2. So like it is out of edge, right? Or 1 already off the end of nothing left. P2 points at C. You insert C. Like, where do we insert? Like, are we inserting, like, I mean, like, we have A B, like, I mean, A B, this is 0 index, this is 1 index, so P1 was here. All right, we moved there and we moved once more, and we insert C where the P1 points at, right? You insert C. Now both strings and in AB, you are done. By your rule, advance P1, keep P2. P1 is already past the end. There is nothing for... Americano, are you ready? I'm gonna show you some magic, all right? I don't understand at all because I'm a visual learner. What I need you to do, are you ready? What I need you to do, connect my blender, and create an animation for this face specifically. And specifically for the example we have now, like AB and ABC, because we need to see we need to see like how these pointers work exactly. Are you ready, guys? Are you ready? We're gonna create an animation for this problem so that we're gonna understand it. All right, understand it. So P1 is 1 and 1 is its limit. Yes, this is the endpoint. So we inserted C at C1 C1 minus 2. So P1 is 1, but S1 length is now 2 or 3. After we insert, its length becomes 3. So PT return. What the heck is this? Wasting tokens like this is just no, like I just wanna learn dynamic programming very bad, Americano. All right, very bad. I've been trying to come this point for a long time, and I have failed tons of time understanding recursion, binding, dynamic, backtracking, dynamic programming, and graph. And finally, I feel like I can understand some stuff. So, and had some interviews and I've seen that they ask these questions with my own eyes. So for a bright future, what I just need to do is focus on this, understand this, internalize this, share my knowledge with people around the world, and apes together strong, you know. We're gonna do it, man. Like, Blender MCP is announced recently, and it works amazing with Cloud Code. Like at the animations, let me show the couple of animations that I created, or even better, like this is one of the animations. All right, this is for heap. Like, this is just wonderful, man. Like, this is just wonderful. Like, I don't know, like it helps me. It helps me, bro. Like, this is the extract phase of heap. I mean heap sort. All right, all right. I move this slider and like see how like because I strongly believe that the people that who discovered these algorithms was like they must be drawing on table or something. All right, like look at these, look at these, man. Come on. Isn't it just wonderful? We're gonna uh we're gonna understand this, Americano. We're gonna do this. We have to. We have to. And also, it doesn't consume that much of token, to be honest. Like a medium, we have to. Yes, yes, we have to. We have to. There is no way other way around. There is no way other way around. Um, like I mean, like this part I didn't understand. All right, like is P1 at index 2 or not? I don't know it. I don't know it. Like, we had pointer 2 over here, and we moved it there and checked P1 and P2 again. They are same. So we moved P2 once more, but what happens to P1? We're gonna understand it, bro. We are gonna so understand this. All right, now what should we do? What should we do? What should we do? Like, it moved P1. What? It moved P2's pointer past to I mean, like, it will fix. Just wait a second. So it will handle it. Because it tries and then it takes a screenshot and try to fix it. It takes some time. Oh, it is rendering. Oh my god. It shouldn't render, man. Rendering. No, no, like, no, just wait. Actually, it would be better if you didn't start rendering, because before that I need to make sure that the animation is all right by sliding, the cursor in the animation field. So create a memory about it, and the next time you create an animation, before starting rendering, just let me see the animation, all right? Because rendering takes time. Rendering takes time. Should we stop this process? Oh my god, this is from yesterday, I think. Task. Now it is time. What was our question name? Edit distance, right? This time, yeah. Actually, not. It was topic, I think. Edit distance, DP problem. All right. Like it started rendering, man. Oh my gosh, it takes time, bro. Like 10 minutes or something. It's like 165 frames. I guess. Yes, I guess it is. Are you done? I guess it is done. So let me see. Are you ready? Americano. Actually, let us see the animation. So it is then it. No, actually, no. Like, just look at it. All right. Yes. So we have P1 and P2. You are ready. Go. Um, we are P1, P2. Yes, they are matched, and then B. Yes, they are matched, and yes, yes, they both move. Word 1 is finished. Word 2 still has C. Yeah. Insert C. Yes. P2 advances. P1 stays. Oh my gosh. Why? Why? P2 advances. P1 stays. Why, man? Exactly. Oh, like this is the last idea that I would think. All right, this is the last case, like last option. Like P1 stays put and P2 advances. Oh, each process advances everything. P1 didn't advance since it took another action. Uh, yes, yeah, you sound very reasonable. You sound very reasonable. You sound very reasonable. Basically, each turn they need to move right unless they do something which consumes their turn instead of moving. Yes, 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 but oh my god. Like like we check AA, they are matched, move. Like move P1, P2. Wonderful. BB, they are matched. Move P1, P2. Wonderful. Now word 1 is finished. Word 2 has still C. We insert C at P1. Oh my god. Oh my god. The pointers are bounded until the process is complete. Uh, Set process being matching the string. Process being matching the string. The pointers are unbounded until the process is complete. I didn't catch the last part, but let us continue. Like this animation is good. This animation is good. All right. Now back to lesson, the animation. Since P2 is for reference only, P1 is the only thing that is important. Like P1 is yes. Like I will understand it. Like I will understand it. Like let's continue, right? Now back to the lesson. The animation is making concrete. You earlier said insert advanced P2, keep P2. Yes, yes, yes. The inserted character matches, so the target character is satisfied. P2 moves on. It is like as we insert C, P2 is satisfied, so we move it. So uh, like like I see that P2 is satisfied, and like why don't we just move P1 too? Maybe I'm seeing a mission. No, no. You are like you understand this part better than me. Um, like my question is now is that why don't we move P1 too? Because like P2 is satisfied after we insert it. Yes, yes. But isn't P1 satisfied too? So um so I understand that like when they match, we move both pointers forward. Wonderful. And in our case, word 1 is finished. Now we insert the character P2 points. Yes, all right. At the position P1 points at. Yes, I understand this. And then we move, like we only move P2. But for me, I think that we should move P1 too. Because now they are both same, right? Why don't we move P1 as well? Let's see. Each turn, they can only do one action. The program states that they should move right and consume their own action. Yes, however, doing any of three, like insert, delete, etc., yes, consumes their action for that point. So P2 can't move forward since it consumes its action to add insert operation. So apply insert operation. So, but P2 didn't do any of three. Like my question now for you is that P2 is not gonna do anything at all because all the operations are made on P1 side. But P2 didn't do any of three, so it needs to move right to satisfy the condition. Like, but at least I the thing I understand is we are using P2 pointer um to know, like to understand what should we do, like right? Um like it's like a reference. P2 is just like a reference. So obviously it should continue going forward. The P1 is quite important here, right? Because P1, like a P1, I mean P1 has two jobs, all right? Like P1 has two jobs, all right? Has two jobs. One is uh moving, I mean uh and the second one is operation, I think. But P2 is only moves. Is only moves, all right? I don't know. Let's continue. That's the exact right question, and it is the heart of my why insert isn't equal to match. Let me hand you a case where it bites. Because in our AB to ABC example, word 1 is already empty, so nothing moves regardless. Take word 1 AC and word 2 ABC. AC and ABC. AC and ABC. AC and ABC. They match, so we move pointers forward. And now they don't match. Yes. What should we do? There are three. Actually, is there a like? Are there three options, or like since we cannot insert, maybe there is only delete and replace options we have. Let's read it. Match A, both advanced. Now P1 is on C, P2 is on B. Mismatch. Oh, you insert, you insert. Oh, no, no, no. We can insert, we can insert. It says. So pointer 1 is here, pointer 2 is over here. They mismatch. What we do is like it is 1, right? What we do is inserting B to index 1. So like we had AC and P1 points to here, and we insert B. So, and C moves right. So it becomes A, B, C. Because we insert like a P1 is 1, P1 is 1, and we insert B. All right, so the C moves right. Oh, so you are thinking that it might add a blank space, so P1 should insert it. Actually, this is what you are talking about, right? So, not blank, but I don't know, man. Like, what I just realized is that when we insert B, I mean, we insert something, the character moves like they move right. That was for earlier. It doesn't make. All right, all right. Um. All right, all right. So like this is something we should know about inserting. All right. Um. When you insert a character where the pointer 1 points to, the characters move right. All right. And you remember what we asked, right? At what position, what character? So at, oh my gosh, oh my gosh, at position 1, like at location 1, all right, at location 1 we add what pointer to points. Like this is what, this is where, this is right, where. All right, like this was my argument. Oh, I got it. So now it matches at C. Yes, yes. Like we insert B where the pointer 1 points and C moves right, and now the strings are matched. Like this is good, guys. This is good. This is wonderful. So these are the questions that we had. All right, that we had, and we solved this issue using 2 pointers. 2 pointers. We have string 1, string 2. We have pointer 1, pointer 2. We check if they are matched. If they are matched, no problem. They go forward. If they are not matched, then we have 3 options. And now we are talking about insert. phase. And for insert, we have like we need to know where to insert and what to insert. For where point one points at, and what is where like the thing that p2 points at, right? Wonderful. So like I want to take a screenshot of it and open our notes over here and paste it over here. And also we have our animation over here, right? And it is rendered. All right, so fine. Match A, both advanced. Now P1 is yes. No, answer this. That I guess we understood this part, right? And the follow-up. If you move P1 to right now, I guess we understood it. So I guess we understood it. So we studied this example. So thank you. Now I need you to move the camera to the right, and in our notes we have like a cinematic camera movement convention. So use it and move camera to another place, and there show this example. All right, the AC and ABC example there, and show the show how the pointers move there. So that in one example, like in one Blender file, we can show these two example cases, and then we're gonna continue with deleting and then replacing. And don't render, all right? Please don't render until the end. Wonderful. So now, guys, we can focus while it is building its animation. We can focus. Like I guess we understand, like we have understood the insert operation. We have our pointers, and we use pointer 1 for its own purpose and pointer 2 for its own purpose. So now, like we now should think about the delayed operation. I think the delayed should be easy, right? Delayed. So again, like we have string 1 and string 2, like a pointer 1, pointer 2, and there is a mismatch. There's a mismatch. And again, I guess, guys, we should delete what the pointer 1 points to, right? Because like as we said earlier, like a pointer 1 has two things, like a moving and operation. So it is like an advanced version of P2. All right, this is like it is more capable of P2, like than P2. S1, S2, right. So let's say, let's assume a case, like let's try a case where AB and AC, or let's say BC, like the first string is B, and then the second is C, and pointer 1 points to here and pointer to here. So what like we can, let's say we can try inserting C, or like this is like, since we have three options, all right, we can insert C, and our character, like our first string, can become BC, all right, and this is not a, let's say, logical operation, right? And if, let's say, when we delete, our string becomes, you know, empty, like we delete the character where the pointer 1 points to. I guess it is easy, like delete operation is quite easy, like we just delete the character pointer 1 points to. Now we can focus on like delete was easy. Now we can focus on replace. I guess after after understanding inserting operation, the replacing is easier, because as you guess right. So what do you say, guys? Americano, what do you say? For replacing, how should we do? I guess I know it. I guess I know it. Can you type it down? Can you type it down, guys? For replace operation, how would you do that? You have your string 1, string 2, pointer 1, pointer 2, and there is a mismatch. All right, let's say B and C. Come on, Americano, are you there? I'm gonna answer by myself otherwise. 3, 2, 1. I guess what should we do is sorry, I zoned out. So there is no problem with that. So no worries, bro. No worries, no worries. What should we do for replace is replace the character where the pointer 1 points to with the character where pointer 2 points to. All right, let's say you have B and C, so that you basically make B to C. But maybe also we should care about the moving part too. Like for example, in insert, like in insert, like when like let's open this another case. All right, so let's open another case. Like here, A's are matched, B, C are not matched. So what we do is, like, this is an insert operation, by the way. We insert P2, like P2's value to the place where pointer 1 points to. But what we need to, oh, sorry, what should we focus on is we increase pointer 1 and pointer 2 after inserting, like at least in this case, like we up that. And also, like, yes, so like we insert the element and we move forward pointer 1 and pointer 2, and they are same, and then we still we again move them forward. I think I just continue. If it has the same number of character but mismatch, use rep. That's a wonderful thinking, brother. That's a wonderful thinking. So you are saying that A, B, C, D, E, F, G, H, I think. If it has the same number of characters but mismatch, use replace to change the current P1 to be the same as P2. Is S1 has more than S2 and there's an extra character causing a mismatch. I feel kind of lost here. Wait, no. P1 didn't increase. It still stayed at C. Its index just increased since P was added, but it didn't move. It's still at so just relax. We have animation. So are you talking about insert operation or replace? So like because AI created the second animation, like in this example, the word one, like the length is different. P1 couldn't move since its turn was used on inserting. Yes, I think yes. I'm trying to understand. Yes. So at this example, the operation, like we insert character to P1's position, and as you say, it consumes its operation, right? All right, but we can move the pointer too. Oh my god, like understanding this part is harder than understanding this one. Let's say, but again we have like again their length is different. Like A's are matched and BC is not matched, mismatch. The difference, I guess in the first example, like the first two characters are matched. All right. In the second example, before the word one is ended, we are having mismatch. In that case, but I guess the the logic is same. Like inserting a character where P1 points at or points at. All right. The logic is same. Like here, pointer one points here, and we add the character like a P2 character here. So like the logic is same. All right. Like at this part is same. But for this part, like for this example, for this case, again we insert the P2 character to the P1. I guess you may be a little bit wrong, Americano, because here we both like insert and move P1. All right. Like this is the like this is another case, I think. Like we insert the element like P2 element to P1 and then move P1 again. Yeah, I'm no, like you're not really wrong. All right. So like the thing is, we have different cases. All right. For this case, this is as you described. This is exactly as you described. But here, it is a little bit different. So the common part, like the common part is, you basically insert a character to P1, like a P1 position, and which character? P2 character. All right. This is same. At least just understand this part. All right. Wonderful. Like understanding this part is more than enough for today. All right. More than enough. Oh my gosh. So where were we? So like let's say like you said this, if nothing mismatch, like what we do, like if we are doing the same thing, all right, we will add oh, like if we insert here, like if we use insert operation here, we're gonna get something interesting, because let's say we insert E to here. All right, so after the insert operation, the first string will be E, A, B, C, D, and then the second string is same. Now the pointer one points here and pointer two points here. Again mismatch. Again we add this character to here. All right, and then like a string one becomes E, F, B, C, D, and then the second string is still E, F, G, H, and then pointer one is here and pointer two is here. Again, we're gonna, I mean, like the length of the first string will increase. Like this is what I'm trying to show. Like a string one, E, F, G, C, D, right? Am I doing correctly? And string 2 is E. Oh, I got it now. Wonderful. E, F, G, and now pointer 1 is like here and pointer 2 is here. Like, did I, like, why the, no, like, this is slightly wrong, because as I add F to this position, here uh here I should have started from A again, because we moved this part to right. All right. So we can create an animation for that. All right. We just don't need to write, but the changing part is correct. All right. So let's see what does the AI said. So yes, just insert it, not replace. So I just wanted to use replace, like I mean insert operation here. But I did it slightly wrong, because I didn't move the string one to right correctly. Both examples live in yes. So I guess, guys, we were talking about deletion. I mean, yes, deletion. I'm a bounce for 5 minutes to buy the. All right. Sure. While you are gone, we're gonna finish this question. While you are gone, we are gonna finish this question. Americano. It is not possible, but let us try. So we have deletion and replace. I think, let me tell you this. So thank you for that. Now imagine your first string is A, B, C, D, and then the second string is D, E, F, G. I want to see, no, sorry, E, F, G, H. So what I want to see is like a insert operation. Like I want to see an animation for like animation where we only apply insert operation. All right. Again, apply the same camera movement and create an animation for that. All right. While it is creating that animation, we're gonna try understanding delete and replace, but actually understanding insert operation is more than enough to understand delete and replace operations, guys. All right. So it is just like too easy now. Like we have string 1, string 2, pointer 1, pointer 2, and when we find mismatch, what we do is just like deleting the character at p1 in string 1. That's all we need to do. And for replacement, again, we should replace the character at p1 with p2. So basically, when there is a mismatch, so now we understand it. We understood, guys. When mismatch, we have three options that we should explore. Like this is the another word that I really like exploration, because to explore we need to make some choices. And what are our choices? Well, our choices are like a insert, delete, and replace. So understanding insert is like more than enough. So now when we find a mismatch, we're gonna explore insert, delete, and replace. And imagine an R function, like let's say we have our function here. All right, let's say S1 and S2, and also I think we should have our pointers as well as parameter, pointer 1 and pointer 2. And in somewhere in our code, we're gonna do insert. All right, let's do it like, let's type it this way. All right, in somewhere in our code, we are gonna insert. All right, and this is gonna return us an integer value x. All right, and then we're gonna make again, like, I mean, we're gonna call our recursive function again, applying delete. I mean, yes, like it, like not applying delete, but this is gonna explore the option where deletion is happened, like a done. And in another like our next, like our third option is replace. All right, so like we're gonna call all of these and they are gonna return some value. All right, like some integer. And as a root, like from perspective of the root, what we need to do is, you guessed it right, return, you guessed it right, guys, return the minimum of the, like minimum of these. All right, if you wanna visualize this, you could like as I like a draw tons of times, they are like, they return some integers. All right, they like for example, we have like other options here. All right, I just don't draw them, but they are there. All right, uh like 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 understanding recursion, to understand recursion, we shouldn't draw them at all. All right, but I just want to show you like these are the discover case, like these continues. All right, these continues, like at least this can continue for as long as it wants. There's no problem with that because we solve it in such a way that uh, it solves everything. All right, it solves basically. So this is a sub problem. This is another sub problem over there here, and then another sub problem over here. All right, and those sub problems are returning some values like a x, y, and then z. And as a root, what we do is, as you guessed it right, we return the minimum of those values. Wonderful. Now the remaining part is like a like a handling, like a this part, like a we type it as insert, but how would you like, I mean, how the welcome back welcome. So like while you are gone, I just show these like these are decision tree basically. What we do is like a insert, like we discover, like we explore insert option, we discover the delete option over here, and we discover the replace option here, and we want to make these calls return an integer like a x, y, and z. Like let's say like this means that a minimum number of operation that is spent if you make insert operation. All right, and you discover like obviously you're gonna do some other operations too, but they add up, they accumulate, and that x value is like a minimum number of operations required if you pick this option, and same as y and same as z. So as a root, we return minimum of them. So this is the overall function structure, and now it is time to like translate these parts. All right, like we said, like we written this as like insert, delete, and replace, but now like our parameters are string1, string2, like a pointer1, pointer2. Now maybe even better, like manipulating our strings, we can call our recursive function with those. Like let me type it down again. Let's say we are doing insert, all right, insert operation, and like how should we pass the arguments? Like we have s1, s2, pointer 1, pointer 2. For inserting, we set that, let's say ab, ac, b. So we insert p1, like index p1. So let's say like when this call, like when this function called, let's say we are like when this function called, the let s1 and s2 as like a ab and acb, and now we are doing like we are gonna call this function such that it represents inserting. All right, this is what we are doing right now. To animate, all right, the insert, we basically, like our first string will be like like a acb basically, and the second string, like of course, yeah, like acb because we inserted, and then second string is already acb, and pointer 1 is like this one, and pointer 2 is this one, like, but like we have done this manually. Maybe we can make use of some helpers, like a like a like a insert helper, and we can give our parameters there, and that function will return a string like this one, and we give these like we give its return string as a parameter to function call. All right, all right. So let's see how our AI created that animation. I think it is just, it created beautifully. All right. All right, now I can ask. Now I think we are done with this question. Let me explain what we have designed to AI and let it verify and check and judge a little bit if it can find or maybe we can type it down. Oh my gosh. Like there are two phases understanding lead code problems, all right? One is the core logic part, like which is the part we already studied, like this is the core logic part. And the second one is like writing the code. So I guess we like I have pasted it, right? What was this question? 33 some, I think. Writing the code is where things turn. All right, all right. So we're gonna do it together. All right. Um, yes, it has. All right, are you ready, man? Like we're gonna type the code together. All right, let's start. So like let me type the overall structure first. All right, let's call it int, I don't know, let's call it void, I don't know, like let's start it. All right, I call my recursive functions as func. All right, this is the recursive function. So like integer x is equal to recursive function call where we apply insert operation. All right, and integer z is equal to function delayed. All right, and it no, like y, it should y, and z equals to function replace. So all right, so now we are gonna return the minimum, like we are gonna use math class for that. There is a min method there. Minimum of x, y, and z, I think, but as far as I remember, matmin was using like a two variables. So maybe integer min first and matmin x and y, and then min first and z. So we return that value. So this is the overall structure, all right? This is all, like, we are discovering our options. And our function will get integer integer no string s1, string s2 are pointers now, like an integer pointer 2. Now, as I said, now we can type the helpers. Let's say private private. Why do you need to put x and y into single? You are definitely right, because, like, I'm not sure, but most probably matmin doesn't provide like this. I don't know, but x, y, and z. Let me ask to AI, because I haven't seen it, like a. Is it correct in Java? No. Yes. Is that correct? Will because completion error. Strictly designed to accept exactly two arguments. That is why you can put only two arguments into this method. Yes. Only two. Like if we were using Python, like we definitely be able to put any number of elements as we like, but in Java, like, you need to know the function name and function parameter. Yes. So let me type the helper, like a private, let's say void insert helper. So what this method gonna do is I want this to return us what do we need, guys? Return us the like an inserted version, right? We need to know what is the value of p1 and p2 when in the inserted version, and what is the updated version of s1 and s2. We need to know these, right? So, but where are gonna be insert? So, like, we have, like, again, we should have string s1 and string s2, and like we need to have all of these, right? We need all of these. So the rule was insert the s2, I mean insert character at, like a, we should insert the p2 to s1 character at, like we should insert the, like, this character to this place, all right? This character to this place, but I think we should use another data structure or something, because strings are immutable. right? Or maybe we can create a new string. I don't know, but they are immutable. So uh, like we should search how we can do it. But for the sake of time, let's continue. Let's assume we insert it. All right. And actually we like mm, maybe we can make this method return string. All right. And this string s1, and we can make what this method return as a first first element, first parameter. I guess we can do that. And also we should increase the p1, since like we inserted, and like in the animation, as you can see, uh let me like not this but this, like look at this. All right. We like they are like now it is mismatch. What we do is like inserting p2 to p1 and then move pointers. All right. So uh, so we moved pointers here like a p1 and p2. S2 is same, and what it returns is inserted version of s1. So we're gonna handle this. I don't know how to do it, but we're gonna handle this later. um, this is the insert helper. So now let me type delete helper. All right. So I guess we need all of these methods again. Now what we are gonna do is delete like a delete the character at uh, at 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 p1, like a string one character at p1. That's all I think, and that's all. And we should move our pointers forward, right? Like this is delete helper, and let me type string replace helper, and again we need all of them. Yes, we all need all of them. So as we do in insert, again the same logic, we should replace, I mean replace the character at s1 character at like a change this character with like a replace this character with s2 character at p2. Like we are replacing these two, and we're gonna move the pointers forward. So um, welcome, welcome in time. Welcome in. Um, so now we're gonna copy this, and I think we should give the all the parameters same again for this method. And still with math, no, like now we are solving a dynamic programming question. Like this sounds better. Dynamic programming question. We've done with matrices. Now we are dynamic programming, which is which is what optimization, I think, right? Yes, it is optimization. It solves some sort of problems very fast. The dynamic word doesn't seem Yes, you would be right. Definitely. This is like it is not easy at all. But together with Americano, we studied a lot. Like we studied very well, and we understand the insert operation. Like there are two operations, like three operations: insert, delete, replace, and we understood the insert operation using Blender as well, of course. Thank you, Blender. And now we are creating the code part. We are coding what we structured, what we designed. Dynamic is understandable at least rather than yeah. So like yes, I definitely agree with you. Like 2D arrays, like I don't like, but in dynamic programming questions too, there are some questions that you use the two-dimensional matrices, especially for bottom up version. Now we are applying top down. So we delete after we delete again. We should increase our pointers, and I think I can copy this part, all right, and paste it over here, and just change the name of the function. But the thing is, in the animation, uh, uh, let's say like we don't care about this edge case. For example, word one is like a finished before the word two. I think I regret entering. No, like I strongly suggest you to work hard. That's all. Working, studying frequently, listening lectures front rows in class, reviewing them when you come home back, asking questions during the lecture, asking questions to TAs, like doing your homework, quizzes, projects, doing your midterms and finals. That's all. That's all. Um, but I mean, like you should study hard. Like, I didn't at least for first 2 years, but at third and fourth, like I was sleeping in uni. At uni, I was not going home for some time. We can't ask questions on our professor since he just tells us to says like this is understandable, but you can definitely ask questions to TAs, teaching assistants. Do you have teaching assistants for each? Uh, think about the money. Yes, yes, exactly. Do we have TAs, Americano? Like, of course, like at least at the end of the lecture, like as soon as the time is up, I was I was running to the professor and ask a question like into 1 or 2 minutes. But if you can't do it too, you can ask him. We don't have that. It says, oh, I think, I see. Uh, then you need to do self study. I am teaching myself coding, relying on uni is for unwanted apps. I'm teaching myself coding, relying on uni is coding notes for unwanted apps. We went to the school's main branch and the quality is just superb. Here though, it's kind of meh. So like you can use AI to make it to teach you coding, and we can study together. Like in these streams, I'm gonna be studying object-oriented programming, developing some games on C sharp, like on Unity using C sharp. I will like we will create some Java applications together with you guys. We're gonna, like I said, the object-oriented and leetcode, and we're gonna learn, like I'm learning Python too. We're gonna I'm gonna do some Python sessions too. So if you guys know, like if you guys want to learn Python, C sharp, uh, C sharp, what is it, man? All right. So let me So if you want to learn like a Python, C sharp, object oriented program, anything, we can study. We went to schools. Yes, yes, yes. So money is what makes us. So money is what makes us move, and also like it is needed. Like if you create your life, I mean, have a life, have a study life. If you wanna, have a family or something, you should definitely, be earning some money. Python seems fun. I will catch up with you in summary. Sure. Yes. Yes. Like I know some basic syntax, like a for loops, while loops, and like I have a small ERP program that I created using AI with Python, and now I'm rereading, like reading the code part. Actually, like this project is like, let me show you guys. This is the project, like a policymaker. And in the last stream, when I studied Python, I learned this syntax and also this syntax. Like this syntax we don't have in Java, but in Python, you like these are the parameter names of the original method. You pass the value like a content user, but these are the literally parameter names of the ingest PDF method. So yesterday, like I mean the previous streams, we studied this, and I learned this. And also these are basically like these are types. Like a DB is type of session, user is user type, and like that's all. That's all I know. I don't know this part at all. Like I get it has something to do with metadata, uh, but I just left it for later. My focus on Python will be for cybersecurity more than apps and sites, I think. Python looks so clean, Java is just two verbs, yes. Though not as much. Yes, yes. So like maybe we can set a challenge for us and learn C together too. Like I want to learn Python quick and fast. Sites, yes, yes. I understood that. Um, like I'm learning Python, I'm learning C sharp, and I'm creating projects using Java, and also I'm studying leetcode problems. Like Python is like everyone says Python is easier, but of course there are some frameworks, for example, Fast API that you need to learn, I guess. Like because basic syntax, the fundamental syntax is easy, but knowing this AP framework, you know, I want to learn C. It will for making my own Linux kernel. That sounds amazing, bro. Like that sounds a real job, real work. Like I don't know how they build such things, like such level things. Uh, it would be a challenge for you. Uh, yeah. So guys, not a chance. I need assembly too. Like we created, like guys, let me tell you this. During college, like at uni, we created a program where I think you just calculate the length of two strings. All right, like in assembly, we created a code calculating the length of two strings. Like we create a function that takes arguments. I'm as far as I remember, and like yes, like, like this may sound simple, but it was too hard. Uh, read Nan to Tetris for making. Oh, the entire project is just super. Let me look at it, bro. That sounds cool. Oh yes, yes. We have done this kind of stuff. at 40 universities, high school boot camps, the students who take them PhD. Yes, yes, yes. Projects, Boolean arithmetic, machine language. Yes, machine language. Yeah, yeah, we've seen this during college. At third year. Yeah, yeah, we've seen this. By the way, I am by the way, I'm a Linux user. All right. I'm still at project one since it's super boring to learn alone. We can learn together, man. Project one, you are saying like which one is the project hardware? All right, we can do this together. Java, Python, yes. Yeah, binary code. Nah, I want your time. I'll learn it my own pace since summer is coming up. All right, all right. Like we've seen this in third year in uni. Second or third? Mm-hmm. Focus, focus. Wow. Abstraction, implementation. Like this is why Java and C and language like that is called high level. You just basically need to code the logic, because when you go into low level, you're gonna have to like think about lots of things. Cinema, especially uh oh, Linux means cinnamon, but all right. So where were we? I guess we were typing the code. We were exploring, getting return values, which is amazing, and then returning the minimum of them. But the case that we are not thinking is like a this one, right? Because this is the edge case, um, and we should handle it carefully. Oh my god, the timer is paused. Oh my gosh, I'm waiting for it to go to, let's say, 0, and I've seen that it is 41. Oh my god, guys. But how many minutes it's been? 5 hours, and I guess it is. I guess I can go one Pomodoro, right? Skip this. 5 hours. I guess we are in the five one, right? Skip one more. Yes, we are in five, even more. Uh, let's say 25. Yes, even better. Let's make it 20. Anyway, 25 is fine. Fine. Are you asking to me like which time zone? Like you are? I think it is three, like a uh, GT, not GTA. Which time zone is Istanbul? GMT 3, I guess. Yo, no, UTC 3. Uh, yes. Oh. So the question, actually, let me share the code with AI. Oh, actually, we need to solve this part too. 6 hours behind. Yes. So it is 9 p.m. there. Yeah, brother. Yeah. So I plan to, do a 12-hour long session. Like my goal is like a going up until the mark 30, all right? But now we we are at 43. No, no, like it doesn't use. Turkey is it doesn't use. Mm, like we can take a break a little bit, like maybe 15 minutes or something, guys. Maybe even 20. I don't know. I could eat some food, like I could had lunch. Maybe 30 minutes. I need to have my lunch. Apologies for the topic. No, brain just refused to. Yeah, yeah, you are right. It refuses. It's like it refuses. But before the break, it would be great if we understand this part. Segways. Let me type it down. Segways. It is a good word. Segways. Topic segways. Um, like let me ask this part to AI, and then we can think about this case, all right? Because I don't think I will be able to handle this case where the first word is ending, like a length of first word is smaller than word two, all right? We need a case for that, like a even the same insert operation. Oh, let me think for a second. I think we need to, like, we can handle this here. We can handle I don't know. Let me share the code with AI and share our intent. Now, like this is the structure we have. Now I want to focus on the helpers. What we need there is inserting the character at P2 to the character at P1, and which data structure and which method can we use for this reason. What do you suggest? And like, can you help me, like, can you help us for like delete and replace helper as well? But don't dump the code, but guide us. AI is so useful, but it is a double-edged. Exactly, since we build people like tend to leave everything to. Actually, let me be honest with you guys. I have spent lots of time building lots of apps, but I haven't touched the code, but instead focus on the, correct open source project that use, or the structure, overall structure. And at the end, it's been months. Like I've created lots of good projects, but I learned a little, all right? So I have spent, like lost or I have lost some time. So you are exactly right. It is a double-edged sword. Now I created my own tutor skills. So when I want to learn something, I activate them, activate one of them, and it teaches. All right. It doesn't give you the full answer right away, upfront. Good, you got the recursion skeleton down. Before I answer which data structure, let me catch something, because I think you are asking a attempted solution, not the real one. The literal answer, so you have it. Java string is immutable, so you'd reach for right. The correct method, like a correct class, is string builder. Yes, that's the mechanical answer. But now, say your question. Predict before you build. Think back to animations. When you did the insert in example one, what actually changed? I guess it is asking this part, but we already shared this part, so I guess it knows. Predict before you build. Think back to the animations when you did the insert in example one. What actually changed for the next step? Did word one need to become brand new string? No, I guess. Or did you just need to know where the two pointers? Huh. No, I should know it. Rewatch frame 122. Oh, like it is asking this 22 and 40. there is there is nothing there. Oh my gosh. So here's what I want you to answer. For insert, instead of insert helper returning a new string, what could the recursive call look like using just P1 and P2? Fill the blanks. Same for delete and what is the pointer move for each? Like we already moving our pointers in our recursive function, but I guess it says that instead of returning like creating a nub string, just use pointers. But I guess we need to create our like a new. I mean, like we are inserting, all right? I don't know. We are inserting, but if we use the same string builder, maybe we can handle it. Look at your three recursive calls right now. All three use. Does that look right to you? Does that look right to you? Yes. Yes, why not? They look right to me. Um, I mean, like, for example, like this case, for example, like this case, like we insert and we move our pointers. Like this is correct, basically. All right. Mm, I don't know. There is this case where every character is different, like every character is mismatch. Insert P1 plus plus P2 plus plus delete P1 P1 P2 plus plus. No need to ask why. So you are saying that for deleting, we don't change P2, but increase P1. By the way, at the actually you are pointing something great. Yes. Yes, you are pointing something great, man. I kinda understand it. I kinda understand it. Does that look right to you? I don't know. Does it have to? Oh my god. So I guess what you are trying to tell me is that instead of creating a string, maybe we should just handle like a or operate or manipulate our pointers such that they represent those operations. Like what I mean is instead of inserting a character like literally, we just move like a move our pointers, right? Like this is what you are trying to say, right? Oh my gosh. Are you living in uni? I mean in Durham, right? Let me uh dorm, right? Dorm, dorm, or your maybe family. Exactly that. I'm on a boarding house around 2 kilometers. So nice. So you can go to your uni by walking, right? That's wonderful because I was spending almost 1.5 hours to go to my college actually, but I was in my grandmother's house, so it was good actually. So what I mean is being close is good. Yeah, it just by walking for mine. So that's nice. Like very nice. It is a good distance. Optimal distance. Exactly that. You don't touch the strings. Oh, Americano. It is as you said, bro. We don't touch the strings, but instead we manipulate our pointers and imagine or assume that we just pretend. Yes, pretend. We pretend that we put, as I said, type and pray. Yes, yes. You don't touch the strings at all. The operation is the pointer move. Pointer move. Pointer move. I think I can save it. Pointer move. And if you understand insert operation, then remaining ones are easy. Special things to Americano Americano beans. Thank you, mate. We studied this together and I understood. Um, you don't touch the strings at all. The operation is the pointer move. The whole string builder machinery disappears. Each helper becomes a single recursive call with different pointer. Oh, yes, 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 yes. Pointer, like a pointer arithmetic. Wonderful. Pointer arithmetic. Pointer move, pointer arithmetic. So fill them in. You already reasoned through all three insert. All right, guys. All right, guys. Um, boarding house. Let me type the boarding house too. Like, what does boarding house mean? Boarding house. So, guys, now we should do like we should paste like we should do some pointer arithmetic. So, for insert, let's say we have these two strings. So we have pointer one, pointer two, and let's say AB and AD. All right. So pointer one here, pointer two. Usually a room, which is my kid. All right. All right. Um, you have your, individual room. That's good. Um, now they mismatch. Oh my gosh, I need to take a break, but I want to understand this pointer arithmetic, man. Ugh. So we are inserting P2 over here. But the thing we need to focus is how we handle these pointers. I mean, let's say we had AB and we insert D, like a D B. Now it becomes pointer one was pointing to here. Yeah. And pointer 2 was pointing here. Yeah. So should we like why should we move it? Or why should we even care moving it? All right? I mean, what would happen if we don't move them at all? These are the questions I have. Let me type it down. What would happen if we yeah, why not just change it and be done with it? What should happen if we move them? Like I can feel that we need to move them, but why? I mean, like because we can move P1 or P2 or maybe together you can move both of them, maybe one of them. In that case, which one of them? All right. I think we should we should try every case and let's see what happens. Let's move P2. Now P2 points here. Let me pick another color. Like let's move it here and let's don't move P1 and then another mismatch. And should we insert empty at pointer 1? No. Uh, let's move it. All right. Let's try the case where we move. So we move pointer 1 and pointer 2. I mean, pointer 1 is there. Pointer 2 is there. Again, they mismatch. I guess at this case, in this case, we should just return false. I mean, maybe because there is no possible way for us to find transfer convert this into this when our pointers are at these indices. So when you reach here and if they are not same, then stop the exploring, I guess. uh yeah, I don't know. I should take a break. I feel quite tired. My brain refuses to study, as you say. Like, what did you say? Refuse to function, refuse to learn. um yeah, in the break I will check my OBS settings because my computer is quite hot. Maybe because of, I don't know, maybe because of some settings on OBS. So I think we can make like a 30 minutes long break, right? If P1 is pointing at something, P isn't, shouldn't you delete it? If P1 is pointing at something and P isn't, like if P1 pointing at nothing, that then that means that we processed all the characters. We're done. Like we hit the base case. Like we've done basically. Like at this is what I think. All right. Um. Yeah. Like this is like P2. P2 is like a timeline. All right. It goes like a this way, and when it reaches end, we just done it. Because by the time we reach that point, we already do every exploration, every, like we already applied these three stuff, many times. So when the P2 reaches to the end, then we're done basically. Guys, I'm gonna take a break now, like maybe 30 minutes or more. I will have my lunch, um, rest a bit, and come back again. I think 30 minutes is all right. So, um, taking a break now for 30 minutes. Eat well. Thank you, brother. Thank you. I appreciate it. So when we come back, like when we are back, uh, I wanna discuss this pointer arithmetic. Pointer arithmetic. Yes, we're gonna continue this, and our next question is count good notes three. So three questions. So basically, um, recursion question. So thank you, and let me go into a break mode. Let's set it 30. Hello, hello, guys. I am back. I guess this seems good. Um, Now we will continue with where we left off. But before that, welcome back, man. Welcome. So, before that, let me open another thing that I need to open. All right. Just give me a sec. I should open something here. Wonderful. Now, after that, we will continue like a pointer arithmetic. That seems fine, I guess. Like my computer, like a fans run, fast when I start streaming. Is it better? Music still on. Like it should be little. Is it better now? Americano. It should be better. Actually, let's move the part here so that you can see it too, guys. What I am trying to do is like making my OBS better. Yes, sir. Wonderful. Like currently I am using OBS and like I don't want my computer to use that much of space. So before continuing a leetcode, let's spend 5 minutes. We are on break. Our shutdown want me to retune on heavy. What is this, man? Study with me 3. Background. All right. Let's click on it. Yes, but I am live right now. Yes. Yes, AI is controlling my overlays. Like to be honest, I set up my OBS using cloud actually. So yes. But like my scene is not too heavy, but somehow my PC's fan is, ooh. So I don't like it. Because while we were on break, it was not running. Name it Jarvis and connect it to us. Yes, yes. So you can be like exactly, bro. Like because this cloud code makes you like a Iron Man, It's just amazing. Like we create animation using it. We set up our OBS with it. So overlays are loaded at the new FPS. Now I can do what I promised, measure it live instead of guessing read only. So, all right. Like CPU usage is 5%. It is not too heavy. But I guess on GPU side, something uses very like huge amount of sources. This is the most important measurement yet. And it flips the conclusion. Look at OBS, yes, actually lighter than breaks-in was, keeping up easily. Yes. So honest answer to make sure OBS is correct now, is optimized and not. The fan it is being driven by more Chrome and Windows Server than by OBS. AI really likes yeah, yeah. Actually, like, I'm not currently running local AI model except for dictation, like a voice ink. It is open source, by the way. You can use it too. But it works only when I am, recording. But of course, like if like I cannot run any local AI models with this PC. I should have, let's say, 192 gigs of RAM. Um, I can use only that computer. It uses lots of RAM, and CPU, because it needs to load everything to function properly. Also, the AI using your PC is on the cloud. Yes, that seems kind of dangerous. Yes, yes, you are definitely right. So, like, yes, exactly. This is dangerous. Yes, like you read your files. I mean, it reads your file, updates like a writes. This is, of course, there are certain points where it prompts you to give permission, but if something goes wrong, it can do everything. It is definitely dangerous. OBS is now correct. It's not your problem anymore. Um, it's keeping up beautifully. I applied patches to save overlays, trims. What is actually hitting your Mac? The real numbers. Hmm. Bigger than OBS. So, I mean, I should see the chat, so I cannot close this tab, but Spotify. Hmm. Not a viewer facing problem. One honest correction. I looked yesterday. I suspected the camera blur. I tested live. It's not cause. Yes. Close Chrome tabs and disable preview. Uh, what do you mean by preview? And also, I realized that, like during break, like a during in break scene, my computer fan was all right, just fine. When as soon as I switched to Stay With Me 3 scene, like my fans started, running. So I guess it has something to do with our scene, all right? Because I have little tabs on my Chrome, so it shouldn't be a problem. Like you should guide the AI correctly, all right? Because like it presents you lots of uh, possible scenarios, and if you change the course of AI wrongly, it will produce very unhelpful stuff. Let me open my this camera too. I guess it like I am using this camera and it got heated. It got hot and shut itself. Yeah, the AI is smart, but it's just too narrow. Yes, yes. So you need to guide it correctly. Two things. Let me explain disable preview plainly. Because you are probably right. Yes, but do you see it? Because you are probably right, and I overrated the Chrome reading. So what disable the big video panel in the middle of OBS? OBS draws your entire scene a second time into the dead panel at your. Yes, yes, yes. How can I do that? You right click enable preview. Uh, where is or all right, now I toggle it off. Yes, it seems just fine. After the stream, all right, I think we can look at maybe later because I want to continue with this part actually. Um, All right. Let's just restart this one. So we were discussing about pointer arithmetic, and we need to handle these insert operation. Uh, Hello, welcome. How are you, Barry? How are you doing? We are talking about dynamic programming question, and it takes quite of time. Good, good. It is good to see you here. When are you gonna stream? I guess it is morning there, right? That looks very confusing. Yes, yes. But we are trying to handle it and decompose it into understandable chunks. Yeah. So our goal is like basically making word one to word two basically, and the question is in how many steps, like what is the minimum number of operations that you can use to transform this word into this word. So we are using recursion, and the topic is called dynamic programming. We discovered that we should apply pointer arithmetic instead of creating a string builder. All right. Together with Americano today, we studied a lot. Builder. So now our focus is insert, and we have pointer one and pointer two. Um, I guess string A B, and let's call it AD. What should we like? How should those pointers behave? Like when they hit mismatch, and when we mismatch, we have three options. Um, one of them is insert, obviously. We insert this character into the position of this one. Like this is our first option. Um, yeah. So like this string becomes A, D, and B. But the question remains like should we increase the pointer one and pointer two? Because in our uh, in our solution, in every case is basically we increase those pointers, and I guess it is not a correct way. And also we are creating like a new string, so this is not a wanted option either. Let's ask AI actually. Maybe we can want uh, to create those animations. Like we have these. For example, in this case, we insert C to here. Wonderful. And then we move only pointer 2, like a P2. Whereas in this case, we move both of the pointers at the same time. We insert B to here, like the character P2 points to the place where P1 points at, which is nice. But we like increase both of the pointers. So I guess, and this is another case where we apply inserting, only inserting. Like this is another thing. But maybe we should ask AI to create an animation, like maybe add a new scene in that animation so that we can see easily how the pointers should behave. So like, can you add a new animation after the last one and using the same camera movement? All right. But here, like, I want you to focus on showing the pointer arithmetic for insert. They should be, yeah, they should behave well and correct. and not break our code or something. Um, exactly, yes. Like we are dictating. Uh, we want them to behave correctly. Like this is insert case, like one of the insert cases where the length of first string is smaller. All right. So what we do basically like a check check the character like they are matched, so there is no problem. We move two of like, both of them forward. Again match, and again we make them move. But here the word one is completed, like is done. So what we do instead, what we do now, um, again inserting at this point. So the core mechanic is same. We're gonna insert P2 to P1. This is same, but what P1 points at can vary. Like at this case, point one points to anywhere, like a space, and whereas here it points to the real character. All right. And after inserting, you move it to. But the difference is after inserting, you don't move the pointer one here. So this is the difference. So these are two different cases that we should handle. Uh, let's let AI create an animation for us so that maybe we can love it. Example 4 will be the no strings, just arithmetic view, a register panel showing P2 and P1 and P2 as numbers. The recursive call, all right. The insert animating only P2's value. Same camera arc, no render. All right. Let's pray that it will generate us a good animation so that we can understand, like we can see the pointer arithmetic more clearer. Um, I wonder how it will handle these two cases. Maybe it's because if you move both, if it is squished, and you move it right since it is still free. But if it is already at the end, example 1, yes, if it is already at the end, you don't immediately move it since it is at the tip. You can only move it after because the insertion step created the wiggle room for it to move. For it to move. Uh, let's see. Mm, or it could also just be like it never moved. So like I'm trying to put this in a phrase so that I can understand, but like at least we know the core operation, all right? We insert the number to the P1, and the number we insert is P2. And when it is matched, we just move both pointers. All right. Wait, let me articulate my thoughts properly since I'm starting to yeah, yeah. Like like thinking back, my earlier hypothesis kind of makes sense if you think of it in the context of it didn't move on example 2 and it just stayed on C. I totally get that you are getting sleepy, man. Um, so tomorrow are you gonna go to college? Or actually the summer starts, right? So do you have any, exams, or when is your holiday basically? So I'm planning how frequent we can study. um, let's see. All right, it created. Wonderful. Let us check. Let us see. Yeah, it is exam week. Oh my god. What are you doing here then? You should study. Actually, like this is another like a what we are doing is right, but I mean Good luck. Thank you. Example one, it didn't move. But P2 moved. Yes. So P1, P1, comma P2 plus plus. Yes, we increase the P2. On example two, it stayed on C and moved right. I will understand, bro. I will understand. So P1 does not move, and P, like, I will get it. Like, let's see the animation it created. All right. This is the animation it created, I think. Let's see. We have string 1, string 2. Both of them are, different. So mismatch. Let's see. So there is no movement. Come on. What is this, man? Oh, yeah. Like, is this the movement? It is the movement. So we check our characters. It is mismatch. So we should insert, right? What is +1? I mean, we are moving P2 here. So, oh my God. Like in this case, like in this example, it moved P2, but I didn't understand it at all. So basically, like A is not equal X, so mismatch. The function call is moving the pointer to. So does this mean that we inserted X into the position of P1, or actually we see inserting operation different? All right, like in this code we don't just like A B A D. All right, let's say string 1, string 2. So we just we don't insert D like a here. All right, what we do instead moving the pointer to forward. So I wonder how was it in in the question definition, like in the example, it says it shows maybe insertion like this one. All right, I think the reason why I didn't get it at first at first time is that here it shows inserting a character literally, but we don't do that. We are doing just pointer arithmetic, representing or simulating insert operation. All right, yeah, you added it to the current position of P1, which moves its index right by 1, but it's still on the same location. So it points to the same area, just that the area moved, but it's still but it is still pointing there. Yeah. So I think I should understand that we are not literally inserting that character. We just simulating. Oh my gosh. So here, when they are mismatched, all right, we have mismatch. We just move this pointer. So what do we get? What do we get here by moving this pointer 2 to right? How is it inserting, man? Like, let's look at the this one. Like forget about this one, but focus on this one. All right, so when there is a mismatch, we are inserting. Oh, I guess now I understand what you mean, Americano. We insert the character here, but look at P1. All right, here in this animation, I thought that we are moving P1 forward 2, but we don't. We're not. P1 points to same thing, all right? Yes, like this is the, all right, all right. This is the enlightenment moment for me. Uh, of course, like the character inserted here, like you can imagine, you can see it like that way. But look at P1, man. P1 points at the same thing. What we do is like a moving P2 forward. All right, that's interesting. P1 is at C. Insert B, yes. ABC, yes. It becomes A. It became ABC. P1 at C. Uh-huh. P2 at P2 was at B, and then it becomes C. Yes. The P2 moves to the right by 1. So it's yes, yes. Yeah, I see, I see. Now I see. So because while I was watching this animation before, I thought that we are moving pointer 1 2, but we are not moving pointer 1. Like pointer 1 is always here. Like, all right, now I understand it. Like if I visualize this during the interview, then I will be able to remember which pointer to move forward. Thought the same too. Yes, that's why I was, yes, yes. Yeah, yes, yes. So because like in the animation it looks like moving, right? Like, but it literally shows the same thing, like here and here. Basically it doesn't move, it points the same thing. All right. And also in the solution, we're not literally inserting a B here, we're just simulating. Wonderful. Like this is quite smart way, man. Smart way of solving this, isn't it? Like there are languages, all right? Let's say like English and Turkish, so you translate between them, right? Like this is what, like this is a translation of real world process into code. But actually we could type, like we could code the solution literally using this, but this is optimized way of solving this question. Instead of literally inserting like a, maybe creating another string or using a string builder and inserting that character to the certain position, we don't know that. I guess it is space optimization. All right, we just focus on the real important, like we focus on the essence of this problem and its requirements. That's interesting. All right, now, so now that we understood, let's think about the pointer arithmetic. All right, so we know that P1 stays same and we move the P2. So this is like, this should be our arithmetic. And instead of like, we don't need them anymore, like we don't need these functions. So we literally can remove, like a, get rid of this one. All right, instead we can type s2 like s1. All right, and let's pretend it will work, and then delete this part too. All right, s1. But for delete, let's see. So we have string 1, string 2, a b, a d, and when they are, like when there is a mismatch, like should we remove? First we should remember this and then focus on the pointer arithmetic side. When there's a mismatch, there are three options. If and we are trying to apply delete operation over here. What would happen if we delete this one? Delete this character. What do you think, guys? Our goal was to transform this into this. Like after deleting it, we end up with A. Then P1 would point at an empty space. So you are saying that for deletion, we move P1 by 1. And basically it is out of bounds for me actually. It is out of bounds. But yes, I guess. Wait, I don't think delete will work if P1 smaller than P2. Why? I think we don't care about the comparison of P1 and P2, like, but instead, if we are hitting the end or not. Just, oh my gosh. Maybe we should ask AI. Forgot we can just use insert. Like, yes, we can use insert, but now we also should know how does the pointers will behave in delayed operation. Now I'm just thinking, I'm just trying to understand the logical part, and then I will focus on the arithmetic part. Like, whereas in insert operation, we were inserting D to this place, all right? A, D, B. So it becomes ADB. So what? I guess that's all. I don't know. Maybe here all the things we need to do is like a deleting the character P1 points to and increase the pointer 1 and pointer 2. What should happen to pointer 2? Maybe we should ask AI, man. So by looking at it, we learned that in insert operation, we just move P2. Actually, no, there is no animation for delay. So maybe we can you create an animation for delay too, like after the last animation? In the same file, of course, again. Yeah, the animation would be great. Animation would be great. Let's see. Like, I didn't understand. Like, we are operating at P1 and we are using the character at P2. We either insert or replace. This is all right. But for deletion, I guess again we would like remove the P1 at string 1. But should we make forward P1 and what happens P2? Like, I don't have any idea what happens to them and why actually. Like, I don't have any reasoning for them. Because like a replace is like, let's look at the replace. All right, let's see AB and AD, all right? When there is mismatch, let's apply replace now. We should replace the B with D. So we put here, so it becomes, I mean, it becomes AD literally. And P1 will, I guess, still show, I mean, show the same index, but different character, right? I think there's a confusion between the index of, I mean, like a P1 and the character that show, like that point that P1 points at. So like like I think we need to clarify these two. If P1 is deleted, if yes, let me write it down. AB AD. If P1 is deleted, yes, where will it stay? Yes, this is the question. Does it get pushed back or stay at the index? Is index the same as pointer? Like this is literally same question that I'm asking. Index isn't the thing here. Yeah, since insert state on C, so pointer one stays on character. Uh, yes, you sound quite reasonable. You sound quite reasonable, but yeah, let us check the animation again. All right, and this one actually, like, so here since we're moving right, logical thing would be to turn back and go back step, I think. I don't know, like index and character that point P1 points at. So is it the index? Like we are thinking from the perspective of words, all right? Not pointers. We are thinking like a wordly, let me say, not pointerly. That causes the problem. Because we, let's say, replace the character that P1 points at. But actually, if we are using pointer arithmetic, we are not replacing, or like there is no right operation, all right? All we do is like a, but maybe you're right. Maybe for replacing, maybe we decrease. Is like, can it be like, can it be possible? Is it possible? Or am I just, you know, thinking wrongly? Am I just making up? I don't know. Let's look at the animation. Most probably it created it. Yes. Oh, it shows. It dumped the all three operations are now in the file. No render. Oh my god. It threw the solution. So delayed operation. Let's look at it. Oh my gosh. We only move P1. We only move P1. I guess we need like delayed animation, just like the insert, like first insert animation, because like it, or we can understand it. So thank you for creating this delayed animation. Uh, but what I need now is not this, but like in the first animation, like in the first two animations, we have two different cases of insert operation, and especially the second one is amazing. I could literally see where we inserted, all right? But the last uh, like delete and replace animation that you created is like I could already see it by looking at the code. Can you create, delete, and replace animations just like the second insert animation, all right? Like in frames 200. Uh, because there I can see, all right? I can see the literally insertion of B, for example. Uh, can you do that for me? Because otherwise, the last two you created are just, pointer arithmetic, and that doesn't ring any bell, basically. Wait, that actually makes sense. Since if P1 was really drop, yeah, 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 then you would need to push it one more time to synchronize it with two. Uh, I mean, that actually makes sense. Actually, what I thought was, if you move only P2, then you just also making P1 go um, backward, right? That's what I thought. I thought that moving P1, like this is a good point actually. I can take this into my notes. I thought that maybe like as I said this, right? Did I type it? Maybe I delete. Yes, here. So maybe I should take a screenshot of it and put it, because these are the mistakes that teaches me most. Open that one. Uh, all right. Yes. So like I thought that maybe we should move P1 backward, but if you if you you know increase the P2, then relatively P1, I don't know if it is correct or not, but let's see how AI will generate the second animations, all right? Because like seeing only the pointer arithmetic does not help at all. I don't understand. The register arithmetic view tells you nothing. Your eyes can't or read in the yes. Tile level view. Tile level view. Like example two, where you watch be physically drop into word is what makes it stick. Yes, yes. Now the concrete delete. At the same slot. Yes, yes, yes. Please, please do it. Now the delete animation. B shrinks and drops away. All right, this might be it for me since it's yes, yes, yes. You should sleep. Like 10 p.m., 11 p.m. is too good time. I will sleep. That's a good question for the next a few weeks. Like yes, the short answer is yes, and I will create a schedule on my profile too. But for the next couple of days, yes, maybe even tomorrow I will do 12 hours long stream, and maybe tomorrow we can study Python, because I have a project that I need to finish. Maybe we can finish this together by half vibe coding, half learning, because I need to finish this. All right. Um, I will add a schedule on my profile, but tomorrow I will be streaming too, but on maybe different topic, not lead code. Thank you for stopping by. It was amazing, basically studying with you. We can arrange, let's say, 3-4 days a week to study together. Thanks for the advice, and listen, anytime, bro, anytime. See you next time. All right, take care. Bye bye. Ciao. um Let's see how well are we gonna do without the help of Americano. I hope it will be good. So basically, I suppose like seeing the animation will help us a lot. All right. The tile level. I think like I think I loved this term tile level. Let me save it too. Tile level view is what makes it stick. Exactly. So I think it has created. So let's see what it created. This is insert, I think. This is match. Oh, nice, nice. So this is delayed basically. So when there is match, there is no problem. And we move P2 to next level, like a next character. And there is a mismatch between, I mean, what P1 points and P2 points. Yes, yes. What we do now, oh, wonderful, wonderful. Like this is what I need. This is what I need. Like what we do, what what we are doing is like literally deleting this, and we are doing this delation, like delayed process by moving P1. But when are we like when are we moving this? When there is a mismatch. So we moved our pointers and there is a mismatch, and then we move pointer one again. And we are done, I think. Yes. And again, there is a match. We move them again. Yes. Yes. All right. All right. That's the solution. Like now it makes sense. Now it makes sense. Like this gap is what makes the difference. There is a match. We move our pointers and there is a mismatch. And our option is like a, let's say delete. To delete, we move P1 forward. Yes, this is the delete operation. We move P1. And in the next iteration, in the next phase, these characters are gonna be processed. All right. So this is deletion. So we know insert operation and we know delete. So let us think about replace. All right. At least we should be able to do replacement, right? Imagine AB and AD. All right. Um, Pointer one points here and pointer two points over here. And we are doing replace method. So what we are doing is like writing this D to here. All right. And then we just move it, man. Like we should move pointer one and pointer two at the same time because we just basically made the character as we wish. All right, as we wish. So this means we can move forward without leaving any of pointers behind. All right. Um, yeah. So this is for replacement. And let us review the delete again. So we have A, B, and let's say A, D, and our pointer one points here, points to here, and P2 points to here. And now we're gonna delete. So let's say we like our process is delayed, and we we complete our process. Now what? Now we still need to process this P2 in the next session, in the next iteration, all right? But for P1, since we deleted it, now it is time for P1 to process the next character. At the moment, we don't care about if it has the next character or not, because it may have or it may not. But this is what we do. So we basically increase pointer 1 and we keep pointer 2 same. All right, because we didn't process we didn't process this character, right? Like we are done with this. I mean, like we should see pointer 2 as the character that we should like, this is our map. Like P2 is our map. P2 is our map. Let me write it down. Our map. All right. By deleting this character, you don't you are not done with, you know, processing this, because the thing we are trying to do is turning this, I mean, string 1 into string 2. All right, by deleting, we didn't do anything helpful. I mean, in terms of, like, of course deleting may help us, but there is a certain number of characters. All right, by deleting a character, it doesn't mean you have the characters that you need to have. All right, so it, like, this now, like, this information doesn't change. So that's why P2 stays same, and actually that's why P2 stays same, and the reason why we increase P1 by 1 is because we delayed. So yes, so this is delayed. How about insert? So let's say we have AB and we have AD. All right, pointer 1 points to here, pointer 2 points to here. All right, and now we're gonna insert at the position of P1. All right, which character we are gonna insert? This character, like the character that P2 points. So this becomes A D B. All right, so our string 1 became this. We had pointer 1, it was pointing to B. I think it is still pointing to B, right? After the insert operation. I mean, you inserted a character. Let's say you inserted character, so but pointer 1 still points B because you didn't change the pointer, like pointer 1's position or pointer 1's value. Like, it still points the same thing. So now for inserting, does this mean that we don't move pointer 1 and pointer 2 ever? I think let's see the animation again. All right, because for insert, what I end up with is like not changing pointer 1 and pointer 2 at all, and I guess it is not correct. Like, let's forget about it. So focus on this part. All right, there's a match, it is all right. There's a mismatch. Yes, we inserted a character there. Yeah, actually we didn't move, so we are correct. We didn't move pointer 1 or pointer 2. But now they are pointing. Yes, so oh, let's look at the solution. So I guess I am correct. I get, but it shouldn't be like it can't be correct. Where is the solution that it gave? Yes, it is not correct because we are increasing the pointer one. Like I understood the replaced place, like replace process, all right? Because this is the golden process, all right? Basically, you are complete, like you done what you need to do, like you complete what you need to do with replace method. So you are going, like you continue your journey. There's no issue with that. But for insert and delete, there is some problem. But by looking at this, I don't see the movement. Like there's a match, no issue. So there is a mismatch. Insert P, yes. We move P2 here. Oh, I see why we move P2 now here. It is because now that you insert, like forget about indexes, all right? We don't care about indexes at all. The only thing we care about is whether we're done with creating word 1, we're creating word 2 version of word 1, all right? This is important. Since we insert P, then it means we're done with this like let's focus on P2, all right? We are done with this one because they are same, so we move. And when we are here for P2 to move forward, it is equivalent, like it is corresponding character in word 1 should be B. So we make it that way. After making it that way, we just move it. And also don't forget that we don't move P1 because we are not done with it yet, because that character is still in word 1, so it should be get processed. All right, I guess we understood enough about this question, and let's continue with the next question. All right, we can resolve it later. Count good nodes, and maybe we can copy the code and save the process here because it is valuable. Paste it over here and save it. Count good nodes. All right, where is our leetcode? I guess it is a tree question. Given a binary tree root, a node x in the tree is named good if in the path from root to x there are no nodes with a value greater than x. Oh, let's take a screenshot. Wonderful. And let's paste it there. Let's focus on this. I guess this seems all right. So given a binary tree, all right, a node x in the tree is named good if in the path from root to x. So let's say this is x, and from root to x, there are no nodes with a value greater than x. All right, so like we are binary tree. So we have a binary tree over here. And what we are looking for is like a selecting a node and finding the path between like root and that node, basically. Like we need to find the root, basically, right? So we need to find the root. That's nice. But how do we do that, basically? How do we find the path? How do we find the path between root and x? Like, this is the question. Take a screenshot. So this is the question, because we're gonna find that path, and we're gonna also check if there is no value greater than x. Nodes in blue are good. Oh, there is no input, like a second input, like second parameter that we can use. So it is not like let's say from maybe it doesn't give us node, all right, and the root. It only gives us the root itself. So we should transfer the knowledge while we are going deep into tree. There are no nodes with a value greater than x. We need to calculate this, like we need to apply this process for each node, and if there is no bigger node than x, we should increase our number. But how can we do that? Return the number of good nodes in the binary tree. Return the number of good nodes. So we should process and find every single one of them. So we're not basically creating a path and then looking at each node and then finding who is like smaller than x. So we don't have this node. So instead, what should do is like finding, let me copy this, finding a smart way of doing that. But what is that smart way? Copy and paste it. All right, this is the first step. Roots. All right. So we go func left. So let me start with this way. All right, func left. So this is the move. Like this is how we move in this tree. So func right and func left. So we don't know if these return something or not, but most probably they're gonna return some value. All right, let's suppose this returns x and this right side returns y, and our goal is to see the total number of return the number of good nodes. All right, so let's say this x returns the good nodes and this y returns the good nodes, the number of good nodes. And what should we return is like a x plus like the summation of these two, right? So I'm trying to create the skeleton of our recursive function. So uh, let's return x plus y. So this is what we should return. Um, Now, other than this, what we need is making sure that they are bigger. I mean, they are smaller, right? So let me read it again. Given a binary tree root, a node x in the tree is named good. Like the node it is good if um, there is no, there are no, there are no nodes with a value greater than x. So if we are, let's say 3 here, all the nodes should smaller or equal to 3, right? Smaller. And while we are going down, it should be same or smaller, right? Like same or smaller. While we are going down, let's say 1, 2, 3. When we find a bigger one, so what we need to do here, communication between parent and its children. How do we do that? Like let me type it down. Communication. Actually, most of the 3 problems like is about this communication between parent and child, or child or parent. Like this depends on the direction that you move. All right. So maybe I should update the code over here and saying that we are solving this problem. Count with nodes in binary tree. Set ticker. Wonderful. So, like this is a skeleton, but we need to transfer this knowledge. And we should have a place where we check if they are, bigger or smaller. So maybe before making these calls, maybe we should have a place where like we check the if the roots value, all right, is like a bigger than the child value. Like we can do that obviously because we don't have the reference of child. um Actually we have like root dot left is left child and root dot right is right child. um Maybe like a child right value. So if the roots value is bigger, then what should we do? If the roots value is bigger, all right, um we can continue making these calls. Maybe even better, we can do something like this, like one, I mean plus fun. So if it is bigger, I mean the root is bigger, we can, make this kind of call, right? I think this seems legit. and like this, if root value, but we should store this number, right? If the root value is bigger than, but if it is not, then we shouldn't stop exploring. We should go continue exploring without adding, I guess. If the root value is bigger than child child left value, we can add like a y1 plus. I've written like a left. Maybe I should make this left and this right. I mean, let me write left, all right? Left dot value and right dot value. Right dot value. I guess this is not right, because if the value, like if it is not bigger, then we shouldn't stop exploring. We should still go. And also another important thing is like for, let's say, this node, it is the 4 that we should check if it is, you know, bigger or something. If it is 5, we should say. So if we let's say, like, can we have 1 here? Actually, we can, obviously. Let's say if it's 1, then this doesn't give us plus 1 value, because 3 and 4 is bigger than that. So first of all, maybe we should decide if we should build our logic like a top down or bottom up. And also, like another question, like maybe I should type top down, like we should decide this, all right? Is it top down or bottom up? We should first decide this. And the second question is, how are we designing the communication between all of these nodes? Like, I mean, information transformation. I mean, transportation. Information communication, we can say this too. This is first step. The second one is information transportation between nodes, because like for this one, we shouldn't count it, all right, because its parent is bigger than its. Actually, if like having only one element that is bigger than the value of this node is enough to don't count it. Like, I mean, not to count this. Actually, I shouldn't think this. Like, I'm still leaning towards solving this question iteratively. All right, this is iterative approach. We shouldn't think this in this way. Like, our approach should be like as I did before. All right, like we have a function, all right, and let's say we call this with function left and function right, like a left child and right child, and these are gonna return, like, let's let's make them return the um, the total number of good nodes in their trees. All right, let's imagine we have a tree and left and right child. uh, I mean, let me move it to a little bit left. I mean, this. They return the number of good nodes. Number of good nodes. All right. X. Let's use red. X and Y. So we have these. And what we return is just summation of that. Like this is one part. Like this is recursion structure. Like recursive structure, which is quite important. We got this. But now it is time for like a transporting or transferring this knowledge, like because we have a tree that is good, and let's say we have a node X here. So what we are looking for, that if all the nodes that comes before that, if they are all smaller than or equal to X, then we count this as a good node. So, but it is hard. Like in this case, I feel like we should store all the nodes in a list, and then X, and then check every one of them to see if every single one of them is smaller. This doesn't seem like a good way at all. All right, this doesn't seem a good way. But now, like, we have the recursive structure, which is good. But now we don't transfer, like we don't transfer the knowledge. We're not doing that. Maybe I can make my pencil a little bit, bigger. The structure is there. Maybe I should type the code and ask AI. Public, let's say integer, boom. So we have our node, or maybe call it root, and let's make it return. I mean, let's make call root with like root left, and Y, boom, root right. Wonderful. What we return is basically summation of these. Like this is the core part. Now what we need is transferring that knowledge. So how am I supposed to do? Thank you for that. Now create necessary files and save them in our project. All right, because now I will start studying another question. That's wonderful. At least we understood this DP part and how the pointers move in that question. Like we literally understand it. So this is good. Now I wanna study this question. Do you think that like this is my solution? All right. Do you think that we can study this using animation? I mean, I'm looking for an animation that will trigger my thinking so that I can understand what to do, because at the moment, like I have the core skeleton part, like I at least I can understand this recursive part, but I don't visualize, or I cannot imagine how we can transfer the knowledge of bigger than or smaller than. All right, let's say, like, because we don't have any specific node, but instead we should count all the nodes that satisfies that rule. So like holding all the nodes from root to that node and checking every single node if they are bigger than or smaller than. So this is not a good option, and we cannot store that. All right. Now I'm dictating and I will ask one more thing. I'm looking for way to animate, like create an animation for, so that I can understand, I can I can get the feeling of what to do, all right? So activate tutor mode 2 and then connect to our Blender, all right? And start creating animation, but before that, tell me what you are gonna build, all right? What you are gonna animate, which part of this algorithm, all right? I know the skeleton part. um why there is no song? um I mean, I should send this. Let me remove that part, and also let me trigger the build. uh I think it is here. No, where is it? I think it is here. um yes, I think it is now better. Yes, it is good, right, guys? um yes, so let's make it more two. All right, I know the skeleton part. Which part of the, I know the skeleton part, but I don't see a way for transferring this knowledge. All right, I need you to guide me. I need you to show me around. Like, I mean, show me. I mean, I need you to show me, guide me, basically. I have, like, I remember a question where, um, like, where we need to find path, like a route to live. I think there was some, like, same kind of three questions. All right. I don't remember them fully, but like this question resembles to them too. So, um, what do you say? Welcome, welcome. Let it cook, guys. Let it cook. What I need is animation. I need to see. I need to have an animation. You also saved the Blender files, right? Everything. Press enter, and let's see which questions is, tutor mode gonna ask. Because I don't see a way for, going down, like a going down. Like, first of all, we should decide if it is bottom up or top down. And also the one of the essential question is like, are we gonna apply top down or bottom up approach? Like, this is crucial too. And then the another one was, yes, information transaction. Two things before any keyframes: confidence audit. Which parts of like I am familiar with the recursive part, I can say this at least. So narrow it. Is it specifically the what do I pass down? What do I return up? Hmm. Like yes, this is something important. Yes, because in one of the recursive questions, um, like there I saw that the important thing is we should decide what to pass down or what to expect from our children. Um, like what do I return up and what to pass down. So in this question, we need to pass down. Uh, Actually, we need to return up, right? I guess we should do this bottom up. So like imagine we have a tree like this, all right? Each node should return like saying that, let's say I am 5, all right? Let's say I am 5 and I need you to be more than me. So if this is 5, then this node should be 6 at least, all right? But this doesn't help us complete the question fully. What I mean is that we can count this if all the nodes up to the root, you know, are smaller than 5. I mean larger than 5. How do we know how do we know that? So let me ask this part too. So but this part is important, but like this question is quite good, all right? Quite good to understand recursion. Your real block is how do I carry the ancestor knowledge down without storing the whole path. So I'm gonna animate exactly the tension. Tension. Tension points. Tension. Tension is a good word. Let me save it here. Layer 0, the tree. A styles, root at top, static. Just so we are looking at the example. Layer 1. What good means? Pick node 5, light up the path, show the rule visually. 5 is good because nothing on that lit path is bigger than it. Then do node 3. Yes, yes, yes. This makes so like in recursion, like we shouldn't do it like a great thinking of each stack frame, but instead we should mathematically and trust the what recursive function returns us, all right? But this question requires like this all path. So it like there's a tension, like there's a real tension here. It puts your recursion understanding to the test. The squeeze, the trigger frame. Phrase is the sound good or not? The squeeze, the trigger freeze on a node mid tree with its trailing ancestor list. Then I pause. Oh my gosh. Maybe it would be a good idea that we just see the animation first. Strong question. That's the senior instinct. But predict before I answer. What does your current skeleton already commit to? Like, yes, you call the children first, then combine their result on the way back up. So name it. Is it top down or bottom up? Um, is it top down or bottom up? Is it top down or bottom up? I wanna say top down. I mean, first the children are calculated. So I don't know, like I genuinely don't know. Then the harder half. And this is the crux of the whole problem. Crux of the whole problem. So this is a term that I also liked. The is this not good decision? Is this not good decision? So this is like this is something important, all right? So I can save it, I guess here. I mean, yes, to here. Wonderful. Evet. Yes. Are those two, and you'll have basically corner. You have basically corner to design yourself. So I genuinely don't know if it is a bottom up or top down. Like we expect our children like return their results. All right. So what does it mean? So does it mean bottom up? I guess it is bottom up, right? My neck started hurting me, guys. Right, your skeleton is bottom up. Children return their result. Parent combines them on the way up. Parent, like this post order. Yes, this is post order. This is post order. Um, did we? No. What happened, bro? Your skeleton is bottom up. Children return their results. Parent combines them on the way up. That's wonderful. I mean, why I can? All right. Now, here's a tension I want you to feel. Hold the good rule in your head. A note is good if no ancestor above it is bigger. The deciding info lives in the notes above. Like deciding info. Yes, yes, yes. Like ooh, wonderful. Like I needed it. I needed it. Exactly. The deciding info. Come on, man. The deciding info lives in the notes above. Like yes, definitely. Let's make it even I don't know, maybe, and also italic maybe. Wonderful. The deciding info lives in the notes above. Um yeah, the deciding info lives in the notes above. The path you already walked through to get there. Oh, the path you already walked. Oh my gosh, like this is like when you put it in like in this way, like things become, easier to see. Power of words, I think. All right, let's make it italic too. So your counts travel up, yes, bottom up. Your return x plus, yes, y. But the fact that the site's good or not lives above and has to reach these nodes somehow. Yes. So can a pure bottom-up call carry down anything about anything? Actually, yes, why not? Look at the function signature. What is the only channel a parent has to tell? A child is something before the child's run. Uh, I don't understand what you are saying exactly, but what I have in my mind is um, maybe we can design our recursive call that holds a min, or let's say, or max value that we share, like a while calling our children, like a func left and func right. We also um share, like we also transfer this information, and maybe they can like maybe run some if condition or something to decide what to do, I guess. Like, is this what you mean? Because there was a question where like I guess it was validating binary tree question, and there we were sharing like a there were two parameters where we share like a min value that it can get and the max value that it can get, all right, basically. So there is a, let's say, uh I mean, limits, like, all right. So using them like a while calling for left children, we were setting one of them, and while calling for right child, we were setting the another one, so that we transfer these knowledge to the like a for our children. All right. I feel like we may have something like that here as well, but what do you say? Um, let it transcribe and let me also update the topic. A three question. That's exactly it. And yes, validate binary search tree cross-reference is the perfect instinct. You just answered your own original question. The channel a parent uses to tell a child something before it runs is a parameter passed into the recursive code. Exactly. Exactly. But still, uh, we need some other info to solve this question, man. Like, because from validating binary search tree, like I know we can do something like this at least. All right. Uh, so that is exactly it. Now sharpen it, because this problem is simpler than, oh my gosh, and I want you to see why. In validate binary search tree, you carry two bounds. Yes, two bounds, like a lower bound and upper bound. Yes, yes, yes. Like, I mean, lower bound, right? And upper bound. And you set them differently for the left and right child. Exactly, guys. Left got a new upper bound, right got a new lower bound. Yes, that asymmetry was the whole trick there. Here, think about the good rule again. No ancestor bigger than me. No ancestor bigger than me. No ancestor. Like, let me think about it a little bit, all right? So, no ancestor bigger than me. So, in our question, we have a tree again, all right? Uh, and let's say our node is this, all right? And there is no node bigger than me. There is no node bigger than me. I mean, how it is possible, like simpler than valid binary search tree. How many values do you actually need to carry down? One or two? How many values? And do left and right children get the same value or different values? Actually, they should get the same value, I think. They should get the same value, I guess. Whereas in validate BSD, we give like we update them differently. How many values do you actually need to carry down? So it said that we are applying bottom up over here, like we are using bottom up. Wonderful. So like we expect our children to return some values. Like this is This is one way of seeing this problem. Like this is correct, by the way. But also, while we are like, upon we make these calls, all right, from left, from right, upon making these calls, we should also transfer, like carry down information, and I don't know which information it is. And like, let's say we have 5, 10, and 12. So should we transfer that your base case is 5? Like the another question is when exactly, like the real question that I have in my mind is when we are gonna count, like when we are gonna increase the count by 1. Like when is this gonna be exact? Like when? Like this is the question I have. So, and also, like, for your first question about the how many values do you actually need to carry down, I think it is 1, but this made me think about like the real question I have in my mind is when exactly we're gonna count, like when are we gonna increase the count exactly. Like let's say we transfer, like let's say we carry down the information, like let's say we are node 5 and we go into our child, all right, left child, which is, let's suppose 10. So like, are we gonna count 10, like, and increase the count by 1? Like, is this it? Or like when, like, or while unwinding, when exactly? So while unwinding, so I guess it is not when unwinding, because the rules that we need to apply, we can do this by while we are calling, right? While we are calling. Like we carry down the rule basically, and also there should be a phase of uh, increasing the count by 1. How can we do that? So there are different phases in this question. I mean, first one, like deciding bottom up or top down. This is one. Carry down the rule. This is one. And another one is counting. So all of these are different phases, different steps we should answer. Let's see. Let's press enter and let's see how, like, what would the answer of AI be. Both correct. When value same to both children, yes. You have fully separated this from binary search tree validation, yes. Now the counting question, and notice you are already answering it yourself. You said the rule gets applied while we are calling. Yes, the rule is applied while we are calling, yes. Because this is where we can apply the rules, basically, upon calling. All right, yes. On the way down, yes. Right, the moment you arrive at a node, yes. You already hold the carried down value, yes. So the decision, does this node earn a point, can be made immediately on entry. Like, I guess we cannot decide if it is valid or not upon we arrive at a node. All right, we cannot do that. So tell me the comparison. You arrive at a node, you are holding the max on the path so far, max on the path so far, max path. What is it, man? Like, this seems quite good too. Like, max on the path so far, max on the path so far. This seems good. What test makes this node count as +1? Your example, you are at the child 10, you carry it in some max. When does 10 score? Then the second half, which is, oh my gosh. So I guess I feel a little bit tired. So for your questions, can you create animations like in the same Blender file? Like currently it has a file called edit distance insert. What I need you to do is like create the animations, like maybe different animations. Use the camera arc movement, all right, different scenes for showing different things because we are applying bottom-up approach. So the skeleton we have is like a left child returns X and right child return Y, and we sum them, like we compile or we process those values on root level, and we sum them up and return. Like this is skeleton, like this is one animation. Another one is transferring or carrying down the knowledge. All right, this is something important. And also another phase, another important thing is like increase the count. All right, so I need them. And also, what other animations do we need? Like, do I need to understand this? You can start building your animation. So, guys, we need to it would be great if we have an animation, all right? Because Cloud Code creates animation amazing, all right? And it really helps understanding. Let's see what will it say. And also, what is our next question? I think, um, like, let's see the next question. Oh, the next question is another tree question, and I think we can handle it faster. Like we already have the hint. Let's see. Like knowing the hints like is like helping, is really helping. Got it. You are tired. So I'll take the keyboard. You already derived the hard parts. When value, same of like these are easy parts. Decision on the way down. Like, all right. The animation will show two pieces you were about to state. The count test and how the point writes home. Writes home. Yes, yes, yes. How the point writes homes on read, yes. So like this is another important thing. Let me add it here. Important cache, the open file, yes. I'm not going to pollute that file, yes, please. Instead, I will create a separate Blender scene called GoodNotes. Wonderful. It will be great, Cloud Code. Thank you. So now we are waiting for Cloud Code to create its animation. I hope it's gonna create a good animation, guys. because animation helps a lot. And after that, it would be great if we have, some time for resting. I guess it's been almost 8 hours. Wonderful. We have 4 hours to go. Um, but we need a break. But before that, I just wanna have this animation, all right? Yeah, so if you have any questions, you can ask. I'm studying leetcode, DSA, data structures and algorithms for incoming interviews. What I have here is like 48 questions that I find helpful among different topics. Let's say I have binary tree, like invert binary tree question, like this is good for understanding recursion. I have DP, like a climbing stairs. I have a greedy problem, reverse linked list, find all subsets. Like these are asked during the interviews most of the time. And I have one merge sort. Like we need to know its time complexity actually. Um, we have studied its implementation in our streams. We have prefix sum. We already studied this in our streams. Right side view, like this is a good example of breadth first search. We have coin change problem, another DP problem. Like we haven't studied this before, but after finishing the last half, I will review all of them again. So my goal is like having these 48 questions in my mind fresh, and I want to make myself write or code these questions from memory in, let's say, 10 or 20 minutes. Even if I forget the code, if I learned, I won't forget in the long run, all right? Because if you internalize this knowledge, you don't forget in the long run. Even though you may forget the details, it doesn't matter, because right you start thinking about it, the details comes to your mind. So another greedy problem: remove case from and. This is a good case, like this is a good technique. We have clone graph, like this is basically recursion, like a powered recursion, nothing more. Quick sort, another sorting algorithm. Container with most mode, like these questions are like greedy problems, but like you need to know the technique, all right? These questions are like the college entrance exam mathematics questions, all right? It like I don't see them as a coding question, but rather a mathematics question. Validate binary search tree, like which like this question quite resembles to the current one that we are studying actually. And we have house robber. So one of the most common question, like one of the most asked question during interviews, and well-known problem in dynamic programming, all right? We have hands-off straights. I guess, oh, I remember. It is another greedy problem. Wonderful. The cache problem, so which is like this is amazing. Like this is a good question, because we use double linked list together with hash map, and then it becomes unstoppable. All right. We have n queens, which is like a backtracking problem. Good question, man. Good question. Voting or like these are the questions that I studied, like the first for 25 actually. But my goal is like making every one of them ready for me. Wallet Sudoku, lowest common ancestor we have. What do we have here? Let's see. Lowest common ancestor. So I guess so we need to care about what the children returns to parent basically. This is a good way for understanding bottom up. But for example, in our question, um, like it is not enough to know. No, it is not enough to apply bottom up only. We also care and knowledge while going down. So that's why like this is what makes this question unique for me at least. All right. Um, so there are different techniques. So in each problem, so it is it is good. So because like for example in this problem there are different cases, but you don't let's say um, represent each of the case. All right, you don't do that, but instead you like simplify it. All right, you simplify it and you use one number for two separate purposes. So this is smart. This is smart. The deeper pattern. All right. All right. So I'm just waiting for Blender to create its file, and then we are gonna take a break. I think maybe we can make it like 45 minutes. I don't know. I wanna take a walk. I mean, I wanna go for a walk. I guess the animation is created. That seems quite nice, guys. Let's see. Uh, oh, look at the X and Y values. Like these values are the values that we carry down. Later in those nodes, they're gonna decide if they are good or not. Not. Uh, all right. Yes. So let's see the animation again. Oh, so the XY values are coming from children, and we return x, like summation of x and y, to our root, and like missing half. So this is another phase. So we share this knowledge to both of our children, and like look at this, like this information becomes 4, and we share these 4 with its children's, yes, children. So like I don't understand this part at all. Like we shared the knowledge, but how exactly we are counting? This is the part that I didn't get fully actually. Maybe we can like this really helped, all right? Like the children returns their x and y values, we sum them up, but the missing half is carry the max down. So we carry the max down, which is good. Like see that this number becomes 4 now. Because we are carrying down the max. All right, all right. And we share the like like we share the basically max down. All right, but then what will happen? Like starting from I think 195. Like let's look at the root. Since 3 is bigger than or equal to 3, this is good. Then the left child, it is smaller than 3, so we skip it. And for this node, it is, good. All right. And now, I guess what we are doing here is in order traversal, like this seems good, but I didn't understand the count phase exactly. Guys, I think I can take a break now, maybe 45 minutes. All right. I wanna take a walk or something, and I also want to handle the OBS thing. So when I come back, I will continue with this three question. Now taking a break, 45 minutes, I think. When I am back, we will continue with. What is the name of the question we have again? Count good notes. Count good notes. All right, take care, guys. Now it is break time. Let me make it 45. Hello, hello. We are back, guys. We are so back. First, let me check the sound. Sound check, sound check. And now we're gonna, like, I. Why don't we see? Oh, let me first close, like, toggle it off and toggle it on. So we were studying three question, which is like a good question, all right? And we created its animation, but we haven't grasped the idea of, like you are seeing that, like, we are transpassing, so we are uh sharing this knowledge like a max with our children, like as you see we share. And then when if they find a better option, like a bigger than us, they update and continue transferring that knowledge. But I didn't genuinely understand the part, like this counting part, all right? How does it work actually? uh so, like, you are hearing me, I guess, but why it doesn't work? Let me connect it again. I think we have some technical issues, guys. Hold on a sec. I think, yes, I think now you are hearing me. um so I'm gonna ask this to AI to create another animation on it. Thank you for your great animation. We are grateful for that. But in the animation, like after transferring this knowledge to the leaf nodes, you start counting from root. But, like, the the way I understand recursive functions is that, like a bottom up or a post order traversal, all right? But here I know that we are sharing a knowledge. Um we are, I mean, we are sharing knowledge to bottom. And also there is another phase for counting the good options, all right? So, um but in the animation, like, you are showing that, but I don't understand. I genuinely don't understand. So where, like, I see, like, I feel like uh while we are going down in the tree, I feel like we are counting as we are going down, right? As we are going down, because it seems that way. Can you, like, maybe use that camera movement, all right, arc camera movement, and create another scene there and show how it, like, when exactly we are making, like, making this count, all right? Could you please? So, guys, the animation is just fine, but, like, there are let me also open this camera as well. Where is my OBS, guys? Yes. um the animation is amazing, but it lacks showing where exactly we are uh, counting, all right? This is important too, all right? And I guess we have written our notes here. Yes, so, yeah, carrying down, yes, this is the one. So, first of all, our approach is bottom up, all right? Our approach is bottom up.
because we expect result from our subtrees, all right, sub problems. Let's say this return x and this return y, and we basically return, like we compute and we calculate this and return this, all right. This is a bottom up. And also, like for this question specifically, um, we are carrying down a rule, all right. We are carrying down a rule, guys. And let me, I guess there is no sound in the background, so maybe guys, let me run this one. Hold on a sec, guys. Sorry for your ears. Now I guess the sound level is good. I think when I am back from break, the sound breaks, I think, but it should be better now. It should be better now. um let's open the project. Amazing. So another important thing with this is, let me open my Spotify and maybe start from, or in case it started playing some bad song. So wonderful. So like, and counting, all right, like counting phase. So like we should know with which approach we should apply here. It is bottom up, all right, which is awesome. Like this is the part that I could do. And then the next part is carrying down a rule, like we have in validating binary search tree, because in that problem as well, uh, like validating, I don't know how to write, validating BST, we were transferring, we were carrying down a rule, like a while we are going down, carrying down, we were carrying down, all right, a rule. For that, while we are calling our child, all right, let's say left child, we also set, let's say, upper bound. I will say, let's start with lower bound and upper bound, all right. So that we share the, like we transfer, we carry down the rule, all right. This is rule, basically. This is rule. So likewise, in this question too, we should carry down the rule. And another part, like another distinct part, like a distinct part from binary search tree, like a validating binary search tree, is counting phase. Where exactly should we count? All right, this is important, guys. This is important, guys. All right. So let's wait for a second now for Cloud to build our animation. And if you guys have any questions, you can ask me, right? And we can think about it together, all right? And I hope we can study this and continue with maximum width of binary tree. I guess I remember this problem because I have solved it before, but let's say I remember, let's say 30 or 40% of it. Let me open, anyway, maybe open. Hold on a sec, guys. All right. Just wonderful. Just wonderful. We are waiting our AI to build, basically. I mean, animation. Like, look at it. Like, we are going down, or we start from here, and we func left basically, and func right, all right. And func left returns the total number of good nodes, all right. And right returns the total number of good nodes too. And the thing we should do now is like maybe we should also check if we are eligible for good node or not. So this is another important thing, right, guys? I mean, we didn't think of the root itself, but it is important too, right? It is important, guys. I mean, like this is another question I have now. Let me type it down. Um, and also after left and right childs return their value, are we checking if the root is like root itself is valid for eligible, let's say eligible for good node? Are we doing anything for that? Are we doing anything for that? So this is important, guys. So are you done? I guess it is done. So let's see the animation it created for us, guys. Oh my gosh, what is happening? What is happening, guys? So we start here. Oh, like good is counted right away. Look at it, guys. Look at it. It is good. 1. It hit good 0. Oh my gosh. Look at this, guys. Like 5 returns 1 and 4 sums what its left and right returns. And also, oh, no. It is doing something else here, guys. Because, oh my gosh. Like, we have like a value like coming from left child, and we have value coming from right child. But also we have our own value. Like, that's interesting. We add it and we return that. Oh my gosh. And also it didn't build as I wanted. I have tried explaining you that don't override, like create another scene, I mean, and move the camera there. Like we have an animation, for example, in our previous question. We created an animation, and in that, like in this single blend file, we show an animation, like part of the animation, part of the question, and then move like a camera change like its angle and continue building like another animation for another part of the question. All right. But I guess currently we have a single animation, and in this animation I don't understand how we calculate count twos. Like, don't show me CPU style. All right, don't show me CPU style. I don't understand the CPU style at all. Like, you are showing me CPU style. Like, this is a good way. Like, this is not a bad way. Like, keep this, but also create a mathematical way, like a post-order traversal, right? Because in post-order traversal we get a value from our left child, and we get a value from our right child, we compute like a sum them and return that value. So like this is like I can understand it, but I don't understand what you just draw in this animation. And also the camera movement is good actually, but what I meant is like we are showing now the calculation of good, but what I also want to see is, let's say, the bottom up logic in this question and carrying down the rule phase and then counting. Like there are three phases, all right? One is bottom up, like we expect result like from left child and right child and we sum them up, all right? This is bottom up, like a post order. And then we carry down rule, like I want to see an animation for that. And then the third phase is counting. So we have counting, like we can decompose counting as two phases again, all right? And one type of this can be showing it like a CPU style, and then the next one is like a bottom up or post order type, all right? Because I don't understand it, man. I don't understand it. So now I just have described how it should generate our animation, all right? Oh my gosh. But we have what I have dictated just over here, all right? Just click on copy and then not this one, but this one, close that one and paste. So now we are creating an animation for our tree problem. Which tree problem? This tree problem. Count good nodes. Maybe I can also set the topic like this one. Like currently we have this animation, but I don't understand how we calculate the good. Most probably we calculate good as we go, like this one. But I don't know, man. Like let's start the animation. Like the part where I don't understand is why all right, this good is not green because it is not one. I mean, it is not a good node basically. That is why. Like the animation is good, uh, but still I do not see how we are doing. So let's wait for a second. Let's for AI to understand. I mean, let's wait for AI to build that animation for us. And also, guys, do you know what is the optimal way of setting OBS? Because right now, like the fans are running. Like it is not too hard, but I don't know. Like we are not doing CPU or GPU heavy thing, but I guess since I'm sharing my screen, my PC get hot. You're right, I finally get the structure you want. I was building it wrong. Yes, you were. Let me restate it back to where we are locked. One blend, one scene, 4 staging areas laid out in space. Yes. So let me guys save this term into here because I really liked. the camera arcs from one to the next, exactly like your heap sort. Yes, four phases. Yes. Oh, like it already knows this, which is good. Post order skeleton carry the rule down, counting execution, counting uh, counting execution step by step, counting post order mathematical leaves resolve their value first, then each parent sums good plus left. All right, guys. All right. This is what I was looking for. Good plus left plus right. This is what I'm looking for, guys. Exactly. Because I thought for a second that we don't calculate the current node, like a current node, whether the current node is good or not. Because here, like uh, in this design, like as I said, like we return x value, we return y value, and we compute them, like sum them up, and return it right away. All right. But we also should somehow calculate the current node as well, guys. All right. This is the point where I have missed. Wonderful. No wonder. No wondering. Values resolve at the bottom and bubble up by layer. The way you think about recursion. Oh, I guess. I guess we can save it too, guys. We can save it too. Click on edit and enter and delete this part. Make it italic and save it. All four states animated. Now the traveling camera that arcs between four. Oh, the traveling camera that arcs between four staging areas. So I like this term too, guys, because I can use it next time I am building an animation, guys. All right. Let's see, guys. And also, it would be great if I create videos on YouTube, right? Because we are studying a lot, and I hope these sessions is like it will stay on Twitch so that I can rewatch them. Because I guess after 1 week they will they will get removed, right? So you don't see it, you are not able to see it, but will I be able to see it even after 1 week? So now our AI creates the animation again as we just described, all right? Because here, as it said, yes, post order skeleton carry the rule down. 3A counting execution step by step, and the 3B is counting post order mathematical. So this is like I want the animations of these, all right? Let's take a screenshot of that part and paste it over here, right? Um, let's see. Like it is privileged to use AI. Like I mean, use AI to create those animation guys. Because otherwise, I would have to create those animations by hand, and it would take so much time, basically. Because like I don't know Blender that much to create animations, but now we are using AI to create animations, and it's good if you like it is able to create animations that you just described, all right? Because let's say 1 or 2 years ago it was not able to do that, but now it can. So It is good, guys. All right, it is good. And also, let me check this one. Let me read this part, guys, to make my OBS better. It tells a very clear story and it exonerate OBS. So that's another good word we have here. Let me write it down too. OBS render is like OBS render seems good. OBS CPU seems good. Windows server is good. Chrome, the driver. So what is that, man? The pattern that proves it. Look at what happens in the spike moments. They are synchronized, and Chrome leads every time. Everything jumps with Chrome. These spikes hit every 30 90 seconds. That's the fingerprint of tab doing periodic work. A dashboard that auto refreshes, a live chat feed analytics, and auto playing an animated page. Uh, Maybe I should close that tab on my computer, right? So your instinct that it is the scene was half right. The screen capture in this scene is what lets Chrome's loss reach the fan, but the actual hit is Chrome itself, and it is there whether OBS captures it. Do it now. Find one tab. Even with few tabs, one is working hard. Open Chrome's own task manager. Click the CPU column to sort the tab. Like in my Chrome, like one of my Chrome profile, I opened Stream Manager. Like, can it be the problem? Because I cannot spare any of my windows. Like, they should be open all the time. And yes, like, can you find that tab? Like, would it be better if I close the tab? Maybe I just open. Let me close that one. All right. Press enter. Let's continue, guys, with our animation. Yes, wonderful. So it created the animation just we have described it, all right? So here the post order skeleton we see basically. Post order skeleton. So we basically uh like this animation is not good. Oh yes, it is good. It is good. So x and y values are coming from children, all right? And the parent computes them. We like some which is summing them up. Yes, this is like I don't know what is the intent of showing these, but at least the overall post order thing is shown correctly. Now the phase two, carry the rule down, mate. Like this is important, all right? Carry the rule down. Max so far, like there is a parameter like a max so far. We are carrying down, like we should carry down this information to our children upon we call our recursive function, like a recursive function, all right? Upon calling, we share this knowledge, this information, as you see here, which is amazing. And then when these nodes are doing like making this recursive call, they will compute the max so far again and will use that to while calling, which is amazing. And then counting. This is the step where I didn't understand. So like a good like a, this is good. So when we are here, I guess it seems that we are calculating, we are deciding that if it is a good or not. So this is the first function call, and we immediately calculate if it is good or not, like the current node. All right. And what is this yellow part? I don't know. And it like we are calculating um, whether each node is a good or not. Like this is the CPU style, right? Step by step execution. Actually, we had this before. All right, like this is CPU style, which I don't understand. So now this is counting with post order style, guys. Post order style. Let us see. Uh, so, oh my gosh. So in post order, we can assume that all for all nodes, we have calculated like can you hear the song, by the way, guys? You should be able to. I mean, but I don't see any green thing. That's interesting. So let me run this once more, guys. Sorry for that. Sorry for your ears, guys. I will fix this in next stream. All right. So we are doing what we are doing now. We are showing how we calculate, like how we apply this counting process. Counting means how many nodes we have that is eligible for being like a good node. All right. What we do is first, what we do is not summing all the good nodes up. What we do is deciding if each node is like whether it is a good node or not. We are doing this, all right? We know, like somehow, like I don't know, but I guess since we are in we are looking from eyes of post order, we know whether we know which nodes are good nodes, all right? This is the B2, 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 beautiful, B2 of post-order traversal, I think. So what we are gonna do is like summing them up, I guess. So I like the position of these numbers are not quite positioned well, but 0 comes from here, 1 comes from right child. We sum the current nodes Boolean value, let's say Boolean. I'm gonna call it Boolean. We're gonna calculate the Boolean of the current node, the Boolean coming that comes from left child and right child. We sum these three things up, guys, and then we're gonna return it, all right? Like here 1 comes, here 2 comes, and this node is a good node too. So 1 plus 1 is 2, plus 2 is 4. So it is gonna return 4. Like I really like this one, but now my question is why, like in the beginning of this animation, why do we have how can we know which nodes are good nodes or not? Is it because we are using post order traversal? Let me ask this. Thank you for your brilliant, amazing animation. Thank you for that. We are so grateful for that, all right? what we wonder is, like in animation phase 3b, you are showing like showing the state of each node, whether it is like each of them is a good node or not. Like the animation starts with these. Start with these, all right? The thing I wonder, like the thing we wonder is, when exactly did we calculate this knowledge so that when we like apply post order, we can apply this post order and like sum them up. I guess it was when we are going down. It was when we are carrying down the knowledge. While we are carrying down the knowledge, we also calculated whether the current node is a good node or not. So while we are going down, we also assign like maybe some sort of variable, like maybe some sort of variable is that is, and we set that flag to 1 or true, I don't know, so that in the unwinding phase of this recursion, when the unwinding phase of this recursion, we can we can we can sum these values up, like a left, like the result coming from left child, the result from coming from right child, and the state of the current node. We sum these three up, like we sum these three things up, and we return this to our caller, basically. I may have talked much because when I talk for a long time, it can fail at transcribing. Press enter and hope for the best, guys. Hope for the best. And if you have any question, guys, you can ask me. You can ask me and we can study and think about it together, all right? So we are now currently studying solving a 3 problem from LeetCode. This will hopefully help me to get a job, because this type of questions are asked during the interviews frequently, all right? And I also want to be a person who understands algorithms. uh, there are some people who says like who say this is not an indication of whether a person is proficient or efficient, like proficient at coding. But for me, I guess like there is no harm knowing these, all right? Because it really challenges you and your brain and your understanding of code. Phase 3b starts with the good flags already known, but it never showed where they were burned. Phase 3b starts with the good flags already known. Starts with the good flags already known. That's the bridge. Phase 2 now shows each good flag being decided the instant max so far lands. Stamp onto every node during the descent. Those are the exact same flags, phase 3b, then sums on the way up. The two phases are now one continuous story. Carry so far, decide if it is good or not, keep carrying. So guys, after completing this animation, the next question is, how is carrying max so far helping us to decide if a node is a good node or a bad node? Good node or a bad node, all right? This is important, guys, because like another important phase of solving this question is like the question was, let me remind you that, guys. The question was, let's say you have a node X and you have your root, the x is a good node if all the nodes are smaller or equal to this node. So like we should obviously transform this requirement into simpler version basically, because what we are doing is not, let's say, creating a path and putting like a maybe creating a list or something, putting each node into that list and iterating through and checking if those nodes are like if all of them are is smaller than or equal to the like this node. We are not doing that, but instead we carry a knowledge like a maybe some variable or something, all right, showing, let's say, max max so far, all right, this is the name of it, max so far. We carry down this knowledge while descending, and each time we hit a new node, or let's say we are coming from here, all right, like first thing we do is setting this value, like a setting, I mean setting the state of whether it is a good node or a bad node, all right. We are using max so far. So like this is the naive way, and which is not good. This is the proficient way, but we need to like our next question is to like to solve, like to ask um, that how we transform the requirement, the original requirement in this question into this one, all right. How how did we do that? How did we do that? And also, why is it work? Why does it work? Like how and why? Like these are the questions that we are gonna ask next. So, oh my gosh, logged into your tracker, the decide down and decide down sum up. Oh my gosh, like I love these one-liners. So open this one, press enter guys, and type it down because I just like it, guys. I just like it. The accumulator down and combine up recursion. Are these two things different than each other? Like the accumulator down and combine up. I don't know. But I just wanna take a screenshot of it and think about it later. Two things left, guys. But maybe first I should open this. But also, what was our question? What were our question? How and why? How does max file so far work, and why is it working? So now let's open the animation, guys, and let's hope for the best, guys. Let's hope for the best, guys. So this is the first phase. This is the carry the rule down phase. Carry the rule down. Carry the rule down, guys. We are carrying the rule down, all right. So this is the max so far. We are carrying. By carrying, we mean in each iteration, like in not iteration, but in each node, we basically make two recursive calls for our left child and right child. For each call, we share this integer 3. We pass this to our children basically, and they decide whether they are eligible for being good. Yes, you are, like you can see it, guys. They like it is decided, guys, whether these children are good or not. But now we are thinking from CPU, all right, like a CPU wise, like. But that's all right. That's all right. That is all right. Now, like, see that the max so far is updated to 4 here, because It is the max so far, guys. It was 3 before, and then now it is 4, guys. Because 4 is, don't don't make me tell you this. 4 is bigger than 3, guys. And now again we share this knowledge. I guess like I have feeling of like a breadth first search, guys. We are not doing like a depth first search or something here. The thing I see here, guys, breadth first search. Why? Why? So let me take a screenshot, guys, and then paste it over here, and then type it down. Why do I see like a, I don't know, A or nothing? Why do I see a breadth first search over here? Because in the animation, like like it is running as if it is breadth first search, guys, but we are not doing breadth first search. So there is like there is a subtle wrong thing with this animation. Like I get the point, by the way. I get the point, but this is even not a CPU style, guys. I'm sorry, this is not even CPU. Like this is BFS. I don't know why. I mean, this is because the way I asked, because I didn't want to see it like a CPU wise, because it is not helpful at all. Uh, like this is CPU style. This is depth first search because. All right, this is depth first search, guys. What we see is depth first search. All right, that this is depth first search. And now here what we see is I don't know what we are seeing, guys. Internal. I guess it is doing something like a post order traversal, guys. I guess yes. Huh. All right, I think, guys. Now, what was our question to ask, guys? I think this so. Thank you for the beautiful, amazing animation. You are just great. Now, my next question is like our next question is, why on earth this max so far logic works? Like a, why on earth is this approach working max so far? I'm asking this before because like when I see this question, uh, when I saw this question first time for the first time, I I tend to think a store mechanism like an array or something. So that for each node, like each path, starting from root and that node, I could create an array for each path, and using a for loop or something, I could like we could decide if that node is a, I mean, is a good or bad. But we are not doing that. We are using recursion, and we uh, carry down max so far and decide if a node is a good or not upon descending. All right, upon descending. And like this question, like we can decompose this question into different parts. One of them is like a um, thinking this question like a post-order traversal, where you expect return value from your left child and right child and compute and then return something. All right, this is one. Another one is while upon descending, we like another one is basically actually carrying down a rule like we did in validating binary search tree, guys. I mean AI. And another one is while carrying down this rule, we also compute or decide or flag a variable that each of our node has, which is good flag, good or bad, like a good flag. So basically, while descending and unwinding, we do a job. We complete a job. Because I thought that if we apply a post-order traversal, or let's say depth first search, like we call our function like a func left and func right, and we take like a their value and then we do some computations and then we return. All right, but here we have this too, but on top of that, while descending, we also setting something up, and while unwinding, we are applying post-order traversal, like a maybe depth first search or something, and we sum these flags up and return that. So isn't that beautiful? And am I wrong thinking like this way? Because like I remember, for example, invert binary tree problem, all right? Guys, in invert binary tree problem, what we do is like imagining if the left subtree, like a left sub problem is done, and then right subtree is done, and they return something, and we invert left and right nodes, we swap them, and that's all we do. So for example, in invert binary tree problem, we like trust the magic of recursion. We call func left, and when func left returns, we trust that it handled inverting that subproblem subtree, and then we call func right, which handles the right subproblem. All right, and then what we do basically, the computation, the processing time. After calling these recursive calls, what we do is like a thinking if the left subtree is done and then right subtree is done, what is left for the root, for the node itself? What it should do is basically swapping left child and right child and return itself to its caller. So here I can understand fully the post-order traversal. I can easily understand, all right, the post-order traversal, man. But here we use that post-order traversal after we calculate, after we know that each node, like for each node, if it is a good node or bad node, we assume we know that somehow, and we use that post-order traversal there, and the part that amazes me is while using this post-order traversal, we also apply something like a pre-order traversal, I don't know. While descending, we set some values. for each node. This is valuable, man. This is important. This is what I'm trying to get. Please explain. So we asked a good question. Let's see how will it answer. So, and also guys, I think the problem with my computer was opening that Chrome page. I wouldn't guess that Chrome tab of my Twitch stream manager would cost a lot, like this much, because now funds are okay. So single tab, but so much trouble, guys. I guess I can open the stream on the phone and maybe manage it there, because I don't want my PC to use its fans. It disturbs me. It irritates me, guys. So if you guys have any question, you can ask me so that we can study together, man. Because I want this so badly, man. I want to understand these questions, guys. This is like a live or die live or die situation for me, guys. Like I have solved, let's say, first 25, and now I'm going backward. Now we are at 42. I thought we could solve up until to mark 30. We couldn't, but it is all right, guys. Don't worry. Don't worry, guys. We're gonna handle it, all right? You're not wrong. You have discovered something real. Oh my God! Look at me. How how do I look in the stream, guys? That seems interesting, guys. Maybe I could make this one even bigger, guys. I don't know. You're not wrong. You have discovered something real. And it has a name. Let me answer why on earth head on. Then validate the beautiful thing you noticed. Why Max so far works, the heart of it. Your first instinct, store the path as an array. Loop over. Store the path as an array, loop over it, was correct for a different question. The trick is realizing what question good actually asks. Is an ancestor on my path? Is any ancestor on my path bigger than me? So, like, I know this is the question. I know, man. Come on. But how should we frame this question? How should we translate this question into something that we can, we can understand in code wise? Like the weather gets hot every day, like it gets hotter every day, guys. Don't forget to drink water. Look at that. Look at that question carefully. To answer it, do you need every ancestor? Yes, I would say yes. Do you need every ancestor? No. You only need the single. Oh, guys, I am enlightened. Guys. Why, you may ask? Because, like, I have solved a few greedy problems. All right, guys. This is like instead of storing all the numbers, all we store is the running sum. Wonderful, guys. Wonderful, guys. So the part I didn't understand in this question was not the recursive part, but instead greedy part, guys. That's quite interesting. and I answered this part. I've said yes, but it isn't. No, no. All right, guys. If the biggest ancestor isn't bigger than, oh yeah, so this is the part that we need to understand, guys. So let me open the stream. All right. If the biggest ancestor isn't bigger than you, then none of them are. If the biggest ancestor isn't bigger than you, so none of them are. So guys, this is the great knowledge that we should have had, like we should have had. All right. This is the greedy part that we should already know. At least for me, guys. Sorry for that. Sorry for that, guys. I guess I'm gonna solve, let's say, 50 greedy problems and then come back here this question again, and then I'm gonna demolish this question so bad that it will scare to exist in leetcode website. All right. If the biggest ancestor isn't bigger than you, then none of them are. The 3 was irrelevant the moment you solve the 4. So the whole array collapses to one number. Collapses to one number, guys. I mean, where is my pen, guys? So the whole array, yeah, collapses, yes. That one number is the only thing the good test can possibly care about. In stats, this is called, oh, sufficient statistics. Oh my gosh, guys. That's wonderful thing to search for, guys. I want to learn what is the relationship between sufficient statistic, I mean this term, and greedy problems. All right, can you make a search or can you teach me? Because in one of the 3 problems I had this concept. Can you clarify? Presenter, go back. Do we have, guys? Do we have? No. I think I should take a screenshot of this part and paste it over here, guys, and even make it colorful, so that even make it so colorful that can be seen from 1 miles ahead distance. All right, guys. I started getting tired. I started getting tired again, so it can be a good time for taking a break now, guys. But I want to finish this question before having a break, taking a break, guys. You never rescan each step at one node, and all right, guys. Here's the part that ties back to the call stack animation you saw. Yes, call stack. You're not really avoiding storing the path. The path is stored. It is the stack of currently open recursive calls. Function 3 is still waiting while function 4 waits while function 5 runs. The chain of pending calls is the root. Oh. Guys, what do you say, man? What do you say, man? Like, isn't it just beautiful? Isn't this just Beautiful. Everyone. Hi everyone. Let's click on save. This is golden knowledge, golden information. Max so far is just a running fold you thread through it as a parameter instead of materializing to array yourself. Essence. Oh, the array isn't gone. The call stack is the array. Max so far is its summary. Oh my gosh, guys. Omai ve mu shindeiru, guys. Omai ve mu shindeiru, guys. We get there, guys. We get there. The rule you can reuse. The path question reduced to a fold, max or mean, sum, count, and or. What you carry down the accumulator, max so far, running sum, the actual sequence. The path and array itself print all. Your array instinct kicks in for the second row. This problem is the first row. Same family, different tool. The beautiful thing you noticed, yes, it is real. You spotted that this problem does not work at two different moments of one DFS. That's exactly right. It's the general DFS template. A node has three positions. The node has three positions. Oh my god. Guys, am I dreaming? Pre-order position. On the way down. Before recursing. Before recursing, guys. Guys. Before recursing, like knowing this is quite important because there are some even harder than, but there are questions that is harder than this one, all right? And in that type of questions, you should know what, like, you should be sure what you are doing. You should be sure about what you are doing, all right? So this is, I think this is one of them because like this includes pre-order one and then the post-order one. Amazing. Like I would like thank God, guys. Like look at it, guys. Let's color it up. Let's color it up, guys. And also I have some secret tag. Let's make it 11th. 11th, guys. Omai wa mushindeiru, guys. I will stop calling you guys. Map your noun problems onto those positions. Invert binary tree, pure post order, trust func left and func right. Then the node's only job is swap and return. No info needs to come from above, so nothing in the pre-order slot. Oh my gosh. Let's take a screenshot and save it up. Save up. Validate binary search tree. Mostly pre-order descending. Yes, like this is pre-order descending, guys. Like this is good knowledge. This is good information, guys. This is good information because if you connect invert binary tree and validate binary search tree, then what you will end up what you will end up is what you will end up with is can't good not problem. And also give me a second because I think I should um oh give me a second. All right. Now I am back. I will take a break after this, all right? So if you combine invert binary tree with validate binary search tree, you're gonna have a beautiful count good nodes, all right? So count good nodes, validate binary search tree carry a constraint down, fused. Oh, like fused with is a good, I guess, phrasal verb. That fusion is the thing amazing. Like that fusion is the thing amazing. You and you name it correctly. Like, is it a good sentence, guys? All right. I think we got it. We got it, everyone. We so got it. We so got it. Got it. Got it. Got it. Wonderful. So let's take a break for 15, or let me first check this one before having even a break. Hmm, 5, 8. I think 15 minutes work. Uh, I'm now taking a break now. Uh, like a mute also. Oh my gosh. See you in 15 minutes. So when I come back, we're gonna continue with our next amazing question, which is maximum width of binary tree. All right. Let's pause the Pomodoro and start 15 minutes break. Take care, guys. See you in 15. Hello guys, we are back. We are so back. Now I hope everything is just fine. Let me open my stream on my phone because somehow all right. Somehow it consumes so much RAM or CPU, I don't know. The stream manager. Everything seems just fine. Let me open even actually it is oh it is still hot. Let's open it, but I don't know, like it is hot guys. I don't know. So let's first start with starting this. All right, and where were we? I guess we were in this very question, guys. Where is yes? So open this leetcode problem. Maximum width I don't know of binary tree. So the maximum width exists in the third level. The width of one level is defined as the length between the end nodes, leftmost and rightmost non-null nodes, where the null nodes between the end nodes that will be present in a complete binary tree extending. Oh my gosh, reading these definitions is soul sucking. It is yes, the width, like I know this question, but I just want to understand what is written here. The width of one level is defined as the length between the end nodes, leftmost and rightmost non-null nodes. All right. So this is the definition basically. Let me take a screenshot and put it here and open our not taking app, and continue here. All right. I guess it is all right. It's just fine. What should we do now, guys? We have a tree. We need to find the width. The width is, I guess, it should be in the same level, right? So how can we recognize if we are in same level or not? I'm thinking maybe we can share a level information while descending. All right, level information, and in each function call, like in each recursive call, like I'm imagining a hash map. I'm imagining like a hash map. Let's say dot get level. I mean, first we should put something, right? Hash map, like a put level, and then the node, I don't know. Like I'm just thinking, all right? Because each node, like, all right, guys. This is about the formulation. Now I remember, like we already mentioned about this. So we have a formulation. Actually, we have used this formulation in heap sort, or somewhere, all right? I guess it was in heap sort, like in heap sort or quick sort, I don't know. We turned 3 into a list, like an array, and there we learned that if the index of this root is k, then the right, like I mean left child is I think this one, like a this, and the right child is 2k plus 2. All right, and now here we're gonna use the same thing. We're gonna use same thing, but how? Like this is from memory, so usually I should be able to come up with this solution first and then think about how I can implement. But since I memorized, at least it is in my memory, I first come up with the solution, and now I mean you got it. Because we need a solution, like we need a way of determining nodes in the same level, and we should be able to calculate the distance between them, so that each node should have an address. All right, let's say xab, and let's say xaf. All right, and we should subtract these and calculate the distance. Let's say this is 1 and this is 4. This is 4. How? Like, what was the question asking again? In the third level? Oh, all right. So there is a node here. Like, we are not counting the nodes. We are counting the real distance, basically, the leftmost and rightmost. So we need the address of this one and address of this one. We don't care about if there are nodes in between these leftmost and rightmost at all. So like this is address of 1, 4. The distance between them is 1, 2, 3. So just but it is not. What is width again? Length of between the n nodes, where the null nodes between the n nodes that will be present in the complete binary tree extending down, that will also counted in the length calculation. So actually we are not counting the distance, but instead how many nodes there are. How many nodes there are, but the like actually this is similar to how many like the number of nodes, but it is not, because like it is not same, because imagine a tree, I mean like this, all right, like this one. So the number of nodes is 2, but it is not that, because this will return again 4. All right, and if it was like that, like this, for example, sorry, about this, then it will return 3. I guess the formulation is leftmost minus, like address of leftmost minus rightmost plus 1. This is the formulation, like for formula. Leftmost, I mean, no, sorry, rightmost. Like we should change these two. rightmost minus leftmost, like address of rightmost minus address of leftmost node plus 1. I mean, I can take a screenshot of it and save it, all right? Yes, actually, yes, here's the formula. Here's the formula. So I guess uh I guess for each level now, like now that we know the formula, our our goal now is, I mean, why the camera is, yes, now it is much better. Now that we know the formula, we should like a way of saving or storing, all right? But how can we? I mean, like, given, like, if we know the address of each node, based, let's assume that, all right? If we know address of each node, then this is the formula to calculate the width. But we are applying, let's say, depth first search, all right? We are applying depth first search. Yes, we are. So my question is that how can we share these their addresses? But I guess it is easy. It is easy because if, let's say, its address, like the root's address is k, and then the left node's address is this, and then the right one is this, and then 4k plus 3, yes, this is the address of this, and 4k plus 5, I guess this is the address of this, and subtract these up, you would get 2, and if you add 1 to them, you would get 3, which is correct because we are counting as if there is a node in between them. So we know, like, so that, like, maybe we can continue creating our beautiful recursive function, all right? We have, let's say, our function over here, and we know the address, let's say k, all right? We should have this, and I guess nothing more. We know the address, but like in it, like, we should have something like this one. So now we can maybe think of how this would work. Like, do we need them to return a value? Do we need these recursive calls to return some value? Actually, I guess no, we don't. Even if we did, what would they return? Like, maybe we also should share the level information. Like, each node should know which level they are in, so that we can collect all the nodes and store them in some sort of list, and find the maximum number and then minimum number and subtract them and store that number somewhere else. But like we know how to calculate the width. We know that we need to, share, I mean, like while calling left, we also should we also should give like a 2k plus 1 and 2k plus 2. Like we need to share this address as well, right? We need to do this, guys. But now I'm trying to find a way to, where am I go? Where are we gonna calculate, like do the calculation of that width? Where? Where exactly, man? Where exactly? Oh my gosh. Like this question should be easy. Come on, man. Like why? At least it is medium. If it was if it were like easy, I would feel bad actually. Come on, guys. We should be able to solve this, man. Come on. Oh my gosh. Like we know that we should do something like this. These are the addresses. All right. So when we call like a func left, all right, and when we call func right, so these nodes do know their addresses. What we need to do for each level, I mean, maybe should we do like a breadth first search or something? I don't know. I guess we should do breadth first search, man. It is like this is, I guess, like because since we need to do this calculation, this computation level wise, this is our friend. This is our friend. So now the new question is how are we doing breadth first? So I guess we were using a while loop and a queue basically, and we were adding like we add the root. Let's say we add our root to our queue, all right, and then we pop I mean, like the thing I remember is we pop the elements, and in a for loop we iterate through them. Like we iterate, yes, through them, I guess. We iterate them. we iterate them over. And while iterating, we add their children into our list so that in the next iteration of while loop, we're going to process them. But I remember that we add this, like we add root into our queue. We start while loop, we pop the root, and I mean we first get the size. Like size is important, so forget about popping. We first get the size of the queue and use that size in our for loop. Size, we iterate. All right, so since the queue size is 1, we iterate once, and while we are iterating, we will add the root dot, like that node's child, like a left child, and then that node's right child. That's all. So that in the next iteration, we are gonna calculate the size again. We're gonna process all the nodes. Yeah. We're gonna. So like this is prefer search. So now at some point we need to calculate the levels number. What I mean is levels width. When we need to do, like when do we need to do? The answer is after. Actually, we pop, like we need to pop them too, right? Actually, let's pop the current element. I mean, let's say node. Pop the current node and add its children to the queue so that in the next iteration they will be computed. All right. And upon we finish adding children for all the nodes in the current level, now it is time for calculate the width. How do we do that? We should know the leftmost and then the rightmost. I guess we can create a list. All right. And add this element into that list. All right, the node. And after we finish, iterate that list and find the leftmost and rightmost, like the smallest one and the biggest one. And then store it. I don't know, like for each level, maybe we should have like a level array or something. And for, let's say, each level, we can store its width. Like, this is my solution. All right. But we didn't use the 2k plus 1, I guess. Yes, we didn't use it. So where are we supposed to use that formulation? That formula? Where are we supposed to use it? How many hours? Almost 11. Almost 11 hours, guys. Let me open Twitch. I feel a little bit tired now. Now, like, I'm thinking, now I'm trying to find a way to use that formula, all right? 2k plus 1 and 2k plus 2. We are using breadth first search, but we didn't use it. Today, yes, it is. Guys, do you have any idea how can we fix this? Breadth first search and using this formula. Because, like, if we were applying depth first search, like since it is recursive, I easily see, like, we could share this knowledge, like, upon calling, all right, upon calling. But now we are I bet you are dead. Welcome, Tar, welcome. No, don't say that. Don't say that. Um like I don't understand. I don't understand why we can't use that refers, like I mean what that formula, man, that formula. Aren't you tired? I am tired. I am tired. Um, but I will feel good if I complete like this question, all right? So my goal today in the morning was completing all the questions up until the question 30. Uh, I have failed at this, but it is all right, all right. It is good enough. Maybe not tomorrow, but the day next, the day after that, I can complete up until to 36, I guess. Uh, like these questions take time. All right. Oh my gosh. Maybe we can ask AI to a little bit guide us. This Mark 41 reminds me of Iron Man. Oh, movie. So, was there something like 41 there too? I really want to. Internalize them. I solve it. Understood fully. I know how they. He had mark on every suit he made. Oh, wonderful. Like there was a suite where he can use underwater, right? And there was a gray one, and there was a the red one, the original. Like I have watched that movie again, and there was a scene where like he was climbing to sky, and the temperature was low, and his parts were getting uh, you know cold. And then he said, how did you solve the temperature problem to the bad guy? So that was the scene where I felt the engineering. uh, no, I have watched it. I will, like, of course, every movie, like I guess there are three versions, right? I love like I love Iron Man actually. Maybe we should ask. Well, I didn't. You didn't. I have no sake to argue. But how? Like, I mean, did you read the, what is that, man? Uh, Not cartoon, but comic books. Like, did you read its comic books? How do you know? I am studying maximum width of binary tree problem, and I guess I should use like a breadth first search, but also, like, we should also share the knowledge of 2k plus 1 and 2k plus 2. They indicate the address of the current node's children, but like I created like the bfs, but I don't see where to put this formula basically. All right. uh, but if I were using, I mean, if I was using DFS, I could easily put these addresses. So, like, where should we do? Activate um, tutor mode 2 and teach me. Strong cross reference. You drilled as heap array indexing, yes. Heap sort sift down session, yes. Same formula. I guess. Uh, oh, we have some important information. Question: are you using voice translate to train cloud? Actually, for not training but dictation. Like, I'm using this application, Voice Inc. It is open source. It is open source, and it is a dictation application. Oh my gosh. I feel tired today, so can you create if like a markdown document somewhere appropriate in our lead code folder? So, and also, can you add it into our, I mean, create a to do or something like this, so that we remember we studied this and we should study it again deeply in the next free time, because I don't have time for studying this right now, but I don't want to lose this valuable information. Can you do that for me? We have studied this problem. Now what I want is saving what we have learned, saving which phases that we struggled with. How should we do that? Maybe uh, we should create a folder, standalone folder for this problem. Can you please do that? And also create like a I guess we also created an animation like a blender. uh, so do we have it? uh, can you check? Because I will end this cloud code session, and I don't want to lose what we have studied, our animation files. All right. Let's see. Because I see something popping out when you talk. Yes, yes. Uh, like I press a button and it starts listening my voice and transcribing what I just say, what I'm just saying. And when I stop, the created text is in my clipboard so that I can paste it right away. Because sometimes I just need to describe something long. So everything is set up, and I can close this session, right? Holy, that's freaking us. Yeah, yeah. It is open source. You can use it too. I just love it. It is open source. Uh, I am making this app, right? Like it is Voice Inc. If you use GitHub, you can download and set it up. It is also there is also paid version of it. Strong cross reference. You drilled as heap array indexing. Mhm. Before before we start, which parts of maximum width of do you already feel confident? Which part? Like like the interesting thing with it is I feel confident about mm, DFS, depth first search part, where like I know that we should share the knowledge of like a 2k plus 1 and 2k plus 2 for our children to locate them basically, because we are gonna calculate width, and uh, to be calculate um, width we need these location coordinates. But I can only imagine this in depth first search. But since we need to calculate level by level, it sounds, or it I guess I should use breadth first search. And breadth first search is like a while loop with Q, and I don't see where I can implement this addressing. You still have 1 hour before you enter stream. I am Linux user, Linux user. I can download anything with one line. Yeah, 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 yeah. You are definitely right. Um, Actually, we can. I mean, voice in GitHub. I guess this is the one that I am talking about. Yes, this is. It is open source and it is just wonderful, man. Uh, yes. Good. That's a clean split. You own the formula and the why. With rightmost index, yes, yes, yes. The fuzzy part is purely in BFS. Where does index live? So let me ask you the one question that unlocks it. Yes, please. In your DFS version, the index travels as parameter. Yes, the recursion call stack carries it for you. In BFS, there is no parameter passing down a call stack. So, what is the thing you are currently putting into your queue? Like, I am putting in my queue the nodes. I mean, what else? What else I can put? No, no, don't worry. I got the repo. All right. like I was adding the nodes itself. What else should I insert into my queue? Like I have a while loop, and in the beginning of it, I get the size of the queue, and I put that size into my for loop as an endpoint, and the I pop the current node and add that node's children to the queue, and after this for loop finishes, I I should calculate the width in the current level. I guess while popping, while popping, we can store those nodes in somewhere and find the minimum and maximum of them and calculate the width basically and store that width somewhere, right? Like this is my idea. I guess like our first thought is correct, but I thought it is like it consumes too much of store, you know. But I guess we just need to do that. Your per level idea is exactly right. First index and last index of the level give you the width. That part solid. Now unlock. You just said it yourself without noticing. While popping, we can store those nodes and find the min max. Min max of what number? Min max of what number? I mean, oh, yeah. So yeah, so this is my question basically. How how can we store that that thing? Not of the nodes of their indices. So when you pop a node, you need its I guess I guess I I guess while adding those nodes, all right, into our queue, before that, let's set their uh, their addresses, like here. I mean, oh my gosh, oh my ve machine de yürü guys. So somewhere here, we can set like this information will be carried on the node itself. All right, think of it as like a node, and like a class node, public class node, and it has, let's say, address. Let's make it even integer. All right. So wonderful, wonderful, wonderful. Thank you for pointing it out. Now I think that before adding these numbers, adding these nodes into our queue, we could just add them. Like, I mean, we can set their field. Let's call it address. Like, let's say we have a node class, and in that node class, let's say we have a field for address. All right. And while we are adding those nodes, before adding, or maybe even after adding, it doesn't matter because we share the reference. So let's say node dot left dot address and set it to, using our formula. Like this approach assumes that root has, like, we can even set our root addresses, root dot address. Like in the beginning of our code, we can set root dot address to k or even 1. All right. I guess this is the way. So guys, now I need to take a break now. A quick 15 minutes break, and I will be back in 15 minutes. All right. Let's give a 15 minutes break. I mean, before that, see you soon. Oh, thank you. I didn't read the chat. Thank you. Thank you, the gambler. Welcome in. Welcome in. I closed the tab on my Chrome because it uses, like, it consumes some RAM, but and also my phone somehow doesn't show. So thank you for stopping by. See you in 15 minutes. Come on, man. Oh, all right. Hello. We are back. We are so back, guys. Now, we figured we figured that we have a beautiful data structure, all right, which is not data structure, but we have it the class, all right, the node class itself, and there we can store some knowledge, like some information there. So as we as we are adding our, let's say, children, like a current node's children to the queue, also set the address attribute of, no, of those nodes, all right, because previously somehow, like, I couldn't imagine how can I share this information, like, because I the only way I know is uh, applying DFS, all right, and there I know how to share the information and um, pass it through. I mean, carrying those information down while descending, all right. And I thought, like, I couldn't imagine how we can do this in BFS, like a breadth first search. But now I realize that we can, like, let's imagine we have a class, like this sort of class, this kind of class, and here let's imagine we have an address attribute in it, and I set my idea to AI. So let's read it, what it says. That's the core insight. The index has to travel with the node, and you found a way to bind them. Yes, bind, like binding is the correct term over here. Let's start this one again, by the way. Conceptually, you solve it. Yes, conceptually. So if it is saying that we conceptually solve it, so there is some missing point. One real world constraint to sharpen it. On leetcode, the tree node, oh, is handed to you. Uh, yeah. So all right. So this is just fine, because instead of using address, we can use value. So I think all right. So we already. Oh no, this value is something else. Like, this value is the node's value. So there is no place for storing the value. Oh, that's bad. That's bad. You cannot edit that class. So your set a field on the node idea can't attach to tree node directly. Given that, how else could you keep a node and its index glued together as one unit inside the queue without touching the tree node class? So if we need to find find another way, uh, like I'm thinking something like a hash map or something. I'm thinking of something like hash map or something, because that should be the way, I think. I mean, key value, all right? Because we can have the node itself, the address of that node, and then maybe as a value we can store the woodwork. Each node is a unique object, so it is valid key. But notice that it costs you. Now you are juggling two containers, a queue of nodes and a separate map, and looking up the map on every pop. Think tighter. Instead of two structures, what if one queue slot carried both the node and its index together as a single bundled value? In Java, what type lets you stick two values into one object so that the whole pairs writes in the queue? Like, I don't know, man. I don't know. In Java, what type lets you stick two values into one object? What type? Like, I don't know, like a tuple or something? I don't know. Tuple or something? Do you guys know which kind of type in Java? Like, we know lists, array lists, um, queues. Which data structures we have? Like a linked lists. Like I know arrays, lists, linked lists, hash map, tree map, um, primitive types, reference type, class. Like these are all things I know, man. What does it want from us? Let's see. You already name it in your own class. So I told you, man. Like what it does, is basically creating another class. So like we could update this one too. So like this is basic, bro. Like all right, we got it already. That wrapper is what goes into queue. Yes. Pop one. Yes. Java also has pair map entry for this. Oh, but rolling your own class is the clearest. Like I didn't know this, but that's all right. So give that wrapper class a name and write its two fields. What do you call it? I don't know. 3 node 2 enhanced enhanced 3 node enhanced 3 node 3 node 2. Like I know that during some interviews they ask you to use or pick good namings for your attributes, for your objects. So what is the correct way of naming this class? I mean, maybe 3 node with index class. What is the profession of naming this class? Because in interviews they really ask, they really ask even the naming. Like they even give point based on how you name your variables. Direct answer. Naming convention question, not an algorithm one. The pro rule, name it for what it represents, not for what it wraps. Like 3 not 2 or enhanced 3 not fail because 2 and enhanced tell the reader nothing about why it exists. What it represents, a node together with its position. So senior idiomatic names, indexed node, adjective are plus noun, reads like English, an index node. Pattern you'll see all over buffered reader, sorted set. All right, so this is something cool. We can save this into our notes, guys. Save it there. Avoid, like I said, enhanced. It says indexed. So, like the type is correct, but the name, like the literal name, is what makes it bad, I think. Um, quick grade on your question. You gave real candidates, contextual. You anchored it interview pressure, hypothetical. You proposed your own guesses first. That's a senior shape. All right, um, so I guess we have solved this question too, guys. Let me take a screenshot and save it because we know that we should apply BFS. Like I don't like. I am tired, guys. Let me open Twitch. Like starting a new question is even harder, but continuing this question is hard too. So what should we do? Like where is my Where am I? Uh, I can't open my profile on Twitch. Can I do this? I think yes. Uh, it's been almost 12 hours, so half an hour left, I guess. It is a good time to break. Maybe a couple of minutes, but maybe we can wrap up what we have just studied today. Or, oh, this is another question that I don't know, guys. Maybe I should just. So we studied this question. Now I want to save our process. All right. Maybe you should create a folder or something, and like I want to save our process. I got tired and I want to take a break right now. What should we do? So thank you for being here, like being together, guys. It was great working together with you. Today we have completed which questions? Three sum, edit distance, count good nodes, and maximum width of uh, binary tree. It took some time, but at least we have studied and understood every part of it, which is great. I guess we have studied this yesterday, right? Not today. And also happy number. Yes, happy number was yesterday's. I said my was yesterday's. So 12 hours for 4 questions. And they're not even fully coded, but almost fully because I know, all right. I can code them. So for each questions, I guess we spent 3 hours. Like this is a lot. This is a lot. We shouldn't be spending more than 1 hour or more than like 1.5 hours, all right? Because otherwise you are spending too much time and it is not efficient. But I don't know, 4 questions and 12 hours basically. But actually, if you extract the parts where we where we took break, I guess we had to add break for 30 minutes and 45 minutes and a few 10 minutes and a few 15 minutes. So maybe we studied, let's say, or 10 hours or 9 hours. 9 divided by 4, 2.5, let's say, or 215. It is good actually, not too bad. But today we solved these questions. Now we are wrapping up. Eden, good session. You derived real insight yourself. So thank you. We save. Let's make sure we save our process. All right. Everything is committed. We also created some animations. Count good notes. So which one of them was for like counting good notes? Because like this animation is good too. I mean, let's click on that. Like this animation is also good. We learned about applying pre-order and post-order at the same time. So this question is amazing. So can you render our animation? Currently on my Blender we have count good notes visual. So I need you to create animation of it and create MP4 and put it into our nodes. All right, can you do that? Press enter. So it means that we have spent 2 hours for each question, and it is I believe it is good amount of time, all right? Not too much. Because I mean you cannot solve it under 1 hour. But my goal is like making me able to solve those questions under 1 hour, let's say 30 minutes or something. So now we are rendering. I wonder what we had like before this, like before um, count good notes, which question we have studied, because we created an animation for that too. I think edit distances. I think we have animation of it. Did we render our animation, and do we have the MP4 in our folder for edit distance problem? I guess we don't, right? Now currently I'm rendering an animation. After we after we have complete it, and maybe we should open that file in my Blender and we should create a MP4. All right, currently the Blender is on use, like is being used, so don't interrupt it. I just wanted to make sure that we didn't render. Now it is rendering our animation, like count good notes. Like this question, like I really love this question, because here you see what happens if you put the process above the function calling, and what happens with you share some variable or parameter in your function call, like a recursive function call. All right. Confirmed, no MP4. And understood. I won't touch Blender or trigger any render now. Your current render keeps running uninterrupted. I won't send any MCP commands to Blender while it's busy. Yes, so wait a second, guys. Let it build the animation and render it as a MP4. After that, I will try rendering this edit distance animation. And then we are gonna end the stream today. Thank you for being here again. I really appreciated it. Let's wait. If you have any questions, you can ask me. I will create some videos on YouTube too, because we study those topics very, focused. I mean, very hard. So it would be great if we summarize, extract the important parts from them, and create standalone YouTube videos, like individual YouTube videos. It would be awesome. So, like now, let's say we are at 41 connected comp. Like this question may take some time. Partition labels, like I don't think this will take some time because I kind of remember it. Oh, like this one I love because I've seen this asked during interviews. All right. So this one another another important question. I have studied earlier, so maybe we can we can solve it fast. All right. So balanced binary tree. All right. I know this. I know this very well. This is easy. We have no question here. Like this is kind of easy. I don't remember this, but we can work this out. The banana change is kind of easy. Like I think we can, like, for the questions that I can call it as easy, we can complete them under 1 hour. Knapsack problem. This is easy. Actually, this problem is quite hard. I hope I will remember correctly, but at least I captured the core idea in this problem. All right. Max path sum. Node can only send one child's path upward. So I don't remember this question actually. This is a hard question. Oh my god. And binary tree diameter. I kinda remember this. Let's see. Oh, this is a good question. This is a good question. This is a good question. Like we should study this. Like I don't remember fully. Question 28. Prefix sum. So we have studied this. All right. Prefix sum. I like actually like after understanding a problem, you should remember, you should review in 1 week, in 2 weeks, in every month. All right. To keep it fresh in your memory. We have heap sort. So we have studied heap sort, but we can study again. Loop detection, cadence algorithm. So we know this. So like before this, we like I already studied this. All right. I know these questions basically. Wonderful. So our goal is continue from 40 next time in the next stream, next leetcode stream. All right. We will continue with like from question 40. These questions are fun, man. I like this one. Like there are some questions that I don't like I don't know the graph questions well, but we can study with using AI as a teacher. But I am happy that we have studied these problems. To be honestly, frankly, I don't remember how we solved this one. Actually, skipping duplicates was the hardest one. Like, did we study this today or yesterday? Welcome, by the way. We are wrapping up and we are planning what we are gonna do in the next stream. Welcome in. So happy number, set matrix zeros. So I genuinely don't remember what we have done for some question. I think we studied it together. Let me check the notes. I guess the finding the duplicates was the hardest, like a pain point. All right. Let me, like, this is DP problem. Yes, this is still DP problem. Still DP problem. Like we studied like this DP problem a lot. Still. Yes, this is some question. I guess we All right, all right. I remember. So I guess we created the code, but like coded. Yes, this is the code we have written. And the hardest part with this was removing the duplicates. Like this was hard. We created an array, like array list, and we store the triplet, current triplet, and also we should get rid of the triplet, like I mean duplicate triplet. So we sorted them using collections. Like this is a we learned that we need to use collections that are instead of arrays that are sort. We sort the triplet, we sort the current current triplet. We checked each characters, and I think this is not done completely. Let me actually we have the code, but let me take a screenshot of it and paste it over here. Like it is not done, I think. It is not completed yet. Like what I was like, I like I suppose like most probably there is a easier way of checking if we have that triplet in our answer. What I am trying to do here is like a checking each character, and if every one of them is same, then uh, we flag it as should that boolean variable as false, so we don't add it and we continue. And maybe like maybe we don't need this here. Can I delete it? No. Maybe we should delete this part. And also I wonder if there is a easier way of doing this or not. Let's now I wanna create the another animation. What is this, man? Oh my gosh. So we created animation for count good notes. Now it is time for the DP problem. I guess this one, right? So now we created animation for the count good notes. Now I need you to render the open the edit distance DP problem and render it. And put it into our nodes. Maybe there should be easier way, but what we are doing is like a comparing each characters, and if every one of them is same with the current temporary file, then we flag, and we flag this for any of them, like among those triplets, if any of them has this thing, we set it to false, and the default value of this is true. I think yes, we set it true. Wonderful. Now we are creating animation for edit distance. We are creating animation for edit distance DP problem. We studied these problems. Now our next problem will be connected components. And it is a graph problem, and I don't know anything about union find or DFS. Like I have studied these before, but I don't remember fully. So then this will be a challenge for us. Like this is 7 days plan. What else we have? Like we have greedy. We have greedy problems. Like I wanna solve these. Like I wanna solve every one of them. I have solved, let's say, 10 or maybe 15 or 20 of them, but I need to solve like a 75 of them or 50 of them at least.